Hello. In this course, you're going to learn how to code by making games in Godot. We will create 7 games in total. A runner game, a platformer, a farming game, a monster battle game, a 3D space shooter, a 3D platformer, and a 3D shooter. All the games will be made in the popular game engine Godot, which is entirely free and super easy to use. By the end of this course, you will be able to create games, and you should feel comfortable coding, meaning you can branch out into other areas like data analysis, AI, or app development. For this course, there are no requirements. I will assume that you have no coding knowledge at all. Although, if you can code already and you just want to learn Godot, you can skip the first part and jump straight into game development. You can get this course on Patreon for £5 a month. On there, you also get all of my other courses and you see future courses early. And if you don't like subscriptions, you can buy this course on Udemy for about $10. Just wait for their super regular discounts. And if you don't want to buy anything, this video contains the introduction to coding and 3 of the games: the runner, the platformer, and the basic 3D shooter. This will teach you all the basics of coding and Godot, so I hope you enjoy. Before we start coding, we need to talk about how video games work to understand what a game engine like Godot does. Fundamentally, any video game is just an interactive movie. Like in a movie, we are playing individual images in sequence. And for some reason, these images are called frames. If that happens fast enough, it looks like a movement. For a movie, that is usually 24 frames per second. For a video game, you want to have at least 30. Now, the difference between a movie and a video game is that video games dynamically create each frame, depending on player input, enemy movement, timers, and a range of other options. So what a video game engine like Godot does is it first calculates where stuff needs to be. For that, it checks player input, the movement of every object, if an enemy was defeated, and loads of other things, whatever you specify. And once all of that was calculated, we are drawing one frame. This we do at least 30 times per second until the game is over. This is how any video game works. So Godot basically is giving you tools to capture user input. It lets you draw images and 3D objects, it can play sounds, and you can use it for lots of other more advanced things, like physics calculations, light simulation, and even online communication. Godot is a really powerful tool, and it is entirely free and open source. To get it, all you have to do is go to godotengine.org and click on Download Latest. The website should then give you the right download link. If you want something specific, just scroll down. Godot works on basically any platform. Just choose what works for you. Once the download is done, unzip and open the folder, and then click on the icon that doesn't say console. You should be seeing a dialog like this. And yes, Godot does not need to be installed. Just keep the downloaded folder somewhere safe, so you don't accidentally delete it. With this dialog, you can manage all of your Godot projects. At the moment, we don't have any. To fix that, you can either create a new one or import an existing project. I want to create a new one. Then you get a Create New Project dialog, where you can give the project a name. Let's just call it Test Project, or whatever you want to call it, doesn't really matter. After that, you get a project path, where you can select where you want to store it. Just choose a good spot, ideally create a folder specifically for your Godot projects. Also keep in mind, Godot is going to create a folder by default inside of this path. If you don't want that, just disable this toggle. After that, we have 3 options for the renderer: Forward Plus, Mobile, and Compatibility. On the right side, you can see a bit of information about them. Forward Plus is going to give you the most options and the best look. I'm going to use this one throughout this entire tutorial. However, if you want to make, for example, mobile games, then you have to account for less powerful hardware and more limitations. Compatibility is mostly for browser games, where you have very limited amounts of hardware power. Now in our case, we only care about Forward Plus. That's the most straightforward one. You can also use version control, but that we don't really care about. Once you have all of that, click on Create. And here we are. This is what you see when you start up Godot for the first time. Now, I will be talking about the different elements in just a second. First of all, though, you can customize this thing quite a bit. For that, you want to go to Editor and then Editor Settings. In there, you have interface and editor, which allows you to customize a lot of different things. For example, if all of this is too small for you, you can set the display scale. The default is auto at 150%, but this you can increase, which you can even push further with a custom display scale. In my case, to make sure all of this is visible, I'm going to set it to 2.5 and then the display scale to custom. That way, we're getting this scale. If you now go to save and restart, Godot is asking if you want to save the current scene, which I do want to do. And then we get the same editor with all of the elements quite a bit larger. Now, in your case, you probably don't have to do that. Just choose something that fits your needs. Most people leave it as it is, which is totally fine. But in my case, lots of people watch these videos on a phone. For those purposes, this thing has to be larger. Besides that, you can go to Theme and choose a custom theme. Under Preset, default is this bluish color, which I wouldn't recommend because blue is just a bit distracting. My default is gray. If you have that one selected, after a second, Godot is going to change the look. And there we go. We have something much more neutral. Finally, if you want to hide the top bar, you can press Shift and F11, and then you are in full screen, which is what I'm going to go with, but in your case, just choose whatever you prefer. Cool, with that, we can start working inside of Godot. Let's talk about the different UI elements. The really big thing right in the middle of the screen is the viewport. At the moment, it's 3D. If you hold the middle mouse button, you can rotate in here. Later on, we're going to explore this quite a bit more, but for now, it's not too important. Instead, if you look at the top, we have 2D, 3D, script, game, and asset library. We are mostly going to work in 2D for now, and in there, we have a 2D space. Besides that, we have script, in which we are later going to have all of our scripts. Then we have game, and finally, we have the asset library, which allows you to download different kind of plugins. We are going to have a deeper look at this later on, but in the most basic sense, it allows you to expand Godot by adding specific tools. And by the way, you can switch between these different modes using the F keys. F1 is 2D, F2 is 3D, and F3 is script. Those are the ones you're going to use all the time. For now, I want to work inside of 2D. Inside of this scene, you can place a whole bunch of elements. Those you usually get from the file system that you can find in the bottom left. By default, Godot has one folder with one image file, icon.svg. This is the Godot logo. To add this to your game, in the most basic sense, all you have to do is drag and drop it into the viewport, and then you have one image that you can move around. And, well, you can also scale it and do quite a few things. I'll talk about this in a bit more detail later on, but for now, I want to undo it with Ctrl Z. While you could simply add a graphic into this viewport, this is not usually how you're supposed to approach it. Instead, you want to look at the scene panel. This allows you to create a scene tree, where we can create a 2D scene, a 3D scene, a user interface, or create another node. If you click on Other Node, you can see all of the nodes in Godot. And nodes in Godot are incredibly important. I'll talk about those in just a second. But basically, in here, we have a whole bunch of nodes that can do different things. The easiest one is a timer, which is just a basic countdown timer. I think this one is self-explanatory. Besides that, we have an animation player, or if you look under Node 2D, we have an animated sprite 2D, which is just an animated picture. We have GPU particles, we have a camera, we have a collision shape, and if you look under collision object 2D, we have, for example, an area 2D that lets you check if something entered an area. For now, don't worry too much about these nodes. I'll talk about them in a lot more detail in just a second. I guess what we can do for now is drag the image back into the viewport, and then you can see inside of the scene tree, we have one node called icon. That's because this file name is called icon. The actual node is a sprite 2D. If you hover over it, you can see type sprite 2D. Once you have that, you can look on the right side. There you have the inspector. This gives you all of the properties of this node. For example, under transform, we have the position, rotation, scale, and skew of this one node. If you change these values, you can see they update inside of the viewport in real time. And in there, you can do a ton of different things and manipulate this node to your heart's content. Although not something I want to do, let's undo all of this. That way, we are ending up right here. Every node has a ton of properties that you could be changing. And being able to change them is pretty much what gives you a game. And alright, with that, we have the basics of Godot. So let's talk about how we combine all of these different elements. To understand how Godot works, you have to understand scenes and nodes. They are the fundamental part of literally any game made in Godot. Let's start with nodes. Those are the fundamental building blocks of literally any project in Godot. They could, for example, be images, timers, sounds, 3D objects, animation players, and really a lot more. Godot has hundreds of nodes. Back inside of Godot, if you click on this plus icon, you can see all of the nodes. There are lots of drop-down menus in here. If you click on them, you can see everything that's available. Now, the way this is supposed to work is that you are combining different nodes inside of a scene. Scenes actually have two purposes. Number one, they are a container for nodes. Or in other words, you're combining different nodes inside of a scene. Besides that, scenes also manage what is displayed inside of the game. For example, a scene could be a level. Imagine a Mario level where you have a fire world, a forest world, a water world, and so on. Each of these levels would be one scene, and you can tell Godot which one to display. Now, this is a concept we really have to practice. So let's have a look at all of this in practice right away. Back inside of the editor, I want to get rid of this sprite 2D by simply deleting it. Godot is going to double check. I do want to delete it. After we have that, I want to create a root node. For now, a 2D scene. This node we can rename to, let's say, first scene. Usually in Godot, you are going with this naming style, where you start with a capital letter, and then you don't add spaces, and instead, you are adding, for the second word, another capital letter. You could add spaces, but when it comes to coding, those can be really confusing. So I would recommend to not do that. This would be our first scene, which I want to save. This you can do either by pressing Ctrl S, or inside of scene, you can save the scene. Then Godot is asking you for the location. I want to keep the default one here. So click on save, and then in the file system, you can see first scene. Also, if you look at the viewport, we have our first scene. And inside of this scene, we have one node at the moment, a very basic node 2D. This is our root node. To this, we can add other nodes. This you do by either clicking on the plus icon or by pressing Ctrl and A. In either case, you get to create new node. In there, you can select any of these nodes. There is kind of a color scheme going on. 2D nodes are blue, and they are inside of node 2D. If you click on the drop-down menu, you can see all of the 2D nodes. Green ones are for user interfaces. In there, for example, we have text and text input. There's quite a bit more in here, but for now, that doesn't really matter. Then we have red nodes. Those are for 3D games. These tend to be a bit more advanced, but for now, it's not too much of an issue. Finally, we have other nodes, and those tend to be white-ish. For example, in there, you have a timer, or you have an animation player that can be used for both 2D and 3D games. I think at the beginning, this can be quite overwhelming, so don't worry too much about any of this. For now, you primarily want to work inside of node 2Ds. And one of the easiest nodes that you're always going to start with is a sprite 2D. And at the moment, I can't find it. Oh, there it is, sprite 2D. Now, most of the time, you don't actually go for this menu manually. Instead, you search at the top. I want to have a sprite, and then Godot is already going to a sprite 2D. This I want to use, so click on Create. Then we have our first scene and a sprite 2D. This sprite 2D at the moment is not visible. If you zoom out, then you can see that, well, we can't see anything. That is because this sprite 2D needs to have a texture, which you can see inside of the inspector. At the moment, the texture is empty. Now, if you click on the drop-down menu, Godot is giving you a ton of options. For example, you could create a simple gradient 2D, and then you are getting something that you do want to customize. So in there, you want to drag and drop the points around, and then you get a proper result. Although not something I want to do, so let's undo it. Instead, you are supposed to drag a texture in there that you're getting from the file system. In my case, at the moment, we only have a single file, icon.svg. Drag this one inside of texture, and then finally, you can see the actual image. And once again, inside of the inspector, you can transform this thing to your heart's content, like you have seen a few minutes ago. Via this system, you can add more and more nodes to your scene. For example, we could be adding another sprite 2D with another Godot logo, and then move the second Godot logo somewhere over here. To make those two distinct, I could go to visibility and then modulate. This one lets you add a color tint. If you click on it, you can change the color quite a bit. Let's make the Godot logo quite red, or really whatever you want, it doesn't really matter. With that, we have two Godot logos inside of the scene. Or in other words, we are building a scene tree. This is effectively what we are creating in here. Now, a really important thing that you do have to understand is that these nodes are related. For example, this sprite 2D is a child of the first scene node, which means when we are changing this first scene, the changes also apply to both of the children. If I go to first scene and then to transform, there we have rotation. If I rotate this node, the children rotate as well. However, if I rotate the child on its own, like this sprite 2D, then the other nodes are not affected. In other words, a parent affects the child, but the child does not affect the parent. On top of that, these two nodes right now are siblings. They both have first scene as the parent, but otherwise they're not really related, which means if you move one, you don't affect the other. However, what you could be doing is attach this sprite 2D 2 by simply dragging it on the sprite 2D, and then sprite 2D 2 would be the child of sprite 2D, which itself is the child of the first scene. Because of that, when we are changing sprite 2D, we are also changing its children. And if we change the first scene, then we are changing all of them as well. I hope this system makes sense. Basically, once a node is a child of another node, it is affected by all of the changes to the parent. A super important thing to understand. Now, besides that, if you want to create a new scene, all you have to do is click on this plus icon. Godot already tells you add a new scene, and then you can create another scene. Inside of this scene, I want you to do an exercise. Create a Godot stick figure by using sprite 2Ds. The end result should look something like this. This should happen via nodes and scenes. Pause the video now and see how far you get. Inside of Godot, I want to create a 2D scene that I want to rename right away to stick figure. To this node then, I want to add a sprite 2D. You can do this either via what you had selected before or inside of recent nodes. Click on create, and then once again, we can't see anything. For that, you want to drag icon.svg into texture. Then we can see Godot. And let's say this part could, for example, be the torso. To make that look a bit more realistic, we want to scale it up by using these points or by going to transform and then increasing the scale on the y-axis. By default, those two scale together. If you want to scale one individually, click on this chain icon and then you can change these individually. Alternatively, you can also drag these points and then change all of this dynamically. This gives us the torso. Attached to that, I want to have another sprite 2D, which should be the head. For this head, once again, we want to add icon.svg to texture. Once we have that, we can't really see a difference. But if you move the head to the side, you can see that, well, the head, because it's the child of the torso, is going to get the same scaling behavior. In other words, if I change the scaling of the torso, we are also affecting the head, which is usually not ideal, but for now, what we can do is simply scale this thing quite a bit down to something like so, and then move it on top of the node. That way, we're getting some kind of a head. Besides that, once again, I want to add another sprite 2D, which you can also do by simply dragging icon.svg into the viewport. That way Godot is automatically creating another sprite 2D with the name of the file you just added, which is not what I want. This should be, let's call it the right arm, which at the moment is not a child of torso, so it doesn't get the scaling behavior applied to it. That's totally fine. This thing, I just want to scale down a bit to something like so. And then inside of transform, I want to rotate it to something like this. Next up, I want to press Ctrl and D. That way we are duplicating the node. And this gives us the other part of the arm, which we want to rotate as well. Let's say something like this. And I guess right arm 2 should be a child of the right arm. That way, if we're changing the upper arm, we are changing this node as well. Next up, I want to add another node. This is going to be the left arm, which at the moment is a child of the right arm, which I don't want. I simply want to drag it onto stick figure, and then left arm is not a child anymore. Because of that, if we go to transform, we can undo all of these changes, and then we get the default Godot logo. And this I want to once again scale down a bit and rotate so it looks a bit more like an arm. Then we can duplicate this thing again, move it here, and transform it just a bit more. Let's say something like this. And then left arm 2 should be a child of left arm. Two more things I want to add. And for that, I simply want to add the other Godot logo. And once again, this should be a child of stick figure. Then I can undo all of these changes. And for this part, I simply want to add a leg. So let's make this a bit thinner and a lot longer and move it down here. This should be the right leg, which we can duplicate and then move it to the side. This would be the left leg. And with that, we have a very basic Godot stick figure. All of this I want to save as stickfigure.tscn. Click on Save. And now, inside of the file system, we have stickfigure.tscn. Looks pretty horrendous to be honest, but I think you get the idea. Now, once we have that, what is super important to understand is that this scene can be added to another scene. For example, to our first scene, we can click on this icon, where we can instantiate a child scene. If you click on it, you can see all of the scenes inside of the project. At the moment, we only have two. First scene, that's our current scene, and then the stick figure, which is what I want to add. If we are doing that, we are getting the stick figure. At the moment, it's rotated because first scene itself is rotated by a certain amount, which I don't want to have. If I undo that, then we have the stick figure inside of our first scene. And I hope you understand how this system comes together, because it's really important to understand. For example, later on, the stick figure would be replaced by a proper player, which has all of the parts that the player actually needs. And then the first scene would be a level. That itself is a scene with all of the parts of a level, and one part of this level is the player itself. So effectively, the scene is going to be what you display inside of the game, and the scene is something that organizes different nodes. It does two things. If you then combine different scenes together, you can create pretty complex projects that are still maintainable, because you only ever touch small parts of it. We are going to practice this sort of system a lot more throughout this course. I just hope for now you understand the absolute basics of it. Two more things that I absolutely want to cover. Number one, let me move this thing a bit down here, this thing here, and this sprite down here. All of this should be inside of this blue frame. This is what you actually see when you are running the game, which, by the way, you are doing via these buttons up here. The most important button is Run Project, or F5. If you click on it, Godot is asking you what the main scene is going to be. You can select one manually, or you can select the current one, which in our case is first scene, which is what I want to do. If you click on it, then the game is going to run, and we can see the stuff that we have just created. On top of that, on the top of this window, we get a lot more things that aren't too important, so don't worry about them. Although the one thing you do want to worry about is the resolution, which at the moment is 1152 by 648. Now, if you resize this window, this can change. You can also go to Project Settings, and then under Display and Window, set a custom window resolution. Although that's not too important at the moment. Besides that, what can be really confusing is the positioning inside of this window. If you click on First Scene, we have a position of 0 and 0. This is in the top left. You can see it via this red cross dot thing. If you click on the first Sprite 2D, this one here, it currently has a position of 151 and 168 for X and Y, or the horizontal and vertical axis. What do these numbers actually mean? To understand them, you have to understand how the window works. The origin point is in the top left. This is position 0 for X and 0 for Y. If you go further to the right, then X is going to become larger and larger until you reach the right side. This at the moment would be position 1152. Or in other words, this for example could be 100, this could be 200, and so on, until we reach the right side of the window. I think this part makes sense. The further right you get, the greater X becomes. On the Y-axis, this gets a bit more confusing, I think. To go down, you want to increase the number. For example, this would be 100 pixels. If you go down a bit further, you'll be at 200 pixels, and if you keep on going down, at some point you reach the end of the window, which I think was 648. This can be sometimes counterintuitive. You want to increase the number to go down. Most game engines work like that, where the origin point is in the top left, and if you want to go up, then you have to go with negative numbers. So this part here, for example, would be negative 100. Especially in the beginning, this can be confusing, but once you work with it for a bit, it does become fairly intuitive. And just to play around with it for a bit, if you have this node selected, I can set the value to 0 and 0. That way, we are right in the center. If I then increase this value for X to, let's say, 50, we are going further to the right. And if I set the Y value to 100, we're going quite a bit down. If I set Y to negative 100, then we are going up. And via that system, you can place different nodes inside of this window. And well, with that, we have the foundation of Godot. At this point, you just have to learn about more nodes that do more things, and you have to learn about GD script to make all of this interactive. To add a script to a scene, you want to have a node selected, and then click on this icon. Via that, you can attach a script. Let's stick with our first scene, and then we can select the language. The default here is GD script, that's totally fine. Then we have inherit. This has to match the type of node that we are working with, and usually you want to stick with the default. The next important field is the path, where we want to save the script that we are creating. Most of the time, you can stick with the defaults and simply click on Create. Once you have that, inside of the file system, we have firstscene.gd. And we can write some code in here. That way, we can create the logic for our game. From this point on, you can continue in two ways. If you don't know any coding, simply keep on watching from here. I will talk about the basics of coding. If, however, you already know some coding, even just a little bit, I would recommend that you skip ahead and start with the first game. If you have done any kind of coding before, you should be good to go already. And of course, you can always go back and look at the coding part. I guess if you are not sure, here are a couple of code snippets that we are going to use inside of the first game. If this doesn't look overwhelming, you can safely skip ahead. Let's get started with coding. And for this part, I will assume that you have never touched a programming language before. Don't worry, it's actually not that hard. In the most basic sense, all that we are doing is create some kind of logic. For example, if you want to move an object to the right, if its position is less than 800 pixels, it would look something like this. We start by creating an if statement by writing if. Then we are checking a value that can change. So this position x could be part of an object that is moving to the right. This we are comparing against a static value, in this case 800. This condition can either be true or false. If it is true, then we are doing the stuff that is indented on the next line. And if that is the case, we're getting the current position x, and we are assigning it a new value, which is going to be the current value plus 5. So we are moving it further in a certain direction. And that's really all we are doing most of the time. The majority of the logic isn't going to get that much more complicated. In practice, this kind of logic can be created in multiple different ways. Godot is actually supporting multiple coding languages. The default one is called GDScript, which is really easy to learn. It is actually very similar to Python, which is one of the most common programming languages. If you know GDScript, you basically know Python, and Python can be used for a ton of other things, like data science, databases, AI, and so on. Besides that, Godot does support other languages, but I'm going to focus on the basics. So we're going to work with GDScript. Once we have that, to actually write code in Godot, you want to attach a script to a node. And via that, you can change the property of that node, like the position, size, rotation, and anything that you can find inside of the inspector. Or in other words, back inside of the scene that we have seen earlier, if you click on this sprite 2D, you can change any of these properties like position, rotation, scale, and skew. You could also change the visibility, modulate, and really anything that you see in here can be changed via GDScript. All you have to do is hover over the property, and then Godot is telling you how you can change it. And there can be a ton of information in here. You can also change other nodes, create new nodes, target other scenes, and even get data from the internet. There's basically no limit to what you can do. Godot is incredibly flexible and lets you do a ton of things. We are nearly ready to start. There's just one more thing that we have to cover, and that is that Godot organizes the code via functions. Functions, in the most basic sense, are just blocks of code. Via those, you are grouping different lines of code together to do a certain thing. For now, we are going to work inside of two functions that are inbuilt into Godot. The ready function, which is executed when a scene is ready. You see in a second what that means. Besides that, we have the process function, which is run on every single frame of the game. And before I start throwing too much theory at you, let's have a look at all of this in practice. Back inside of Godot. This is getting a bit too complex, so I want to create a new scene, which is supposed to be a plain 2D scene. Let's rename this one to Coding 1. This I want to save right away. You could create another folder in here if you click on this icon, but in my case, I'm going to leave it as it is. Click on Save. And now we have a scene with one node coding 1, which is totally fine for now. To this scene, I want to add a script, like we have done before. So attach a new script and leave all of the defaults here in place. Then create. And now to actually do something, we have to work inside of a function. Because remember, all of the logic in Godot has to be inside of a function. To create a function, you want to write the keyword func, and then the name of the function. You can basically choose any name in here, but there are some special names. They usually start with an underscore. If you simply type an underscore, then Godot is suggesting you all of the inbuilt Godot functions. The one that I want to work with is ready. If you click on that, you get ready, then two parentheses, an arrow, and then void. This last part we actually don't need, so you can get rid of it to keep things easier. This would be the most basic way to create a function. You have the keyword func, this always has to be there, then the name of the function, and then two parentheses. We will see later why these are important. If we only type this, Godot is going to complain, which you can see at the bottom, that Godot is expecting an indented block after the function declaration, which means we have declared a function here, and after that, if you press enter, Godot is creating an indented line, which basically means that we are pressing tab, and whatever we are writing next is going to be indented. Having this line being indented means it is part of this function. That way, if we later on create another function, let's call it something, then anything that is indented afterwards is part of this function. Or in other words, via indentation, you can group things together. So what can we actually do inside of this ready function? And well, the most basic thing that you want to do is to print data for now. For that, you simply want to write print and then use parentheses again. After that, whatever you write inside of this print statement is going to be printed out once we are running the game. For now, let's simply write a number, 1, 2, 3. Could be any number for now, doesn't really matter. Once we have that, we want to run this one scene, coding 1. If you simply click on this icon, run project or F5, then nothing is going to happen because earlier we have set this first scene as the main scene, which means no matter where you are, if you are clicking on this icon, you always run the first scene. If you don't want that, inside of coding 1, you can click on this icon here, where you are running the current scene, or simply press F6. If you are doing that, then the game is going to run, and if you look at the bottom, there we have the output tab, and this at the moment says 1, 2, 3. That we are getting because inside of script, we are printing 1, 2, and 3 once the scene is ready. Alternatively, what you can also do inside of project settings, you can go to run and then set the main scene. I guess for now, we can set the main scene to coding 1. Then I can close this dialog and simply run the project. And now we are running coding 1 via F5 or this button. At the moment, we are using two inbuilt functions of Godot. Print is a function and ready is a function. But this might be a little bit confusing because for the first ready function, we had to use func, whereas for the second function, we don't do that. So what's happening here? To understand that, let's talk a bit more about functions. There are two things that we are doing at the moment. Number one is we are creating a function. For that, we are using the func keyword, then the function name, and then we have parentheses that can accept parameters, which we don't have at the moment. That's going to come later. But via those, we could add information to the function. After that, we have indented code with the actual logic. Now, the important thing is that this is only creating a function. It doesn't actually use that function, at least by default. To actually use this function, you have to call it, which is another way of saying that you want to execute the code that you have created. For that, you want to use the function name and then add in arguments, depending on how many parameters you have. Now, in our case, we are creating the ready function. And this function is special because Godot is calling it internally. Whenever we are executing the project, this function is being called by Godot once the scene is ready. So we only have to create it, Godot is calling it for us. But for the print function, it's the other way around. It's an inbuilt function into Godot, so we don't have to create it, we just have to call it. And when we are calling it, we have to add an argument into it. At the moment, this is 1, 2, and 3. And the result of this is that Godot, inside of output, is printing 1, 2, and 3. If you want to display some text in here, you couldn't simply write something. That wouldn't work. Instead, I will talk about later why this doesn't work. But what you have to do is put this inside of quotation marks. Single or double ones would both work, you just have to be consistent. I will use double ones because that's what Godot uses internally, but it's really up to you. If I now run the project again, we get something inside of the output. And that way, you can print anything inside of the output. To practice all of this, I want you to create a new function and call it as well. So now we are doing both things. The new function should print something and 1 to 3. Or in other words, you want to call the print statement twice inside of that new function. And the new function itself, you want to call inside of the ready function. Pause the video now and try to figure this one out and see how far you get. First of all, we want to create a new function. For that, once again, we will need the func keyword and then the name of our function. I guess I should have mentioned this earlier, but this has to be inside of one string of characters. This could, for example, be something. After that, you need the parentheses, opening and closing ones, and then colons. Then inside of the function, we need one level of indentation, like so. Godot should be doing this automatically, and then we want to call the print function and write something. And on the next line, we also want to print 1, 2, and 3. Via that, we have a new function that does two things. We are printing something, and we are printing 1, 2, and 3. But this function, by default, doesn't do anything. If I run the code, the output is only something, which we are getting from this print statement. To actually use this function, you have to call it, which you do by writing the function name, in my case something, and then add the parentheses afterwards, opening and closing ones. If you're doing that, then we're getting something twice and then 1, 2, 3. The first something comes from this print statement, the second one from this one, and then we get 1, 2, and 3. I guess the first print statement should say something else. Let's say test. Then this becomes a bit easier to see. We have test, something, and 1, 2, 3. And via that, I think you can already see a couple of basic things. The most important one is that Godot is executing code line by line. We are starting inside of the ready function, which is called once the scene is ready. In there, first of all, we are calling print and test. After that, we are calling the something function, which is down here. Inside of this function, we are printing two more things, something and 1, 2, and 3. Because of that, we can see test first, then we have something, and then we have 1, 2, and 3. So with that already, we can create a new function, and we can call functions as well, either inbuilt ones or ones that we have created ourselves. In a little bit, we are going to talk a lot more about functions. They tend to be slightly more advanced, and usually you cover other things first. But since Godot executes all of the code inside of functions, I had to cover it right away. So I hope this part isn't too confusing. The only thing that you have to really understand is that you are creating functions via func, the name of the function, and then parentheses. Also, don't forget about the colon. You want to indent some lines, so you know that this line belongs to this function. After which, you can write any kind of logic. In the next part, we're going to talk about that a lot more. To call a function, you want to write the name of the function and then parentheses. Inside of the parentheses, you can add arguments, which we don't have for the something function, the one that we created, but for the print statement, we can add one argument, and this one prints a certain thing. So with that, we have functions. Next up then, we can work on actual logic. Now that we can create basic functions, we can work on logic and variables. And let's start with logic right away inside of Godot. Here we are again, and I want to keep on working inside of coding 1, specifically this script. At the moment, we are only printing test, which doesn't really do very much. So instead, let's do something a bit more interesting. And I guess while we are here, we can get rid of all of this stuff as well, because it's going to be a bit confusing. I only want to have the ready function where we are printing something. And that something is not going to be a word, it's going to be a math equation. And for that, you can simply type something like 2 plus 2, run the project, then you get the result, 4. Other operations would be 2 minus 2, then we get 0. You can also do 2 multiplied with 2, or let's say 2 multiplied with 3. That way we are going to get 6. And finally, you can do 2 divided by 3. Although then we would be getting 0 because Godot is rounding this value. That we can change later. For now, not too important. Let's do 9 divided by 3. That way we're getting 3 as the result. These would be very basic things that you can do via math inside of Godot. And Godot supports a huge range of math operations. The best way to learn about them is to use the documentation. Godot actually has multiple kinds of documentation. There's one inside of the Godot engine right away. If you click on Help, there's Search Help, and then you basically get an overview of all of the parts of the engine. This isn't really a tutorial, it's more of a manual. If you go to Google you can look for GD script reference. That way, the first result should be the Godot documentation. If you click on that, you get a page that tells you all about GD script. It is quite a long page, but in there you have a ton of information. I would recommend to have this page open all the time. It's super, super useful. Right at the beginning, we have an example of GD script, and there are some things that we have already seen. Like, for example, a function with a couple of parameters that we're going to cover later. Besides that, there are loads of things that you haven't seen yet, so don't worry too much about it. Instead, go down a bit further to the operator part. In there, you can see all of the math operations, like x plus y, x minus y, and then you get all of the other operations as well. The only things that you need for now are these operations. Everything else is going to be a bit confusing. But it is still super useful to at least have a look at this page and see what you can be doing. By the end of this course, all of this is going to make sense. Now, using this information is really important, so I want you to do an exercise right away. I want you to calculate Pythagoras' theorem, where side A is 10 and side B is 20. Calculate the output using GD script. Just in case you don't know what Pythagoras' theorem is, you can go to Google and then look for Pythagoras' theorem calculator. Then Google is giving you the formula that you have to write inside of GD script. You're taking the square root of the square of A plus the square of B. Via that formula, you can calculate a side C inside of a triangle simply from knowing side A and side B. So in our case, we know side A is 10 and side B is 20. The result should be around 22. This is what you should be getting. So effectively, what I want you to do is to put this formula into GD script. For all of that, you want to look at these couple of lines inside of the documentation and figure out how to combine them. Pause the video now and see how far you get. Back inside of Godot, I want to print the result like we have seen before, although before that, I want to add a hashtag and then add exercise. If you add a hashtag, then Godot knows this is going to be a comment, meaning the code is going to entirely ignore whatever you write in here, which makes it much easier to document your code. Not something you have to do, but I think in this case, it does make things a bit easier to read. Once we have that, we have to write the actual formula. You can see it in the bottom right at the moment. First of all, we want to get a squared, which in our case is 10 and then squared, which you do by adding 2 asterisks and then 2. That way, you are squaring the number 10. Then we want to add something, which is the value for b, which in our case is 20, which we also want to square. So 2 asterisks and then a 2. If we run the project now, we are getting 500. That is because the square of 10 is 100 and the square of 20 is 400. If you add both of them together, you're getting 500. But now we have to take the square root of all of this. Now, getting the square root might have been one part that is a bit more complicated because there's no square root in any of this. However, what you can do is use the power once again. If you take half the power of any value, you are taking the square root. Or in other words, let me demonstrate it really quickly. We can print 9 asterisk asterisk, so the power of 0.5. That way, we are taking the square root of 9. The result is going to be 3, or at least I hope it is, and it is 3.0. However, now there's another thing that we do have to worry about. If I simply add asterisk asterisk and 0.5, we are not going to get 22. If I run the entire thing, we are getting 120. And to only focus on the value, let me get rid of this one. This value should return 22. Whatever we have seen down here with 22. The reason why we don't see it is because this square root only applies to this value, but we want to apply it to the entire thing. To do that, you want to wrap them inside of parentheses, like so. And let me add a bit more spacing to this. That way it's going to be a bit more visible. We first of all want to do this operation and then take the square root of the entire thing. Via these parentheses, we can control the order of operation. If I now run the entire thing, we should be getting 22 point something, and we do. This looks really good. So I hope this part wasn't too overwhelming. But effectively, we have used different kind of equations and put them together to create a bit more advanced logic. And this logic you can control via parentheses, and that way, with a bit of practice, this should become fairly straightforward. But now, what if we want to make all of this more dynamic, where the numbers aren't always going to be 10 or 20? For that, we have to learn about variables. Variables are basically buckets that store data. You can either read them or you can change the value. This is super useful to keep things organized. And once again, if you look at the GDScript reference, at the top, we have a whole bunch of variables. Let's create some of those. Those you can create outside of a function, and they are just about the only thing that you can create outside of a function. To create a variable, you always start with var. That way Godot knows you want to create a variable. Then you need a variable name. This could, for example, just be a. After that, you want to assign a value to this variable, which you do via equal, and then the value you want to assign, like for example, a10. Next up, we can create another variable, b, and this one can be 20. And now you have two variables, which you can use inside of this equation. All you have to do is replace the 10 with a and the 20 with b. If you run the code now, we are still getting 22 point something. But if I change these variables to, let's say, 20 and 30, then we are getting something else, whatever the output is. Via that system, you can be much more descriptive in terms of what your code can do. So I think just looking at this, it makes quite a bit more sense instead of just having random numbers in here. Although, when you're naming variables, you do want to be careful. There are a couple of things that you have to do. Number one, variable names cannot start with a number, have a space in them, or use special symbols, like the dollar and the ampersand symbol. Those are reserved by Godot. Other than that, you are basically good to go. And by the way, these rules also apply to functions. They basically have the same kind of naming scheme. Besides that, variable names are usually written in the snake case convention, meaning you only use lowercase letters, and if there's a space, you use an underscore. That's what most people use, but it's just a convention. You don't have to follow it. That being said, it is recommended that you do. For example, instead of simply using a, you might want to go with site underscore a. And for b, you want to have site underscore b. Once you're doing that, Godot is complaining because now variable a and variable b don't exist anymore. Instead, they have been renamed to site a and site b. Once you're doing that, Godot is happy again, and we are good to go. That way, the variable naming is also a lot more descriptive. Most of the time, you do want to be quite careful how you name variables. If you mess this up and your code becomes more complex, this can be incredibly confusing. Other than that though, this is basically how you create variables. You create them in the first few lines of the code, and then inside of any function, you can use them as a stand-in for any other number. So at the moment, we are simply reading a variable. Besides that, what you can also do is overwrite the value. So for example, site A can be, instead of 20, 100. After the line, I can print site A again, run the code, and now as an output, we are getting 100. And I think now it's important to understand how Godot is executing the code. It goes through it line by line. It first does this line, then it does this line, and then it does this line. Because of that, for this formula, the value of site A is 20. But on the next line, we are changing that value to 100. And just to demonstrate, let me run the project. The current output of the formula is 36 point something. This is what we're getting from this statement. But if we move side A being 100, one line before that, and run the thing again, then we're getting a different number, 104. That is because now side A is 100, so inside of this formula, side A is 100. But if we update value A afterwards, then this side A is what we're getting up here, 20 in my case. So it's really important to understand how this code is executed. Godot goes through it line by line, and then simply goes through all of these operations. Really important to understand, sometimes this can give you some weird results. Besides that, along with variables, we have to learn about data types. Now, inside of Godot, there are a ton of different kinds of data types. So for now, I am only going to focus on the most common ones. First of all, we have text. These inside of Godot and really any kind of programming language are called strings. You are creating them via double or single quotation marks and then whatever kind of text you want to have inside of them. Besides that, we have numbers. And those are actually two data types. We have integers and floating point values, or simply floats. The difference between them is that integers are full numbers, meaning 1, 2, 3, 20, and so on. Could also be negative, like negative 100. Floating point values have decimal points, like 1.0 would be a floating point value. Could also be 1.5 or negative 2.4. Then we have true and false values. Those are called Booleans. They can only be true or false. Once we get to if statements, those are becoming incredibly useful. Finally, we have different kinds of lists. Those can store multiple values inside of a single variable. Now those I am not really going to touch yet. There's going to be a separate part on them. But there you have arrays, dictionaries, and vectors. I do want to mention them now because they are incredibly important. Really, really common. Variables and data types. You can force a variable to only accept a certain data type. For example, you can tell a variable to only hold integers or floating point values. That way, it would be impossible to assign text to it, which is generally a good idea. It's a good safeguard to make sure a variable doesn't get the wrong kind of data. Although, if you don't do that, variables by default can hold any kind of data. But let's play around with all of that. Back inside of Godot, let's say I want to create a new variable. And this can just be called test. Test should only hold strings. Like for example, some test string. This value I want to print. And this we can do all the way at the end, inside of the ready function. I want to print test. If I now run the project, we're getting some test string. That works pretty well. We are printing this piece of text or this string. However, before this final line, we can assign a different value to test. Like for example, 1, 2, and 3. If I now run the code, as an output, we're getting 1, 2, and 3, which would be an integer, because now we have a full number. If we want to avoid this kind of behavior, what you can do, after naming this variable test, you can add a colon and then tell it to always be a certain kind of data type. For example, a string. If we have that set up, then Godot on this line is going to throw an error that we cannot assign a value of type integer as a string. We are telling Godot that this variable always has to be a string, meaning we cannot assign an integer to it. If we change this to some other string, Godot would be perfectly happy because we still have a string. Besides string, we also have integer. And if I do that, Godot is going to complain on these two lines that we are trying to assign a string to a variable that can only hold integers, which means now this has to be numbers. So 1, 2, 3, or really any other number. Via that, you can be very explicit in terms of what kind of value you are working with, which usually is a good idea. Especially once projects become more complex, you want to be very, very explicit in terms of what values you have. Without that, you can very easily get some random errors that you don't understand. and always having the right data type is a good way to avoid that. Now, this can be sped up quite a bit. If you simply add colon and equal to a certain kind of value, then you're forcing this variable to only hold the data type that is first assigned to it. In this case, an integer, meaning now, if I try to add a different kind of value to test, like for example, a string, then Godot is going to complain because this variable can only hold a type integer, because that's what we first assigned to it. Or in other words, this has to be a string. So with that, we have different kinds of data types. We have integers and we have strings. Besides that, you can also add floating point values like 30.0 or let's say 30.2. Now, both of those are numbers. And if you use them inside of an equation, they would still work. So if I run the code, Godot is still going to execute all of this and we are good to go. But sometimes this difference between an integer and a floating point value does become apparent. We have actually seen this earlier. If we have 2 divided by 3, so the first operation we did, in the beginning, we have gotten a 0 because we are dividing an integer by another integer. And the result is also going to be an integer, which has to be a full number. Godot is actually giving us a warning about that. If you look at the debugger down here, we are getting errors, although in there we have errors and warnings. Yellow ones are warnings. We have an integer division where the decimal part will be discarded. That happens on this line. To avoid that, to get an actual value, you want to have 2.0 divided by 3.0. That way, if I run the thing again, we are getting an actual value, 0.666 and so on. So sometimes using different data types is incredibly important, even for basic math equations. And without knowing the different data types, this kind of behavior would be very confusing. So always make sure when you want to have very precise results, you want to use floating point values, anything with a decimal. The next important part are properties and methods. And those you kind of actually already understand. But let's go through it step by step. So far, we have covered variables and functions. Variables store values, and functions are blocks of code that you can execute. I hope at this point this is reasonably straightforward. But besides that, we have properties and methods. These are also basically variables and functions, but they belong to an object, like a sprite2D, for example. Or in other words, inside of a sprite2D, we have a position, which is just storing the position of that sprite2D. Besides that, the sprite2D has functions that are part of it, like for example look at, and that way you are rotating the sprite2D to look at a certain point. In practice, position and look at are just a variable and a function. But to emphasize that they are part of an object, we are calling them a property and a method. There isn't really that much of a difference. The only thing that you really have to be careful about is that you are adding a dot after the object, and then you can use the property or the method. Once you understand that system, you can actually dynamically change nodes inside of GDScript, which gets you a lot closer to an actual game. So let's have a look. Back inside of Godot, I want to create a new scene where once again, we have a 2D scene as a root node, which I want to rename to coding 2. Maybe not the best name, but it's good enough for now. This I want to save right away as coding 2. After that, I want to assign a script to it called coding 2. That way, once again, we have another script and we still have coding 1 and the first scene. Now, in here, I want to work with a sprite2D, which at the moment is difficult because inside of this scene, we don't have a sprite2D. That, however, we can change by simply clicking on plus and then adding a sprite2D, which once again needs to have the texture, so let's drag it in there, and then we have the Godot logo. As a reminder, inside of the inspector, we can see all of the properties of this object. For example, there we have position, we have rotation, we have scale, and so on. And to be a bit more explicit, this sprite2D is an object, or to be fully precise, it's an instance of an object, which is a fancy way of saying it's one object that we can use inside our game. That means inside of GTScript, we can access all of the properties and methods of the sprite2D. This, once again, has to happen inside of a function. So let's work with function ready. Once again, we don't need this void part to avoid confusion. Let me remove it. I'll talk about later what it actually means. To actually work with this sprite2D, you can simply drag it into the code, like so, and then you can see what Godot actually does. It adds a $sign and then the name of the node that you want to work with. That way, you are getting the object. And on this object, you can add a dot and then get all of the properties. For example, somewhere we should be having a position. This should give us the same position that we can see inside of the inspector, which at the moment is 251 and 169. This value we want to print. So we want to put it inside of the print statement and then run the current scene. Really important, coding 1 is the main scene at the moment, but we want to run coding 2. So you don't want to click on this button, you want to click on this run current scene button. If you're doing that, you can see the Godot logo, that looks good, and you can see the position. Inside of output, we're getting 251 and 169. Exactly what we can see inside of the inspector. Besides that, we can also get the rotation of the sprite2D. Let me run the current scene again. We should be getting 0.0, and we do. That looks really good. So fundamentally, this rotation is a variable. It stores a certain kind of value, whatever we are getting inside of rotation. But it is called a property because it is part of a sprite2D. That being said, it behaves just like a variable, which means we can assign a value to it. For example, the rotation could be 20. If I now run the current scene again, then we're getting an output of 20, and on top of that, the Godot logo is rotated by 20 degrees. Via that system, you can update all of the nodes inside of Godot in real time, which is how you get an actually dynamic game. This would be properties. Besides that, we have methods, which are basically functions that are part of an object. So once again, I want to have the sprite2D. For that, you can either write the $sign and then sprite2D, or you can simply drag and drop the node in there, like so, whatever you prefer. If you now add a dot, Godot is giving you all of the properties and methods of this object. And if you scroll around, you can see there are, well, a lot. The most important ones are usually at the top. If the left thing says .p, you're getting a property. If it says f, you're getting a method. There are a few more. I'll talk about those later. They aren't too important for now. Most of those are properties and functions. One method that is very easy to use is rotate. This is a method that kind of does the same thing that we have done up here. It rotates the node by a certain amount. Let's say 90 degrees, and I want to comment out this line by adding a hashtag in front of it. If I now run the current scene, then you can see the Godot logo is rotated by a certain amount, 90 degrees. And on top of that, we are printing 90 degrees because we are using this print statement. Once you have all of that, you can actually start moving this node2D inside of the scene. For that though, first of all, I want to get rid of all of the stuff that we have done so far, and instead introduce another function that Godot calls automatically. It is called _process. This one is slightly more advanced. Now we have one parameter that we can actually entirely ignore. So don't worry about this part. On top of that, we can get rid of this void, but don't forget the colon. This process is called constantly. Every time Godot generates a frame, it is calling process. Or in other words, if I now print something, this something is going to be printed multiple times per second. So if I run this current scene, we get something a lot. So there you can see the outputs we have, they are increasing very, very fast, which is totally fine. In fact, this is what we want. because now I can grab the sprite 2D and then rotate it by a certain amount. Let's say something very slow, 0.5. If I now run the current scene, then the Godot logo is going to rotate. It is going to rotate quite fast, but that we can control. Let's say 0.1 in here. That way, this feels a bit better. Besides that, we can also move this sprite 2D in any direction. Although for that, we have to target the position, which, if you hover over it inside of the inspector, has a data type of a vector2, this value here. I'll cover this kind of value in the next part. But basically, via a vector2, we get a list that has two values, for x and y. Those we can target via .x and .y. Let's say for now, I only want to have .x. And this value should get the current position of the node. Let me add a bit more space so we can see this properly. I want to assign a new x position to the node that is the current value plus some kind of addition. Let's say +1. And then, if I run the script again, the Godot logo is going to be very slowly moving to the right. If I increase this value to, let's say, 10, and try this again, it's going to be more visible. Now Godot is moving to the right. So with very few lines of code, we can move stuff around inside of the game. By the way, this kind of operation is really common, and there's a shorthand to make it easier to write. Instead of writing all of this, you can simply write +=10. That way, we're getting the current value and adding something to it. In other words, these two statements are doing the same thing, except that the second one is much easier to read. As a consequence, let me comment out the first one. If I now run the game again, we are getting the same result. Most of the time, you are going to use this kind of line. It's just much easier to write. All of this we should be practicing. So, I want you guys to create another moving sprite 2D. This one should move from the top left to the bottom right. And while it is doing that, it should also scale up. Pause the video now and try to implement this kind of logic. I want to add another sprite 2D to the scene. And make sure this sprite 2D2 is not a child of the first sprite 2D. In fact, let me rename it to exercise sprite. That way it's a bit easier to read. This exercise sprite, once again, will need a texture inside of the inspector. Otherwise, we can't see it. Drag the Godot icon into it, and there we go. In the top left, we have the Godot icon. After that, inside of the script, in the process function, I want to add another comment for the exercise. Now, in here, I want to get the exercise sprite and do a couple of things. First of all, I want to get the position.x plus equal, let's say, 5. That way, this sprite is going to move to the right. And to make them a bit easier to distinguish, this exercise sprite under visibility and modulate is going to get a different color. Let's make it really blue, something like so. Doesn't really matter, but it makes it a bit easier to understand. Now we have both of the Godot logos moving to the right. Good start. Besides that, I want to duplicate this line, which I can do by pressing Ctrl or Command, Shift, and D. Besides X of the position, I also want to update position.y and increase this value. Remember, if you want to go down, you have to increase the Y value. If I now run the project again, the Godot logo is moving to the bottom right. We could reduce the speed here just a bit to, let's say, 3. That way, we are going a bit more towards the actual bottom right of the window. Also, in just a bit, we're going to find a better way to update the position, so you don't always have to target X and Y separately. But for now, I want to press Ctrl, Shift, and D again, because besides the position, I also want to get the scale. Now for this one, you do want to be careful. If you add +3 in here and run the thing, then you get some weird behavior. We are scaling this thing up very, very fast. A better way would be to multiply the current value with something like 1.1. Like we have seen with plus equal, multiply equal takes the current value and multiplies it with whatever you write in here. That way, this scaling becomes, well, still quite fast, but a lot slower than before. Let's set this to 1.001. That way, it doesn't grow that fast. I guess you can still kind of see it. Once again, Control or Command Shift and D, and then scale.x. And now we are scaling the Godot logo in all directions. A bit hard to see. Let's do this with 1.005. That way, it should be more visible. And there we go. This is definitely scaling up. With that, we have learned about properties and methods, which are basically variables and functions, but they are part of an object, like for example, a sprite 2D. Once we have that, we can actually do dynamic things inside of the game, which is a massive upgrade. And to get really good at Godot, you want to be able to use as many properties and functions of an object as you can. The best way to learn about them is to go to Help and then to search Help. That gives you, once again, the Godot documentation. In there, for example, you can look for Sprite 2D, double click on it, and then inside of the script view, you are getting the documentation for Sprite 2D. There you can see all of the properties and all of the methods, or at least some of them. If you go a bit further down, you're getting a lot of descriptions in terms of what you can do. Being able to read through here and understand what's going on is incredibly helpful to really get good at Godot. With that, really quickly before we finish, back inside of Coding 2. At the moment, we have a script attached to the parent node, Coding 2 of type node2D. And from there, we are influencing a sprite 2D or the exercise sprite. Here and here. But what if you want to influence the node itself with the script? In our case, this node 2D. Let's say, for example, once the scene is ready, func_ready, then we want to move this node, or in other words, the entire scene, to the right. Well, for that, all you have to do is grab the property of this current node, and you can do that right away. For example, if you want to update the position, you just have to type position without any of the $sign stuff before it. Once again, you just want to look at the inspector and then find the property that you want to change, like position at the moment. This once again is a vector 2, so in there we have position.x, and this we could set, for example, to a value of 200. If I now run the script, everything is going to be 200 pixels further to the right. A bit hard to see. I guess if I change this to 600, it's going to be much more visible. There you can see now everything starts much further to the right. And that's basically the system. If you have the node itself with the script, you simply target the property, or you can call a method. And if you have a child, you target that child with the $sign and then the name of the node. After that, you can call any kind of method or use any property that you want. The next important topic is going to be Booleans and logic flow. Via that, we are going to learn about if and while statements. These allow you to control what code gets run and how often it gets run. Using an if statement, you can run a code once if a certain condition is true. With the while statement, you can run code forever as long as a condition is true. Both of these are really easy to implement, but we have to figure out what is true inside of code. And for that, we have to look at the data types again. Up to this point, we basically only worked with text and numbers. Those at this point, I hope, are at least reasonably straightforward. Next up, we are going to look at Booleans, which can only be true or false. That's the only two options that you have. So let's talk about how to create these kind of values. And most of the time, you are creating them via logical operators. We have smaller than, greater than, is equal to, is smaller than or is equal to, and is greater than or is equal to. All of these operations are either true or false, which is a Boolean value. Now, there are other ways to create Boolean values in Godot, but those aren't that important yet. Although what is important to mention, that you can also combine multiple conditions. Like for example, a is greater than 5 and b is equal to 2. And by the way, if you're wondering why we are using two equal signs for the comparison here, that happens because when you are creating a variable and you assign a value to it, for that, we are using the equal sign already, and we can't use it here and here at the same time. For all of this, I want to work in Godot once again, create a new scene where the root node is a 2D node. Let's call this coding 3 Boolean to add a bit more detail. Then I can zoom in a bit and add a sprite to the scene, like so. After that, I want to attach a script to the scene like we have done before. All the defaults here are totally fine, and then create. Just for testing purposes, I want to create a func_ready. In there, for a really basic if statement, you first of all want to type the if keyword and then the condition that you want to check. For example, 10 is greater than 5, which is going to be true. If that is the case, add a colon and press enter. Then once again, we have an indented line. Via that, you know that any code that comes afterwards is part of this if statement. Just like for the if statement, we have one level of indentation, and that way we know that the if statement belongs to the ready function. Same system, really. Now, if this statement is true, I want to print, let's say 10 is greater than 5. Now I want to save the entire scene. Coding free boolean.tscn is totally fine. Click on save and then run all of this. In the output, we're getting 10 is greater than 5, which is perfect. If, however, I change this condition to 4 is greater than 5 and run this again, then we are not getting any kind of output. This line only gets run if this condition is true. If it is not, then Godot is going to ignore all of this. And to go into a bit more detail, let me get rid of all of this and then print the comparison operator right away. Let's say 4 is greater than 5, which we know is not true. But if I run the script, then Godot is telling me that this is false, and this is a Boolean data type. If I make this a true statement, let's say 7 is greater than 5, and run this again, then we're getting true. Other comparison operators would be an equal comparison, for which you need two equal signs. And for this, let's check if 5 is equal to 5, which it should be. And it is. Perfect. If I change this number to a 2, then this is going to be false. And besides that, we have smaller or equal to and greater or equal to. Besides that, one more that I forgot to mention is this one, which checks if two values are different from each other. So at the moment, we're checking if 2 is different from 5, which it is. So if I run this, then we're getting true. However, if I check 5 is different from 5, then we're getting false because, well, 5 is 5. So with that, we have basic Boolean values and we can use them inside of an if statement. Once again, as a reminder, all you need is if, and then let's say 4 is equal to 4, a colon, and after that, you can run any kind of logic. Let's say print 4. Besides that, what you can also do is via and expand the if statement. So for example, we only want to run this if statement if 4 is equal to 4 and if 10 is greater than 3. Both of these statements are true. That way, we're getting 4. However, if one of them is wrong, then this if statement is not going to run. So if I change the 3 to an 11, then this if statement is not going to run. Both of these statements need to be correct. If you only care about one of them, you can use the OR keyword. That way, only one of those has to be true. So if I run it now, since 4 is equal 4, that part is true, the entire thing is still going to be run, even though 10 is not greater than 11. And that's pretty much it for basic if statements. Although there's one more thing that you can do. Two more things actually. For a basic if statement, let's say if, and I want to have a false statement, 4 is greater than 10. If that is the case, I want to print A. This condition obviously is not going to run. However, if it is not running, I want to do something else instead. That I can do via the else statement. In which case, I want to print B. What is going to happen now is that Godot checks this if statement first. If it is correct, it's going to run this line. However, if this doesn't run, so it's false, then Godot is going to run the else statement and will print B. Or in other words, if I run this now, we should be seeing B, and we do. However, if this statement was to be true, then it would only run the first line, in which case we would get A. You only ever get one of these. They can't run at the same time. And it can be even more detailed in here via the elif statement. This is going to run if this one is false and you want to attach another condition to it. Let's say 1 is equal to 1. If that is the case, I want to print C. And let's make sure the first condition is going to be false. So 8 is greater than 10. They can run the thing again. And now we should be seeing C. And we do. So at the moment, Godot starts on this line and checks if it's true, which at the moment it's not. Because of that, it's going to the elif condition and then checks the Boolean value. In this case, this one is true. So it runs C and then discards anything that comes afterwards. However, if this condition wasn't true, let's say 2 is equal to 1, then Godot is going to print B. So it checks this condition, it's false. It goes to the next one, it's still false. So it goes to else and we're getting B. Obviously, these conditions aren't really that useful yet. But once we start using properties and things like node positions or health values, this becomes incredibly powerful. If statements are being used all the time, you see them constantly. So something we are definitely going to practice in just a bit. First of all though, there's one more way to execute code that you don't see that often, and that is a while loop. This while loop runs code as long as the condition is true, which means you do have to be really careful. If you do something like while 1 is equal to 1, and then you run any kind of code in here, let's say print A. This while loop is never going to stop, meaning any code that comes afterwards is not going to be executed. The code would simply stop working. In fact, if I run this now, we would get a ton of output. So if you look at the console, you can see a ton of stuff, but well, Godot doesn't run well anymore, simply because this line destroys everything. And now Godot has crashed. So when you're using while loops, you do want to be careful. Here we are again, and let's create a while loop that doesn't crash Godot. For that, you want to create a condition that doesn't stay true forever. I think the best way to approach that is by first of all creating a variable. Let's say var a, and this has to be an integer with a default value of 0. This we can make a bit shorter by simply doing this. That way, we have a variable with the name a, and we're assigning an integer to it, and because of this colon, this variable can only have integers. This we want to use inside of this while loop. Let's say I want to check while a is smaller than 10. While that is the case, I want to print the value of a and then also print while loop is running. This would still crash Godot. because a doesn't change. It will always be below 10 because the current value is 0. However, what we can do is a plus equal 1. That way, this condition is going to be false eventually. Let's try to run the scene. We are getting the scene running perfectly fine. Godot doesn't crash. That's a good start. And inside of the output, we are getting 0, while loop is running, 1, 2, 3, and so on. We're getting up to 9, and then the while loop has stopped. That way, we could run code multiple times, which occasionally can be super useful, although in practice, you don't really see while loops. Simply because if anything goes wrong, you are crashing the entire game, and there are better ways to run code multiple times. But once in a while, it does come up and you do want to know what it's doing. That being said, what you really want to practice is the if statement. So let's do that. I want you guys to bounce the sprite that we have created left and right. Or in other words, make the sprite move left and right, and whenever it hits the window border, make it bounce in the other direction. There are a couple of ways of doing that. I guess just get started and see how far you get. First of all, we want to move this icon. I guess we can start by moving it to the right. For that, we will need the func_process. I want to grab the icon, update the position.x, and let's say plus equal 2. If I run the scene, the icon should move to the right. That's a bit slow. I guess we can go with 10. And that looks reasonably alright. Although this number has to change. So if we hit the right side of the window, this 10 should become a negative 10. I think the best way to approach that is to create a var direction, which once again is going to be an integer, and the default value should be 1. After that, I want to multiply this 10 with the direction. That way, by default, with this value being 1, this value keeps on being a 10. Or in other words, we are still moving to the right. That looks good. But if we change this 1 to a negative 1 and run the whole thing again, then we are going left. And we do. Perfect. In fact, what we can do is replace this 10 with a proper variable. Like, for example, speed. This, once again, could just be an integer with a default value of, let's say, 15. This 10 was still a bit slow. And instead of this 10 now, I want to have speed. That way, we can control the speed and the direction of this sprite 2D. And this kind of logic you see a lot, where you have a speed and the direction, and this you apply to some kind of node. We are getting really close to having actual games. But anyway, for now, the start direction should be 1, so we are going to the right. However, on every single frame of the game, I want to check if the icon.position.x is smaller than or equal to the right side of the window, which in this project is under display and window 1152. If you change this number, go with whatever is in here. In my case, I want to check if the icon position.x is greater than 1152. If that is the case, direction should be negative 1. That way, if I run the scene, we are going to the left. And I realized this should be greater than or equal to 1152. That way this should actually work. And now we are going to the right by default, and then we are bouncing and going to the left. Although we never go back. That we can address via another if statement, where we want to check, let me copy all of this, if the current position.x is smaller or equal to 0. If that is the case, direction should be 1 again. And if I now run all of this again, the sprite 2D should bounce left and right. And it does. That looks pretty good. And alright, with that, we have if statements and while loops, but most importantly, if statements. Next up, we're going to work with data. Once again, Here are the most common data types I have talked about earlier. At this point, we have covered the first three, so we should be good on those. So finally, we can work on arrays, dictionaries, and vectors. Vectors is what we're going to start with, because those you are going to use the most. Vectors are basically a better way to store numbers. We have vector 2s and vector 3s. Now technically, there are also vector 4s, 5, 6, and so on, but we only really use vector 2s and vector 3s. For a vector 2, it just stores two numbers, vector2.x and vector2.y. If you have a vector 3, then you have x, y, and z. Other than that, they work in exactly the same way. By that system, you can store, for example, positions incredibly easily. On top of that, vectors are really useful because of vector math. The most common example is when you multiply a vector 2 with an integer, or a float, doesn't really matter. In that case, you are multiplying both values. So the 5 becomes a 10 and the 2 becomes a 4. Both were multiplied with 2. Besides that, you can add two vectors to each other. That way, you are adding the x part, so in this case, the 10 and the 1 together, and the y part, the 3 and the 2. The end result would be 11 and 5. There are a few more examples of vector math, but we get to those when we make the actual game. Finally, vectors have a ton of methods that are incredibly useful. And I guess let's have a look at all of those in practice. Once again, back inside of Godot, I want to create a new scene with a 2D root node. Coding for data. This I want to save right away in the usual folder. And also attach a sprite to this scene, so we can work with something. Finally, I want to attach a script to the entire thing, create, all the defaults here are fine. And then I want to work inside of the ready function. And for now, print the position of this icon. Drag it in there, and then look for the position. If I now run this script, as an output, we are getting the values 327 and 310. This is a vector 2. Or in other words, if you look at this icon, the sprite 2D, under transform, you can find the position. And if you hover over it, Godot is telling you the data type. It is a vector 2. Which means on this vector 2, we have two values that we can access via x and y. If we go with x, then we are going to get the first value, 327. Let's just try that. And there we go, 327. And of course, you can also create new vector 2s via a variable. For that, you want to create a new variable. Let's call it pos for position. And then you simply assign it a vector 2. And inside of Godot, we have vector 2 and vector 2i. The I means that you're only getting integers as a value. By default, you're getting floating point values. Most of the time, you are simply going to go with vector 2, 3, or 4, depending on how many values you need. The integer version isn't really that common. It's very specific, and we're not going to use it. You want to have parentheses, and then you can set the x and the y value. Let's say 200 and 300. This would be a very simple vector 2 that we can use to, for example, update the position of the icon. Icon.position is going to be the pos variable. If I now run all of this again, then we have moved this logo around. So if I change the number from 200 to 500, run all of this again, then the Godot logo should be roughly here. And it is. Perfect. And that's pretty much all you have to know for the absolute basics of it. You can create a vector 2 by simply writing vector 2 and then you assign the values to. Besides assigning values, you can also add dot, and then you have, for example, down, left, 1, right, up, or 0. Those are simply pointing in different directions. If you, for example, have right, you would get a vector 2 with 1 and 0. Meaning in a 2D space, you'll be going to the right by 1 unit. And remember, in the last part, when we try to move the icon around, We could do that on the x-axis quite easily. But now, via vector 2, we can do it in any direction. For that, and this is something you see all the time, you want to use the process function get icon.position and then add the position. Although a better name for that would be the direction, because this is what this thing is effectively. Then we can get rid of the ready function. We don't need it anymore. And instead of position, this is going to be direction. This at the moment would move the Godot logo, but it's also going to be very, very slow. But let's try. There we have the Godot logo moving to the right. If I change this vector 2 to, let's say, 1 and 1, we're going to the right and we're going down. Remember, to go down, you have to increase the y values. And there we go. We are going down and right. On top of that, what we can do, because of vector math, we can create another variable, let's call it speed. And this can be a basic number like 20. This I can multiply with the direction, and then we are still going in this direction, but now at a much higher speed. Inside of the game, that is looking pretty good. And just to demonstrate how this would be working, if I print another vector 2, so vector 2 right away, with the values of 2 and 3, I can multiply the entire vector with, let's say, 3. Then we're going to multiply this 2 and this 3 both by 3. As a result, we will get 6 and 9. Let's try. There we go. We are getting 6 and 9, both of which are floating point values because a vector 2 always stores floating point values. Unless you add vector2.i, then you would get integers, which you usually don't want. And well, that's pretty much it for the basics of vector 2s. Especially for positioning, they are incredibly common. We have 2 more data types, and the easier one is arrays. This is just a list that stores values. It would look something like this. You can have any kind of data type in here. Any kind of number, strings, booleans. You can even have an array inside of another array. Via that, you can store any number of data points. And if you want to get one value, you are doing an indexing operation, which simply means that you are adding square brackets afterwards, and then you define the index that you want to grab. The index always starts at 0 and then goes up. The first value would be index 0, then you have 1, 2, and so on. Which means if you have square bracket 0, you're getting the first value. If this was a 1, you'd be getting this value. And that's pretty much it. You can also loop over all of the values inside of an array. For that, you would need a for loop. You start with the keyword for, and then you define a variable. Very often this is called I, but you can call it whatever you want, as long as it's a valid variable name. And then you need some kind of array. Now, inside of the code that has to be indented, we are running the code for every single value inside of the array, and we are storing that value inside of the variable while we are running it. That way you can grab every value and work with it. But let's do all of this in practice. And for that, I want to create a func ready once again. To create an array, you simply want to, let's say for now, print, then square brackets, and then any kind of value. Let's say 1, 2, and 3. We can have a string. We can have a Boolean value that you can create directly. All you have to type is true or false. And finally, you can add another array into an array with values inside of it, 1, 2, and 3. If I now run the script, we are getting inside of output all the way in the beginning, the array. And that's really all we need. And I guess while we are doing this, let me comment out this line so we only see one output. I hope the system here makes sense. You simply have square brackets and then values separated by a comma. There's no limitation on data types or number of items in here. It's a really flexible system. And if you want to grab one item, after the array, you are adding square brackets and then the index. For example, 0 would give you the first item. You always start counting from 0. which sometimes can be a bit confusing, but you get used to it. Pretty much all programming languages work like this. But now, if I run all of this again, we are getting 1, which is this integer here. If I set this to 3, we're getting 0, 1, 2, and 3, meaning we would get the string. At least if I can count right. And we do. That looks good. Once again, I think this operation is pretty straightforward. I guess one thing that you can do here is count from the back via negative numbers. -1 would be this last item. -2 would be false, -3 would be the string, and so on. You basically go backwards. We're getting the array as an output, or to be a bit more specific, the array inside of the larger array. That works pretty well. Besides that, what you can do is a for loop with for I in, and then I want to grab this array. Let's actually store it inside of a variable. Var, let's call it test array, and then this value. Or any kind of array, it doesn't really matter. This we can replace here. Test array makes all of this a lot more readable. And also for I in test array. Don't forget the colon. And now, Godot is going to go through every single value inside of this array. And it's going to store it inside of this I variable. Which means, inside of the for loop, we can print I, and we would be getting every single one of these values. Let me run it again. Inside of the output, we're getting this 1, 2, and 3 because of this print statement. But after that, we're getting 1, 2, 3 string false and the array 1, 2, and 3. We went through every single value inside of this array. By that system, you can loop over the array and do pretty much anything you want in here, which is a fairly common operation. And besides arrays, we have dictionaries, which are pretty much arrays, except now we have key value pairs. This system looks like this. We have curly brackets, and then we always have a key, a colon, and a value, with the key value pairs being separated by commas. On top of that, both the keys and the values can have any data type. Our first key value pair is this one, where the key is the string A and the value is the integer 1. The same system applies to the second key value pair, but for the third key value pair, the key is the string C and the value is another string called test. Finally, for the last one, the key is the integer 4 and the value is an array, all of which would be totally fine. Like for the array, you can still do indexing. Although this starts to get a bit messy to observe, but effectively we have the dictionary here, and then we have square brackets with the key that you are looking for, which currently is this key here. The output is then going to be the associated value to it, the 1 here. And this is what we're getting. Also, like for an array, you can use a for loop. With for, then the variable name, in, and then the dictionary. Then you cycle over the dictionary. Although for that, you do have to be a bit careful, but let's do all of this in practice. I am inside of the code, and I want to create another variable. Test dictionary. To create a dictionary, you want curly brackets, and then the key value pairs. Let's say A could get a value of 1. Then I can have a key called 1, 2, and 3, with the associated value being an array with 1, 2, and 3. And finally, you can even have a key like true, the Boolean value, where the associated key is, a string. Let's just call it string. For keys and values inside of a dictionary, any data type is fine. Although I guess what I haven't mentioned is that these keys need to be unique. You cannot have duplicates in there, which means using something like a Boolean value is usually a pretty bad idea, but you could do it. Once you have that, and let me comment out the stuff that we have done for the array. Oh, and by the way, if you select multiple lines of code, you can press Control or Command and then the /. That way, you're commenting out multiple lines of code. Super handy. I want to print the test dictionary. If I now run the current scene, we are getting the dictionary that we have just created. and this stuff should have been commented out. You get the idea. We have a dictionary where we have key value pairs. And these keys you can access via indexing. For example, if I add square brackets and then the key 1, 2, and 3. That's this key here, and the associated value is the array 1, 2, and 3. So if I now run all of this, the value that we are getting is 1, 2, and 3. With that system, you can store data and be much more explicit what it's about. Having too many values inside of an array can be a bit confusing. So sometimes using a dictionary is much more elegant and much easier to understand. Besides that, like for a dictionary, you can use a for loop with for I in test dictionary. And then for now, I just want to print I. And let's see what we get. And to not make this confusing, I want to comment out the earlier print statement as well. So the only output that we are getting is from this for loop. Let's run it. There we go. As an output, we're getting A, 1, 2, and 3, and true. If you compare this to the actual dictionary that we have created, you can see that we are only getting the keys. We're getting A, 1, 2, and 3, and the Boolean value true. If you use a for loop with a dictionary, you are only getting the keys returned, which sometimes can be what you want, but very often not really ideal. To customize that, every dictionary has a couple of methods that let you customize how the for loop is going to work. By default, you're getting the keys. If you don't want that, you can use values. That way, this for loop is going to cycle over the values inside of this dictionary. Let's try. And there we go. Now as an output, we are getting 1, the array 1, 2, and 3, and string, which is the values inside of this dictionary. So that is something you do want to be careful about. Using a for loop with a dictionary can either get you the keys or the values. Now, most of the time, we are not going to work that much with data. So arrays and dictionaries aren't going to be a common thing that we will work with. But once in a while, they are very handy. The most important thing that you want to practice, though, are vectors. Those come up all the time. For that, I want you guys to make a sprite bounce in all directions. The sprite should move via a vector 2, and it should bounce on every single window border. Pause the video now and try to implement this one. You will need a vector 2 and if statements for all of this. Back inside of Godot, I think just to keep things organized, I want to add another sprite 2D to the scene and rename it to exercise sprite. After that, inside of the process function, I want to create another variable, and all of this is for the exercise. I want to have an exercise direction, which is going to be a vector 2. That, let's say, by default is pointing to the right, so x is going to be 1, and is going to point up. Y is going to be -1. This variable should only hold vector 2s, which you can do by defining the vector 2 as the data type, or simply do this operation. That way, the first value assigned to this variable is a vector 2, and afterwards, it cannot change the data type. Besides that, I want to have an exercise speed, which is going to be an integer with, let's say, 30. After that, inside of the process function, I want to get the exercise sprite and update the position. To this value, I want to add the exercise direction multiplied with the exercise speed. And now this line is getting quite long, which makes it a bit hard to read. If that's an issue for you, you can click on this button. That way, you are expanding the code window. Quite handy sometimes. Let me try to run the code. The Godot logo should move to the top and to the right. And there we go. We are moving in the right direction. Although we are not bouncing, which is the whole point of the exercise. We can check if, and I want to get the exercise sprite position dot y is smaller or equal to 0. If that is the case, I want to get the exercise direction and update the y value. This one should now be 1. That way, and let me reduce the speed just a bit to 20, we should be bouncing. There we go. We are bouncing once at the top of the window. And effectively now, we have to duplicate this thing once and check if the logo is exceeding the value 648 or whatever you have set as the window height. The default is 648 if you haven't touched this value. If that is the case, exercise direction.y should be -1. Then we can duplicate all of this and then change position y to position.x. If position x is smaller than 0, we are on the left side of the window, which means exercise direction.x should be 1. If the position is greater than 1152, then we are on the right side of the window. So the direction.x should be negative, meaning we are going left again. And with that, we should be done. There we go. This looks like a pretty good bouncing. It is time to talk about functions in a bit more detail. Along the way, we are also going to talk about scope and return. Really important concepts that you have to understand to actually understand functions. But let's go through it step by step. We have already seen that you can create and call functions. Creating functions looks like this. You start with the func keyword, then you add the name of the function. Afterwards, you add parentheses with the parameters that we haven't done yet. Then you have to add a colon, after which you have the indented code with all of the logic. That way, you are creating a function. To actually use the function, you have to call it, which basically means you want to write the function name along with parentheses, and inside of the parentheses, you can add all of the arguments. That way, the function actually does something. We haven't actually created any parameters. So let's have a look at that. As always, here we are back in Godot, and I want to create a new scene. Just as before, this is going to be a 2D scene that I want to rename to coding 5 functions. Let me expand this just a bit, like so, and then save the entire thing. The location doesn't really matter, so click on save, and then we have a scene that we can work in. All I want is some code, so I want to attach a script to the node, click on create with all of the defaults, and then we can write some code. For now, I want to create a function that we can just call test func. That would be the name of the function, and afterwards you need parentheses and a colon. Then inside of the function, you have to write the logic that you want to execute. Let's do something simple. I want to print test function. And that's all that this function does. With that, we have created a function. And this we have done a couple of times by now. However, if I execute this one scene, nothing is going to happen. We don't get any output. That is because this function does not get executed. Or in other words, it's not being called. The functions that do get called automatically are functions that start with an underscore. Like for example, func_ready. This function gets called by Godot once the scene is ready. Which means what we can do, inside of this function, we want to call this function. We simply have to do test func, then parentheses, opening and closing ones, and then we are calling all of this code. Which means if I run this one scene, inside of the output, we are getting test function. This part should still be super straightforward. We have done this a couple of times already. But all of this we can expand. Most importantly, by adding parameters. That means inside of the parentheses, you can add parameters. For example, parameter_1. Simply by doing that, Godot is already going to complain that, let me expand this, there are too few arguments for the test function call. Godot expected at least 1, but received 0. Or in other words, there's now one slot that we have to fill when we are calling this function. This at the moment could be any kind of data type. I could, for example, write 1, 2, and 3, and Godot would be happy once again. Also, let me fix my typo. This should be parameter 1. This parameter 1 becomes a variable inside of the test function. The value assigned to this variable is what we have added as an argument when we are calling the function. Or in other words, I can print parameter 1, run the scene once again, and as an output, we're getting 1, 2, 3, the value that we have added when we called the function. With that system, you can make your functions much more flexible. And you can also force a certain kind of data type. All you have to do is add a colon after the parameter and then define the data type. For example, right now, I only want to allow integers for this data type. That way, if I change this to, let's say, a string that says something, doesn't really matter, then Godot is going to complain, you cannot pass a value of type string as an integer. This function only accepts a single parameter that has to be an integer. Let's change this back to 1, 2, and 3. Although you can also add multiple parameters. Let's call this one parameter 2, which can be a string. And then Godot is going to complain once again. So now we have to add a second argument, which now has to be a string. And once again, Godot is happy. And to actually use parameter 2, what I haven't covered yet is that when you're calling the print statement, you can add multiple arguments as well. For example, we can add parameter 1 and parameter 2. Then, if I run all of this again, we're getting 1, 2, 3 and string all combined. If you want to have a space between the two, simply add one more argument with a string that has one space inside of it. That way, this looks just a bit cleaner. And effectively, those are parameters and arguments. Parameters are slots inside of a function that you can fill with arguments, and that way you are giving them a value that you can use inside of the function. Super handy. Finally, you can give a parameter a default value. Let's say for parameter 2, we want to have a default value, and that you do right after a default value of test. That way, if we don't give an argument here, then Godot is going to use this value. Or in other words, I can run the entire thing again. We're getting 1, 2, 3 and test. Godot used this value for parameter 1 and this value for parameter 2. The one thing that you always want to be careful about is that these parameters are organized via their position. This is the first parameter, so the first argument is going to go to this parameter. Then you have the second parameter, and the second value would be for that one. So second would be here. Always be careful about that one. The position of these parameters and their arguments are really important. It's the only way to really link them. But other than that, this is basically as complicated as it gets. If you understand it, you understand functions reasonably well. That being said, there are two concepts that are really important that can be quite confusing. The first concept is scope. Or more specifically, you have a global and a local scope. What that means is, inside of a function, you can create variables. But if you create a variable inside of a function, it only exists in that function. Or to be a bit more technical, the variable exists in the local scope of the function. Variables created at the beginning of the script are in the global scope, meaning they are accessible everywhere. Inside of this test function, you can create variables. This happens in a normal way. You type var and then the name of the variable. Let's call this one the local variable. This could be any kind of data type. For now, let's go with local var. Once you have that, you can use this local variable like any other variable. You can print it, you can change it. Let me just print it and run the script. We're getting local var, so that looks good. We have a variable like any other. However, inside of the ready function, this variable does not exist. If I try to print it here, print local underscore variable, Godot is already going to complain that the identifier local variable is not declared in the current scope. What that means is that this function has a scope and this function has a scope. And local variable only exists inside of this test function. It does not exist inside of the ready function. I guess an easier way to think about it is that every single function is its own box. Inside of this box, you have a ton of logic, and you can create variables. But these variables only exist inside of this box. If you create another function, this function would be another box with its own content. That's really all that local scope means. Variables created inside of a function are only available in that function. However, what you can do in the beginning of the script is create a variable, and this is what you have already seen. Let's call this one global variable with the value global var. And this global variable is available everywhere. We can print it inside of the ready function, and we can print it inside of the test function. It would work in both of them, so we're getting global var twice. First from this print statement, and then from this print statement. The reason why the system exists is that functions should be self-contained. All of the logic in here shouldn't connect too much to stuff outside of the function. It really helps to have modular logic, where a function does its own thing and simply gets its data via the parameters. If you get too much data from other sources, things can get really complicated and confusing, so be careful here. And with that, we have covered scope. Next up, we have to talk about return values. This is how data is moved around. And also, you can specify what kind of data a function returns. Something that I haven't talked about yet is this arrow and then void. This defines what kind of data this function returns, and void means it returns nothing. This part actually isn't necessary. If you get rid of it, nothing would happen. But you can make it useful. For that, I want to create another function. Let's call it function return something. No need for any parameters, but I do want to return an integer once we're calling this return something function. After that, you need a colon, and then we can print return something function was run. However, now Godot is still complaining that not all code paths return a value. Effectively now, Godot expects when this function is run, it returns a value, specifically an integer. To get that, we need the return keyword, and then some kind of value that we want to return. For now, let's go with 100. And then Godot is happy again. If I print return something, really importantly with the parentheses, so we are calling the function, I can run this script, and we're getting 100. And I think it's important to understand what happened here. Let's go through it step by step. Inside of this print statement, we have called return something, which means Godot is looking at this function. First of all, it is going to print some kind of string. Doesn't really matter what it is. After that, we are returning the integer 100. Or in other words, this function is replaced with 100, or whatever was returned in here. This 100 is then being picked up by the print statement, and Godot prints out the value. Effectively, this return something function, after it is called, gets the value of this 100. We could even change the value. For example, you could multiply it with 2, rerun the script, and now we're getting 200. Programming languages, when it comes to this kind of system, are super flexible. And generally, understanding how return works is really, really important. It pretty much defines how data is sent across your code. For example, here is a slightly longer line of code. First of all, we are creating a vector2 that has an x value of 3 and a y value of 4. This would be the first value that gets returned. After that, we are calling a method on this vector, where we're getting the length of the vector, which means the returned value from the vector gets changed to something else. After that, we are multiplying the entire value by a factor of 2. Or in other words, the thing that was just returned, this value here, gets changed once again, and we're getting something else. After that, all of this gets passed into the str function, which turns any value into a string. Which means this becomes, once again, another kind of value. Finally, via the print function, we are printing this final value. This does look a bit complicated, but once you play around with it, it becomes really straightforward. You always have to go from the innermost part to the outermost part, and then work through it step by step. Getting used to all of this will take you some time, but not that much time. You'll be fine. For now, the one thing that you really have to understand is that when we have this arrow at the end of the function, we are defining some kind of return value. If that is the case, inside of the function, you have to return some kind of value at the end of it. And all of this should be practiced. So let's do an exercise. I want you to create a calculate function. It should look something like this, where you can add two numbers and then the operation as a string. There should be plus, minus, divide, and multiply. The correct answer should be returned, which means inside of calculate, you shouldn't use any kind of print statement. You simply want to return the final value and then print that return value. Pause the video now and see how far you get. I want to create a func calculate where we have three parameters. Let's call it number 1, number 2, and the operator. All of those should only accept a certain kind of data. For number 1 and number 2, let's say, to keep it simple, this should only be integers. Whereas for the operator, this should always be a string. The return value, once again to keep things simple, should also be an integer. And just to test if things are working, I want to check if the operator is equal to plus. If that is the case, I want to return number 1 plus number 2. And if that is not the case, else I want to return, let's say, 0. That way, inside of the ready function. And let's comment out all the other stuff so this doesn't get confusing. I only want to print the return value from the calculate function, where for now we are doing 1 plus 2, like so. And then we should be getting as an output the number 3. And we do. That looks good. Although this logic here doesn't work terribly well yet. That we have to work on. First of all, I want to create a local variable called result. This is going to be an integer with a default value of 0. And this is the only thing that we are going to return at the end of the function. In between that, via if statements, we are going to do the actual math. So let me copy and paste this in there. First of all, I want to check if the operator is plus, then the value of result should be number 1 plus number 2. If operator is equal to minus, then result should be number 1 minus number 2. And I think you get the pattern. If operator is equal to multiply, then result should be number 1 times number 2. And finally, else this has to be divide, so result is going to be number 1 divided by number 2. And that is pretty much all we need. We have a couple of parameters inside of the function. Then we create a local variable, and we're adding a whole bunch of logic that assigns a value to the result. At the end of the function, we are returning one value, and that one value is being printed out. This should still give us a 3. Let's try. That looks good. We're getting a 3. And if I do 10 minus 3, then we should be getting 7. And we do. That looks really good. I suppose one thing that you can do is give the operator a default value of plus. That way, if we only give it 2 numbers, like so, then we're going to add them together by default. Let's try. We should be getting 13, and that looks good. All right, perfect. With that, we have basically all you need to know about functions. And by the way, inside of Godot, the default style guide tells you that there should be 2 spaces between functions. Not something you have to do, but something that you usually see. It's just to keep your code a bit more readable. Anyway, with that, we have another super important concept. Alrighty, let's get started with the first project, where we are going to create a Frogger-style game. Obviously, this isn't going to be the most sophisticated game. However, it is going to teach you all of the important parts of Godot, like using scenes and nodes, using GDScript, and using all of this to create logic. By the end of it, you should already have a pretty decent idea how Godot works on a basic level. Now to get started, for the first part in this project, we are going to create a very basic outline, where we have a player and the background. Or to go into a bit more detail, we want to create a basic game scene, and then place the player inside of it. On top of that, we want to move the player by just a bit. Although for now, this is going to happen without input. That's going to be the next part. Here we are in Godot, and at the moment, we don't have any kind of scene inside of the engine. That being said, if you look at the file system, we have a couple of folders. Most importantly, we have graphics. In there, we have, for example, the player, a simple version, and a tile set. We're going to come to that later. Then we have a whole bunch of objects, and so on. We also have fonts and audio, but those aren't too important. Now, to get this project, you want to look at the video description. In there, you can find a link to a Google Drive folder, which is going to look like this. In there, you have the project files for every single game. For example, right now, we are working in the Frogger game, and in there, you have the Frogger project setup and the Frogger start files. The second one you want to download, so download, and then your computer should be downloading the entire thing. Inside of the project stages, you're going to find this, by the way, the finished code for every single part of the game. If you get stuck somewhere, you can use that to figure out what went wrong. Should be quite helpful. But much more importantly, the file you just downloaded is going to look like this, and you want to extract it in the usual way. Then you're getting the Godot starting files. Right now, this is just a folder. To import the entire thing into Godot, you want to open the editor, and then you can simply drag and drop the files. From the folder, the one you have just downloaded with all of the stuff inside, just drag it in there, and then you're good to go. Open this one, and you should be seeing the project. Alternatively, you can go to Import, and then navigate to where you have to be, which in my case is going to be the Downloads folder. In there you have Frogger start files. Open this one, and then you want to open this project file inside of the folder. You are going to get the same result that you are seeing in here. Double click on that, and then you get exactly what I have started with. Other than that, this project does not contain any kind of script. All of this we have to create ourselves. And well, for that, first of all, I want to create a 2D scene, which I want to rename right away to game. Then save the entire thing with Control S or scene and save scene. And I want to save it inside of the scenes folder. Game.tscn is totally fine. And now we have our first scene for the game, and this is going to contain all of the logic. So for example, attached to this is going to be the player, the background, all of the cars, and so on. Speaking of which, first of all, I want to add the background to it. And for that, we can look at graphics. In there somewhere, we have map.png. This I want to import. Or in other words, I want to create a sprite 2D, which can hold a texture. So in other words, I want to drag map.png into this texture slot, and then we have the background. That is actually already pretty solid. That way we have at least something to look at. Next up, I want to create the player. For that, I want to create a new scene and then create another 2D scene. This is going to be for the player, And to that, I want to add another sprite 2D. This sprite 2D is going to display the player graphic. So let me zoom in a bit and then go to the folder Graphics, Player, and Player Symbol. Drag it inside of the texture, and then we have the player. Although, if you look closely, this is looking horrible. Also, while I'm talking about it, if you look at game and you zoom in into this map, this is also not looking great. So what's the problem here? When you have graphics, like for example the player, Godot has to scale it. This original player graphic for the player is 12 by 14 pixels, a really, really small graphic. And Godot, to make it this big, has to scale it up by a lot, which is totally fine. The issue is that there are different ways to scale a graphic, and the one that we are currently using is really, really not working. To fix that, all we have to do is go to Texture, and there we have Filter. At the moment, it's set to Inherit, but if we set this to Nearest, then this is looking significantly better. That being said, this isn't what I actually want to do, so let me undo it. Simply because I want to do this operation for every single graphic inside of my graphics folder. Doing it one by one would be kind of a pain. You can simply go to Project, Project Settings, and then look for Texture, and then look at Textures. In there, you have a default texture filter, which is set to linear by default, but we want to set it to nearest. That way, by default, we are scaling all of the graphics in this filter style, and that is going to look a lot better. Nice improvement. Then I want to save the scene, player.tscn is totally fine, and then we have the player. And this player we want to add to the game scene. So with game selected, I want to either instantiate a child scene or press Ctrl Shift and A, and then we can add the player scene to the game scene. If I now zoom in a bit, we can see the player. Let's move the player roughly here, so it's a bit easier to see. And then we can try to run the game. For that, click on this button here or press F5 on the keyboard. And then you want to select the current scene to start the game. Select current, then we're getting a graphic, and it does work, but it's really small at the moment. That we're going to fix later. For now, this is totally fine. I am happy with that. I suppose to see the player a bit better, we can scale the sprite 2D, which we do under Transform, and then scale it by a factor of 6. If I now go back to game, the player should be much more visible. And that is definitely better. Alright, with that, we have two scenes that work together. Next up, we want to move the player in a certain direction. For that, the player scene needs to have a script. So click on Attach a new script. We want to have inherit node2d and save it inside of scenes and player.gd. All of this is fine. Click on Create, and now we can write a couple of lines of code. Now for the player, first of all, I want to have a couple of basic variables. I want to have a variable for the direction, and this needs to be a vector2. If we set this data type, the default value that we are getting is going to be a vector2 with x and y both being 0, which is exactly what I want. Although, if you wanted to be a bit more specific here, you could do vector2.0. Same thing really, choose whatever you like. Besides that, for the player, I want to have a speed, which should be an integer, and for the default value, I want to go with, let's say, 200. Once we have that, I want to call a function that runs on every single frame. This could either be func_process, or it could be func_physics_process. I am going to use physics process because later on for collisions, we want to have just a bit of physics. Although at this point, it wouldn't really matter. And in here, we want to move the player position, or in other words, we want to grab the position of the current node. Remember, when we are attaching a script to a node, like for the player at the moment, we get access to all of the stuff inside of the inspector. So at the moment, we are targeting the position via this position value. If you have an over position, you can see that this value wants to have a vector2. And the way I am going to approach it is I'm going to add a value to it, which is going to be our direction multiplied with the speed. And that's actually all we have to do, although at the moment this isn't going to do anything. So if I run the main scene, the player is not going to move, but that happens because our vector2 for the direction is 0. We have a vector2 with 0, and this we are multiplying with 200. The end result is going to be a vector with 0 and 0, so the position doesn't change whatsoever. However, what we can do is change this vector2 to a value that's not 0. I want to have a vector2 where x is 1 and y is 0. And now if I run this thing again, our player is moving to the right, although it is quite fast. Let's change this to a 5. And there we go. Now the player is moving to the right. If I set this to 1 and 1, then the player is moving right and down. And that is working pretty well. Perfect. With that, we have a really basic setup. Obviously, it doesn't do very much, but at the very least, we can move things around. Let's do an exercise. I want you to create a new scene with a few objects, like trees, boxes, whatever you like inside of the graphics folder. Add all of that to the scene, and then add the scene to the game scene. So you are decorating the entire thing a bit effectively. On top of that, use GDScript to scale up the scene over time. How fast this is going to happen is entirely up to you. Pause the video now and see how far you get. I want to add another scene, which once again is going to be a 2D scene. Let's call this one exercise object. The name really doesn't matter. And then save it. The scenes folder is totally fine. Save in here. And then we want to attach a couple of objects from the graphics folder. Let's say I want to start with a basic tree. You can actually just drag and drop it into the scene. Godot is automatically going to give you a sprite 2D. Although by default, the position is going to be a bit weird. So let's reset that one. And then the tree is right in the center point of the scene. I guess besides that, we can add another tree. And let's say we could add a box like so. This I want to save. And then inside of the game, I can add via this button or Control-Shift-A the exercise object. This we can place somewhere, let's say here. Then run the game. And we have another scene inside of the game. Doesn't look amazing yet, but at the very least we have something. Besides that, I want to add a script to the scene. All of the defaults here are totally fine. Then create. And like for the player, I want to run a function on every single frame of the game, which I am doing via physics process once again. Now for this thing, I want to target the scale property, which we can target via scale. So hover over the property inside of the inspector, and then you're getting some bits of information that are super useful. Once again, Godot wants to have a vector2 with x and y, and that determines the scale. So to target it, I want to type scale and then assign a new value to it, where we want to get scale and multiply it with a value of, let's say, 1.1. Let's try the entire thing, and that might be quite fast. And yeah, it definitely is, but you get the idea. Let's change this to 1.001. Then it's not so strong anymore. Now we can see that the scene that we have just created is growing very, very slowly. Not something we can use for the actual game, but for an exercise, this is pretty alright. And with that, we are pretty much good to go for this part. Although there's one thing that is a bit annoying. If you look at the bottom, Godot is complaining with the debugger, where we have not 2 errors, but 2 warnings, that we are not using the delta parameter. To fix that, I want to add an underscore to both of them. That way Godot stops complaining. If I run the scene again now, the debugger doesn't complain, which feels a lot better. Next up, we are going to move the player around using player input, which is bringing us a lot closer to an actual game. For that, we have to capture user input, which in Godot is quite easy. We can simply create an input map. Via that, we can capture keyboard, controller, joystick, and mouse input, which is really all that we need. So back in Godot, you want to go to Project, Project Settings, and at the top, we have an input map. The way this thing is working is you define an action, and associated with this action, you have some kind of input, like a key press on the keyboard, for example. For example, I can type left and press enter, then we're getting one action for left. And to this action, we can assign events, which is a fancy way of saying a button on the keyboard, a mouse button, a joypad button, or whatever you have available in here. Godot is also listening for input, meaning if you press a button on the keyboard, for example, the left arrow key, then it gives you the right option right away, which is super handy. So in my case, I want to click on OK. And now to the left action, we have the left physical button on the keyboard. Besides that, another action I want to add to it is the A button on the keyboard. Click on OK, and now we have two key bindings for this action. You could also add a controller, although for now I am not too worried about it. What I rather care about is to add other keyboard bindings for up, right, and down. For all of these, I want to add the keyboard bindings. So for up, it's the up arrow on the keyboard or the W key. For right, I want to have D on the keyboard or the right arrow. And finally, for down, I want to have the S key or the down arrow. And that is all we need for now. We can close this dialog and then work inside of GD script. Specifically, I want to work inside of the player. Now, there are a couple of ways to work with the keyboard bindings. The easiest one, I think, is to use input and then is action pressed. This is looking for an action that is being pressed. Let's start with the right action and then print the result. If I now run the code, by default, we're getting false because the button is not pressed, but if I press right on the keyboard, we are getting true. If I release it, we're going back to false. The way we could use that, for example, is to only move the player if this value is true. Let me cut it out and add it to an if statement. Only if we are pressing the right button, then we want to move the player. If I run the thing now, the player is not moving, but if I press to the right, then the player is moving, which is already quite a bit better. Although this still isn't exactly what we want. To actually move the player in a certain direction, I want to keep position is equal to direction times speed. And then when we are pressing the right button, I want to change the direction to a vector2.right, which is the same as a vector with 1 and 0. Besides that, I want to duplicate all of this and then get the action pressed for left. If that is the case, direction should be vector2.left. If I now run the code, I can press to the right, the player is going to the right, and if I press left, we are going left. And this kind of works, although the player never stops, which isn't ideal. Meaning we have to figure out some kind of system to organize the input and then get the right direction. There are a couple of ways of doing it, and the best way to get started is to look at input. For that, hold Control and then click on Input. Then you get the documentation for input. If you go down a bit, you can see all of the methods associated with it. There are quite a few. The one that we care about the most is called getVector. Click on that, and then we are going to do an exercise. I want you to read the documentation and figure out what input.getVector actually does and how you can use it. Pause the video now and see how far you get. I hope you read this entry. I think overall it's fairly straightforward. Basically, getVector wants to have 4 inputs: -x, +x, -y, and +y. Or in other words, for normal people, left, right, up, and down. These are the directions that we can add to this method. And as a result, we are getting a vector2 that organizes all of them super easily. Or in other words, back inside of the player, I want to get rid of all of this and instead update direction via input and get vector. Now we need the 4 different directions. Negative x is left, positive x is right, negative y is up, and positive y is down. Once we have that, I can run the game and now move the player around. Feels like magic. If I stop pressing any of the buttons, then the player stops as well, which works really, really well. Get vector you see all the time. It's incredibly useful. And fundamentally, it's not that complicated. All it does is it takes 4 inputs and then returns a vector that we can use right away inside of the direction. And to finish all of this up, I want you to do another exercise. Create another input, this time for the space key, and then inside of GDScript, when this one is being pressed, print something. And as an extra challenge, make sure that when the button is pressed, you're only printing it once, not multiple times. You will definitely have to read the documentation for all of that one again. Pause the video now and see how far you get. Once again, back inside of Godot, I want to go to Project, Project Settings, Input Map, and then create a new action. I call this action Confirm, because later on from the title screen, this one goes back to the actual game. Confirm might not be the best name, but it's going to work for our purposes. The actually important part is I want to add a key binding to this action with the space button. Click on OK, and now we have space physical. That's all we need. Next up, inside of the player script, I want to check if input is action pressed with confirm. If that is the case, I want to print something. And you might think that this is all we needed. However, if I now run the game and I press space, even if I press it once, we're getting something multiple times. Not ideal. So what's the problem here? Is action pressed checks if this key is pressed on every single frame of the game. And physics process always runs at 60 frames per second. Meaning this function checks every 60 milliseconds if this key was pressed or not. Even if you only press it for 1/10 of a second, for Godot, this is quite a few inputs. Now there are a couple of ways to fix it, but the easiest one is to not use is action pressed, but rather is action just pressed. That way Godot is only checking if the button is pressed, but not if it is held down. If I now run the thing again, I can press space and we only get one output every single time. Much better. With that, we have user input. At the moment, we do have some basic input, but the game just doesn't look very good. Most importantly, everything is tiny and we can only see part of the background. All of this is going to be fixed in this part where we are going to add the camera. That way we can zoom in and actually follow the player on the map. And fortunately, cameras in Godot are really, really easy. You simply create a camera and then tell the camera to follow the player. That's all we need. The camera could also follow any other object, really whatever you need. On top of that, you can also set limits and speeds for the camera. That way, you have a ton of control over how this thing is moving. First of all, the player shouldn't be scaled up anymore. So the scale should go back to 1 and 1. On top of that, inside of the exercise object, I want to get rid of this code, so we're not scaling it up anymore. That way, I can run the whole thing, and everything is super, super tiny. To fix that, we want to add a camera and zoom in. On top of that, the camera should follow the player. Now for that, to the player scene, I want to add a camera 2D. If I now go out a tiny bit, you can see this pink purple-ish frame. That is the frame of the camera. And simply by having it attached to the player, it is already going to follow the player. Or in other words, if I now run the game and I run around, the camera is following the player, which is already a lot better. Besides that, if you look at the inspector, we can modify a couple of things, most importantly the zoom level. If I set this to a factor of 4 for x and y, then the frame has gotten a lot smaller If I now run the game, we can see the player quite a bit better. And that is actually already making a pretty big difference. You can also set the offset and, for example, move the camera down by quite a bit or up by quite a bit, because the player might want to look a bit more ahead, but I guess for our purposes, we can leave it at 0 and 0. Besides that, if you look a bit further down, we have a few more options. We can set a limit for the camera. By default, these are basically infinite. Then we have position smoothing, and this you always want to enable. That way the camera follows the player a bit more smoothly. You can actually see it right away. If I run the game and I move around, the camera takes a little bit of time to catch up with the player, which right now looks a bit silly because the player is too fast. But if we increase the speed of the camera to something like 20, then this is going quite a bit better. Usually, you do want to have position smoothing enabled. It just looks and feels better. But once again, whatever you think is best. Finally, we can set a limit. For example, for the left side, we never want to go further than 0 pixels. If I now run the game again, I can go to the right, but the camera stops at position 0. And that is pretty okay. Obviously, you want to measure this value. For that, inside of the game, you want to look at where this map starts and ends. The best way I find for that is to drag the ruler, and then you get a pixel measurement. So if you hold it there, this is going to be negative 192. Since this thing is symmetrical, the right side is going to be 192 as well. Then for the top, we have negative, I think this is going to be 320, and positive 320, because once again, this map is symmetrical. Now to get rid of the rulers, you simply want to drag them outside of the screen. After that, inside of the player, for the camera, the left side should be negative 192, the right side should be 192, the top should be negative 320, and the bottom should be 320. Top and bottom can be very easily confused, but remember, going up means you are decreasing the values. But let's try all of this now. And I can move in the different directions, and we cannot go outside of the window. And that is working pretty well and makes the game feel quite a bit nicer. I guess while we are here, what you could also do inside of project and project settings in general, you can look at display and window. In there, you can set the viewport width and height. Usually I set them to 1280 by 720, which is a much more standard resolution. Besides that, you can set the mode, you can stretch the thing in different ways, you can work with landscape or portrait, and do lots of different things in here. Although I'm not going to touch them too much. If I run the thing again, now you can see our resolution is 1280 by 720. And obviously, you can also resize the entire thing. That works totally fine. And with that, we have cameras. Our game is coming together quite nicely, but there's one really important thing missing right now: physics, or in other words, collisions. That we're going to fix in this part. And for that, we have to talk about physics in Godot. We want collisions, and for that, Godot has dedicated nodes. There are 3 that basically do all of the work. The first one is a static body 2D. This is a, static physics object. It doesn't move, and it's basically for objects like houses, trees, bins, really whatever doesn't move and needs to be collided with. Next up, we have a character body 2D. This is a physics object that can be moved via code. Pretty much any kind of character is going to be a character body 2D. This could be the main player, this could be enemies, this could also be a car, really anything that moves and doesn't have to be physically accurate while moving. More or less anything that moves and needs to collide with something is going to be a character body 2D, with some minor exception. The most important one is for rigid body 2Ds. These are physics objects that can be moved via physics. These are going to be used for arrows, cannonballs, and things like that. And just to be explicit, the difference between a rigid body 2D and a character body 2D is that a rigid body 2D gets some code in the beginning to determine the direction of the movement, and then everything else is covered by physics. Whereas a character body 2D is going to continuously get directions from the code, meaning these objects can be updated constantly. Besides these three nodes, there's one more node that you see very often, and that is an area 2D. This one simply checks if a body is in an area, and that's all it does. On its own, it doesn't do any kind of physics, but it works very similar compared to the others. As a consequence, they are usually grouped together. And before we get started, there's one more super important thing, and that is that physics objects are not moved via their position. Instead, we're giving them a velocity, and then Godot calculates the position. Via that system, Godot can account for physics right away. First of all, I want to create a static physics object. We can actually use the exercise object for that. Now, at the moment, we have a node 2D at the root node. This I want to change. For that, I want to right-click on it and then change the type. If you now look at all of the nodes, we can go to node 2D, and in there, we have a collision object 2D. If you expand that, we have an area 2D, and we have physics body 2Ds, where we have a static body 2D, a character body 2D, and a rigid body 2D. The nodes I just talked about. These are the main physics objects. Although they're not the only ones. If you expand static body 2D, you also have an animatable body 2D, which is basically a static body 2D that can be moved a bit. And if you expand rigid body, we have a physical bone 2D, which is going to be useful for skeleton animation, but not something we need at the moment. So instead, I want to work with a static body 2D. Click on Change, and now Godot is going to complain that this node has no shape. As a consequence, it cannot collide or interact with anything. To fix that, we have to add another node, either collision shape 2D or collision polygon 2D. To get started, I want to add a collision shape 2D. If we add that, Godot is going to give us another warning that a shape must be provided. With the node selected, you want to look at the inspector, and there we can add a shape. Loads of options in here. Choose what you think is best. Usually a rectangular shape 2D is working the best. And I guess just to keep things simple, we can get rid of the box and of the second tree. And then change the shape of this thing so it fits the tree reasonably well. And by the way, if you hold Command or Alt, then you can scale this thing while mirroring it around the axis. This works on X and Y. And let's create the box like so. Cool. With that, we have one physics object. If you now look inside of the game, we have a tree, basically. That being said, at the moment, we are still not getting collisions, and if I run the game, the tree just doesn't do anything. For actual collisions, both the player and the tree need to be physics objects. At the moment, the player is simply a graphic that can move around. No collision yet. Now, before we start working on the player, inside of the tree, in the script, you want to make sure that you are extending the right node. At the moment, node 2D is incorrect because this is a static body 2D, meaning this should be static body 2D as well. Without that, the code would start doing weird things. Now, that being said, this exercise object doesn't need to do anything anymore. We can remove the script entirely. And close the script. We can simply discard it. That way, we simply have a tree. And I guess while we are here, we can rename it to tree. And just to be consistent, inside of the scenes folder, this shouldn't be exercise object. This should be tree. And the script, so exercise object.gd, we can delete. Remove it, and then the game is going to be a bit cleaner. Now that we have that, we can start working on the player. First of all, the player root node needs to change the type. We want to have a character body 2D. Once again, Godot is going to complain that we have no collision shape. This we can change by adding a collision shape 2D and then giving it a shape. For the player, I want to go with a rectangular shape and then scale it so we are hitting most of the player. You want to leave a bit of space at the top and at the bottom, because these parts should overlap with other objects. That way you get a fake kind of 3D effect. Looks really nice. You see later what I mean. Besides that, what's really important to do inside of the script, we want to extend a character body 2D. And now that we have that inside of the game, I can move the player around and we still don't have collisions. That is because at the moment, we are changing the position of the player via the position property, which you can do. You wouldn't get an error, but you also wouldn't get collisions. The way you are supposed to approach it is you are supposed to override the velocity, which is a property of a character body 2D. This needs to be moved in a certain direction, which we are getting via direction multiplied with the speed. Once we have that, you want to call move and slide. That way it applies this velocity and actually moves the character body 2D. As an outcome, the player is going to move a lot slower. That we can fix by changing the speed back to 200. Might actually be a bit too fast. But now the important bit is we have a collision with the tree. So I cannot go further than this tree, and that is working really, really well. That is all we needed for collisions. For the player, we have a character body 2D, which we are moving via the velocity and move and slide. Besides that, we have a tree, which is simply going to be a static object with a collision shape. We also have an image, but that isn't actually necessary. At least for the collision. For the actual game, this is important. So with that, we have a pretty good system. To finish up this part, let's do an exercise. I want you guys to restrict the player to the map. Or in other words, use static bodies that ensure that the player is not able to leave the screen. Pause the video now and see how far you get. Back inside of the game. In the main game scene, I want to add a new child node, which is going to be a node 2D. Let's call this one borders. To this node, I want to add a static body 2D along with a collision shape 2D. For the shape, I want to add a rectangular shape. That way, once again, we're getting the shape and the player is not able to move past that. So here, we cannot go further up. And this shape, I want to move to the right. So we are here on the right border of the map. And then I want to scale this thing up by a lot. So the player cannot go further to the left and leave the screen. Let's try this one now. And the player is not able to leave. This we have to do for all of the 4 sides. Although you do have to be careful. If I simply duplicated this static body 2D by clicking on duplicate or Ctrl D, then we would get another static body 2D that we can move to this point here, and that would work. I can now run the game, and the player cannot go further to the right than this border. The issue is, if I wanted to change this collision shape, I would also change the other one. If you duplicate a static body 2D with the collision shape, these collision shapes are going to be linked, which sometimes can be useful, like in this case, where we do want to have the same shape. And this one should be a bit further here. But for the top and bottom bit, this would not work. So do be careful here. Instead, I want to add another static body 2D with another collision shape. And for this collision shape, I want to create a new rectangular shape that is going to be all the way at the top here. And let me move it to the right position here. And here is fine. Finally, I want to duplicate this shape and then move it all the way down. So we are covering the final part of the map. And now the player is not able to leave the screen in any direction. Perfect. Next up, we are going to animate the player, which is going to make the entire thing feel much more dynamic. In Godot, there are a lot of ways to animate things. The easiest one is to use an animated sprite 2D, which is a sprite 2D that's, well, animated. Inside of this node, you can create animations and then select them. That's pretty much it. Let's have a look. Back in Godot, I want to work inside of the player and then get rid of the sprite 2D. Instead, I want to add an animated sprite 2D, which at the moment is going to give us a warning that we have to add sprite frames to it. For that, you want to look at animation and then inside of sprite frames, create new sprite frames. This right now doesn't really do anything, but if you click on it again, then you're getting a sprite frames editor. In there, on the left side, you can see the animation that you want to play. Let's say for now, I simply want to play the left walking animation for the player. Then inside of this main field, you can play the actual animation. This you can create in basically two ways. Number one is you could simply drag graphics in here. For example, if I grab a couple of these random objects and drag them in there, I can play the animation, and then Godot is going to play one frame after another. Which would work, but for our purposes, this isn't ideal. Let's undo all of this. Instead, for the player, we have a player tile set. If I drag it in there, you can see that we have all of the player frames in this kind of setup. And from this, we want to select specific frames, like for example, this graphic here. To work with that, inside of the sprite frames, you want to click on this symbol, where you can add frames from a sprite sheet. We want to go to Graphics, Player, and then select the tile set or the sprite sheet. And then we can zoom in by holding Control and using the mouse wheel. Godot wants to separate this graphic into specific cells. We have 4 horizontal cells, but only 3 vertical ones. The size lines up pretty well, so this looks pretty good. And now we have to select the right kind of frames for the animation. At the moment, we want to get the left animation, which is the left one. And if you click on it, you're getting a number. This would be frame 0, then we have frame 1, and then frame 2. These are the 3 frames that I want to add to it. And now, we can play this animation. Although at the moment, it doesn't look great. This animation is actually supposed to have this frame, then this frame again, and then the final frame. To get that, you can simply have the first frame selected, then press Ctrl C and Ctrl V, and now we have duplicated the frame. And to move this frame, you can either move it in the right position or use these arrow keys. That way, we can move frames around quite easily. We are getting a much nicer walking animation. You can also set the frame rate, if this thing is looping, and if it's autoplaying. You can also set the frame duration, but I don't really care about any of those values. Just make sure that you are looping the animation. Otherwise, it would simply stop on this frame. Also for now, I want to autoplay this animation. And that way, if I run the game, we are getting a very basic animation. That is looking pretty alright. And now to work with this, we want to use GDScript, and to keep things organized, I want to create another function for the animation. No need for parameters. I basically want to check if we have a direction, then we want to actually play the animation. If we don't have a direction, then the player should be static, or in other words, we only want to get the first frame. That way it looks like the player is idling. If we have a direction, I want to play the animation, which for now means we are simply not doing anything because we already have an animation, it's just not doing the right thing. However, if we don't have a direction, so we're not moving, then I want to get the animated sprite and update the frame property. This one should always be 0. Now by default, this value increases, so we are selecting different frames. But if you set it to 0, we're always sticking on the first frame, so this one here. That way, at the very least, we can play the animation or not play the animation. Really important, don't forget to actually call this animation function, which I want to do before we are doing move and slide animation, although the actual position of animation doesn't matter. Anyway, let's try this now. If I am not moving, the player is also not animating, but if I start moving, then we are getting the walking animation. And that is working pretty well. Next up, I want to get the right walking animation. For that, you could add another animation in here. So simply add another animation with right, and then select the player and the right movement. So these frames here. However, we don't actually have to do that. We can approach this much more elegantly. So let's get rid of the right animation. Instead, all that we have to do, if the player is moving to the right, we want to flip this animated sprite on the horizontal axis, which we can actually do super easily. With the animated sprite selected, we have offset, and there we can flip H. And if you hover over it, the property is called flip_H. Inside of GDScript, what we can do, if direction.x is greater than 0, then the animated sprite 2D dot flip H property should be true. Let's try that. If I go left, we're looking left, and if I go right, we are looking to the right. Now, if I look left again, we're not going back to the left side. So that's not great, but at the very least, we are making progress. To fix this part, all we have to do is add an else statement and then copy all of this with the difference that flip H should be false. Let's try this again. And now we're getting the left animation and the right animation, and that is working really well. Cool, definitely progress. Although we are trying to do something very simple and we are using 4 lines of code for it. This could be more elegant. The way to approach that is to first get the animated sprite 2D and then flip H. The value we want to assign to it is going to be direction.x being greater than 0. And then we are done. This line is doing the same thing as these 4 lines. And I think it's much easier to read as well. So let me get rid of these 4 lines. Try this again. And we are getting the same result. Doing this kind of stuff comes with experience. If you work inside of an engine for long enough, then at some point you find ways to make your code more efficient. So for now, if you work with more if statements, that's totally fine. But this would be more elegant and much easier to read. With that covered, let's do another exercise. I want you to finish the animated sprite, which means you should be adding the logic for going up and down. So in other words, select the right animation depending on the player movement. Pause the video now and see how far you get. Back inside of Godot, I want to work with the sprite frames and then add 2 more animations for up and down. These, unfortunately, we cannot mirror. I guess let's start with up. I want to click on this button again, select the player tile set, zoom in, and at the moment we are looking at up, which is this animation. Add the 3 frames, and then once again, I want to duplicate the first frame and place it between these 2 walking frames. All I have to do is press Ctrl C and Ctrl V, and then drag this frame in the right position. Just to double check, let's play the animation, and that looks pretty alright. Cool. Besides that, for down, we want to do the same thing. So grid, player, get the down walking animation, add the 3 frames, duplicate the first one, and drag the frame in the right position. Then we are getting the down walking animation. Perfect. With that, we have the right animations that we can work with. We just have to figure out when to play which using GDScript. I first checked if direction.x is different from 0. If that is the case, I want to play Animated Sprite 2D and update the animation. This one should be left. We are still flipping the sprite on the horizontal axis. So if the player is going to the right, then left is automatically going to become right. Besides that, else, if we are only going up and down, then I want to get the Animated Sprite 2D and update the animation again. Let's say for now, this one could be up. Let's try this one. I can go left, I can go right, and I can go up. Although I cannot go down, at least not with the right animation. But we are making progress. Now at this point, you could approach this in two ways. You could either check if direction.y is smaller than 0, and if that is the case, we want to do all of this. If that is not the case, let me duplicate all of this. Direction.y is greater than 0, then the animation should be down. Let's try this one now. I can go left, right, up, and down. This, once again, is working, but we are also doing something very simple over 4 lines of code. A better way of approaching this would be to get the animated sprite, then the animation, and assign it up if direction.y is smaller than 0, and if it is not the case, else we want to assign the down animation. That way, we can get rid of all of this, and we would have the same result. Much more elegant. Let's try all of that, and now I can go in all of the 4 directions, and the player is animating or static when we are not moving. At this point, we have basically finished the player, which means we can start working on the cars. For those, we have to do a couple of things. Number 1, cars should spawn automatically in a specific interval. For that, we're going to create a timer in just a second. On top of that, they should start in a set position and move in a certain direction. There are a couple of things that we have to go through, so let's go through it step by step. Number 1, we have to learn about signals. These are a vital component of Godot, and basically, any node can emit a signal. For example, a node can trigger when there's a collision or when a timer triggers. Every node has its own signals, depending on what they're supposed to be doing. This is a super important concept. Let's have a look at it. Back inside of Godot, let's say I want to look at the player, specifically the root node, so the character body 2D. On the right, we have the inspector, and there we can also see the node. This one contains signals and groups. The thing that matters for us are the signals. In here, you can check all of the signals that this node can emit. For a character body 2D, there aren't many, because this node in general is just supposed to collide with things and not do that much more. So we can check some general things, but they're not really that useful. Instead, a much more interesting node, let's add it to the main game, is going to be a timer. This is, well, a timer. If you look at the inspector, you can get a wait time, if this is supposed to trigger once or multiple times, if it's auto-starting, and that's kind of all you need. Let's say I want this timer to auto-start and then run for 4 seconds. This right now is not going to do anything. If I run the scene, at some point the timer is going to trigger, but it doesn't really do anything once it triggers. So this is no good. But what we can do, inside of node, we have the timeout signal. This one is going to be triggered when this timer times out. The way you are going to use it is you double click on it, and then you have to connect it to a script. At the moment, the only node that we have with a script inside of the scene is the player. So what I want to do is to add a script to the game scene. Add a script, the defaults here are fine, create. And now, with the timer selected again, double click on timeout again, and then add the signal to the game script. Connect. And then inside of this script, we can run a function. Let's say I want to print timer has triggered. If I now run the entire thing again, every 4 seconds, we should be getting timer has triggered. There we go. This should happen multiple times. There we go. This looks pretty good. If we enabled one shot, this would only happen once. This system, I want you to practice right away as well. So, I want you to create an Area 2D node. This should be at the top of the map, and when the player enters, it should print player entered. An Area 2D node works like the other physics objects, meaning you have the node and then you need a collision shape. After that, look at the signals and see what you can work with. Pause the video now and see how far you get. I want to add an Area 2D node. Once again, Godot is giving us a warning that this has no shape. This we can fix by adding a collision shape 2D or collision polygon 2D. In your case, you could just add a collision shape 2D. With a rectangle, it would be totally fine. But just to illustrate what you can do with a collision polygon, let me add this one. So create, and now nothing has happened. But if you look at the top, we can create a bunch of points with this thing here selected. Once you have that, you can simply draw a couple of points vaguely at the top of the screen, like so. And to close the shape, you want to click on the origin point again. Now we have another shape for this Area 2D. For the Area 2D, the inspector doesn't matter that much. But if you look at the signals, we're getting a ton of stuff to work with. Most importantly, we have body entered. This one checks if a physical body has entered this area, which is what we are looking for. So double click on it and connect it to the game script. On Area 2D body entered would be a decent name. Although what you could also do is rename this Area 2D to Finish Area 2D. And then the name here would also change. It's usually a good idea to have descriptive names in here. Since our game is going to be quite small, this doesn't matter so much, but for a more complex game, you really want to have precise names. Anyway, click on Connect. And now we have another function that is going to be called whenever a physical body enters this Area 2D. Once that happens, we can print the body that we are getting, and we can print as entered. Let's run the entire thing. And if I move up, at some point, we are getting, inside of output, the player character and has entered. So this function here did trigger. So with that, we have signals. Those are incredibly useful inside of Godot. They make any kind of node much more interactive and give you a ton of options. Before we finish, there's one more thing that I want to do, and that is to organize the game scene a bit better. Inside of game, I want to add another child node, which is going to be a plain node, which I want to rename to timer, and then add the timer that we have just created to it. And that way, I can also remove timer2. Godot added the 2 because you cannot have the same name for two nodes. The timer that we have created should be called the car timer. And for now, I want to disconnect this signal, which you can do by right-clicking on it and then disconnect. Also, inside of the script, this timer function should disappear. We're going to replace it in just a second. For now, I just want to have a clean start. On top of that, the finish Area 2D can go inside of borders. I think they kind of work together. And finally, this exercise object should just be a 3. That's the better name for it. On top of that, the sprite 2D is simply going to be the BG or the background. That way, all of this feels much more organized. This is something you are going to learn really fast. The scene tree can become cluttered incredibly fast, and you want to keep it as organized as possible. Now that we can create a working timer, we can start working on spawning the cars. For that, we have to go through a couple of steps. And along the way, we are going to learn how to spawn scenes via code. In other words, we want to create instances of a car whenever a timer triggers. For that, number 1, we have to create a basic car scene. This is going to happen in the normal way. We are just going to create a new scene with a sprite and an Area 2D. After that, we're going to store the car scene in the main game. Next up, when the timer triggers, we're going to create one instance of that car scene. And finally, we can attach the car scene to the current game scene. That way, we can actually see it. First of all, inside of Godot, I want to create a car scene. Add a new scene, and the root node is going to be an area 2D. This area 2D, by the way, I have used because there are no actual collisions between the player and the car. Whenever there's any kind of collision between the two, the game is ending right away. So an area 2D here is totally fine. To this area 2D, I want to add a sprite 2D so we can see something. The graphics for that are going to come from cars. Select one of them and then assign it to the texture of the sprite 2D. Then we are getting one car. After that, for the area 2D, I want to add a collision shape 2D, which for this one can simply be a rectangle shape. Make sure you cover the whole car, like so and so, I guess kind of like this. Doesn't have to be too precise for our purposes, but obviously for a real game, do spend some time on it. All of this I want to save as car.tscn, click on save, and now we have one car. That actually should be renamed to car. And then inside of scenes, I should have done that before. This shouldn't be area2d.tscn. This should be renamed to r.tscn. Much better. Now we have a car scene. This I want to spawn inside of Godot whenever this car timer triggers. Speaking of which, for this one, wait time should be 1 second for now, and it should auto start. After that, for node, I want to go to timeout once again, and then connect onCar timeout timer to the game script. And now we get onCar timer timeout. Whenever this thing triggers, we want to create one instance of the car scene and attach it to the game. For that, we already have a car scene. So next up, we have to store the car scene inside of the game scene, which we do all the way at the top. I want to create a variable car underscore scene. The data type for this one is always going to be a packed scene. You are getting it by preloading the car scene. Godot is now giving you all of the options of data that you could preload. In my case, I want to get scenes and car.tscn. That way, let me add just a bit more space. We have the car scene ready inside of the game scene, which means we have covered the second part. Next up, we have to create one instance of this car scene, which is going to happen every time the timer triggers. To create one instance of the car scene, we have to call instantiate. That way, we are creating an instance of it, which we want to store in another variable. Let's call it car. That way, we have one instance, so we have covered the third step. Finally, to actually see the car, we have to attach it to the current scene. This happens via add_child. I want to add the car, and then I can run the game, and we should be seeing the car somewhere around the origin point. So there, we are getting the car. On top of that, with the game still running, you can look at the scene tree, and there we have remote, where you can see the nodes in real time as the game is running. And there you can see Godot keeps on adding area 2Ds to it every time the timer triggers. Besides that, you can see the nodes that we have added ourselves. So this is a real-time view of the game. And well, you can see quite well that we are adding more and more cars. Inside of the game, you can't see them because they're all in the same position, but that we can work on. Inside of the car scene, I want to add a script to it. The defaults here are fine as they are. And then for the car, I want to add var direction, which is going to be a vector2 that at the moment points to the left. Besides that, I want to have var speed, which is going to be 100. After that, I want to call func_process, in which we are updating the position of this area 2D node. So once again, inside of transform, we can update the position of this node. Like we have done in the beginning of this project, I want to get the direction multiplied with the speed. And you might be wondering now, why do I use process for the car, while for the player, I used physics process? And well, for the player, we have collisions, so we want to include physics. Whereas for the car, we don't actually have collisions. Once again, as soon as there's a collision between the player and the car, the game ends right away. So we don't actually have collisions, we are simply checking for an overlap. In practice, you could also use physics process, it doesn't really matter for our purposes. But anyway, with that, we should have the car movement, although I think 100 is a bit too much. Let's go with 2. Let's try out of this now, and there should be a car going to the left. And that is looking pretty good. Perfect. Once again, if you look at remote in the game, you can see we are adding more and more car scenes to the game. That being said, there is a bit of a problem. Number one, adding the cars to the game scene is going to clutter the scene tree a lot, which is going to make it difficult to work with. So what we can do at this point is add another node 2D that we can call objects. All of the objects in the game are going to be inside of this node 2D, including the player and the tree. Add them in there, and then inside of the script, I want to add the cars to this objects as well. You can simply drag and drop objects in the right position, don't forget the dot, and now we're adding the car to the objects node. If I run the game inside of remote, all of the cars are going to be inside of objects. If you minimize it, this looks a lot cleaner. Once again, not something you have to do, but it's going to make your life quite a bit easier. Besides that, it's actually not a great idea to spawn cars indefinitely. So at the moment, we keep on adding more and more cars. And this goes on forever. It never stops, which isn't great for performance. Because once a car leaves the screen, it shouldn't be there anymore. You can't see it, you can't interact with it, it should just disappear. And think of a more complex game. The more objects you have, the slower the game is going to run. So you want to keep the amount of objects as low as possible, which is generally a good idea. In other words, for the car, as soon as the car leaves the screen, we want to destroy it. That you can do by adding another node, which is called a visibility screen notifier 2D. This can check if the node is entering or exiting the screen. It should roughly fit the texture, that looks alright, it doesn't have to be too precise. And then, inside of the signals, you can check if the screen was entered or exited. We care about exited. If I connect this to the car scene, we want to destroy the instance of the car scene as soon as it leaves the screen, or when this function is triggered. This in Godot you are doing via Q3. This destroys the current instance of the node. Or in other words, if I run the game again and go to remote, inside of objects, we only ever have maybe 2 cars. As soon as the car leaves the screen, we are destroying it. So we only ever have that many cars. And inside of the game, you can see we only have 2 cars on the screen, maybe 3 cars sometimes. That way we are making sure that we only ever have so many cars on the screen, which is going to be really good for performance. Now, obviously, for our game, since it's really simple, it doesn't really matter, but it's generally good practice. Besides that, I want to set start positions for the cars. At the moment, the car always starts in the origin point, which obviously isn't great. To fix that, I want to add another node 2D to the scene tree that I called car start positions. In here, we want to store a couple of nodes that have the start position for the car. For that, you could use a node 2D. It would work, but Godot also has a marker 2D that works a little bit better. So with this marker 2D, if you move it, you can see that we have the origin point along with this cross around it. So it's a little bit easier to see. But outside of that, we only really care about the position of this node, and this we are getting via transform and position. These marker 2Ds, I want to move to all of the car lane start positions. Left or right doesn't matter so much. You can alternate or you can stay on one side, whatever you think is best. So let's do this again, like so and like so. And then we have a start position for every lane. Once we have that, as soon as we have a new car, we want to update the position of that car. For that, first of all, I want to get a random marker from the car start positions. Let's store that in a new variable, position marker. The way you're getting that is, first of all, you want to get the car start positions and then get children. This is going to return an array with all of the child nodes. On an array, you can call the method pickRandom. That way, you're picking one random child of car start positions. And once we have that, we can get the current car and update the position of that car. Now, right now, you don't get position as a suggestion. That is because Godot doesn't know what kind of node this car is that you have just instantiated. If you want all of that, you can add S and then the type of node that you want to create. So in my case, an area 2D. That way, if you have car, you can get all of the suggestions again, which can be super helpful. And generally, being really picky about the right data type is a good idea. It can make your life much easier. Anyway, for the car position, I want to have the position marker. And don't forget, position marker is just a node. On this, we want to have the position as well. If you want to be super precise here, this could be S marker 2D. If I now run all of this, we should be seeing a car coming from the right. And that is working pretty well. If we go further down, there are also some cars that can also disappear, and that looks pretty good. The issue now is on the left side, we can't see any of the cars. Simply because if a car starts here, for example, it only goes left. Not great for our purposes. But that we can work on. Inside of the script for the car, once the car is ready, or in other words, func_ready, we can simply check if position.x is smaller than 0. If that is the case, we know we are on the left side. If that is the case, direction.x should be 1. That way, we're turning the vector left to a vector right. Although, if I run the game now, this is not going to work. We are still getting the cars on the right side, but we have no cars coming from the left side. The issue is that this ready function only runs before we are updating the position. Or in other words, the ready function, this one here, is called when you're adding a node to a scene, which currently happens on this line when we are calling addChild, which at the moment is a bit of a problem because we are adding the car here and the current position of the car is 0 and 0. And then we are running this line here, which is never going to trigger because the position is 0 and 0. Only after we are doing all of that, we are setting the position of the car. As a consequence, this if statement is never going to trigger. I can actually demonstrate. I want to print car direction. Let's run it, and this function is never going to run. So this doesn't do anything. Fixing that, fortunately, is very simple. We want to update the position of the car before we are adding it as a child to the scene, which is totally fine to do. When we are calling this ready function, the car already has the right position. And that way, we should be getting cars coming from the left as well. So there we get car direction. I just have to find it. There we have the car. This can be kind of annoying in Godot. Understanding when these inbuilt functions are being called sometimes can be a little bit tricky. Always remember, ready is called when you're adding the node to the scene tree. And while we are here, I don't want to print something when that happens. Instead, I want to get the sprite 2D and flip H should be activated. That way the car is pointing in the right direction. And with that, we should be having cars that go reasonably well in both directions. At some point, there should be one coming from the right as well. Let's look up here. That definitely works. This we can refine, but I think for now, this is working reasonably well. Now, before we continue, there's one important topic that we do have to cover that does get a bit more technical. Frame rates and delta time. So far, we did not care about the frame rate at all. The game simply worked, and that's totally fine. However, in some instances, this can be an issue. That is because the frame rate is affecting the movement of objects. Not always, but in some circumstances, and that we have to talk about. And while we are here, inside of Godot for the car, when we are calling process, we are getting delta. Same for the player inside of physics process, there we also have a delta. And so far, I just didn't talk about it, but it's a really important parameter. But let's go through it step by step. Now, the main issue is that a frame rate determined movement can be inconsistent. Here's a table with the same movement, but different frame rates. The actual speed is the first column, where we always want to move at 10 pixels per frame. Or in other words, inside of our game, for the car for example, we are moving the car by a certain direction multiplied with a speed. In our case, for example, this would be a speed of 2 on the horizontal axis. This change in position is applied on every single frame. So effectively, we are moving at pixels per frame. Besides that, we have the amount of frames per second. This number is going to vary on the computer. If you have a really slow one, you might only get 10 frames per second. If you have a really good computer, you might get 500 or more frames per second. This also depends on what happens inside of the game. If you have a lot of objects, the game is going to be more difficult to run. Generally, you want to have 30 or more frames, that way your game is going to feel smooth. But for this example, it doesn't really matter what the number is. What does matter is the final column, where we get the pixel movement per second. This is simply the multiplication of these two numbers. For example, if we are moving at 10 pixels per frame, and we have 10 frames per second, we are moving at 100 pixels per second, which on its own would be totally fine. But the issue is, depending on different frame rates, we're getting a different speed because we are applying a change in position multiple times per second. And this number varies. If we apply the change in position 10 times a second or 500 times a second, it's obviously going to be different. Which for our game is going to be a problem because, well, you can see it here. If our pixel movement is 100 pixels per second or 5000 pixels per second, the game is going to feel significantly different. Or in other words, the movement speed of your game will change depending on the computer. And this is really, really not good. Just imagine any game where the movement speed could either be 100 or 5000. No game would work like that. And as a consequence, we have to account for it, which we are doing via delta time. All that this concept describes is the difference between the current frame and the previous frame. Or in other words, it tells you how long it took your computer to render the current frame. Doesn't sound that important, but it's actually super useful. Because imagine you have a game that runs at 30 frames per second. Then delta time is simply 1 divided by 30 or 33 milliseconds. If you have different frame rates, then you get different numbers, obviously. The specific number here doesn't actually matter. What matters is that the higher the frame rate becomes, the smaller delta time will be. Which is incredibly useful because let's do the table again with delta time. The first 3 columns are what you have seen before. The only addition now is that we have delta time. For example, if our frames per second are 10, then delta time is 1 divided by 10, or 0.1. If our frame rate is 30, then delta time is going to be 1 over 30, or 33 milliseconds. All of that is useful because delta time and the frames per second effectively cancel each other out. Imagine this formula here written in a slightly different way, where we have 10 pixels per frame from here, multiplied with the frame rate. In this case, that's 30 frames per second, this number. And this we are multiplying with delta time. This number here, 1 divided by 30, or 1 over 30. The end result has to be 10, for the simple reason that 30 and 1 divided by 30 are simply going to be 1. The only thing that's left is the 10 that we are getting at the end. And this works with all of these numbers. So if we have 60, we would have 60 multiplied with 1 over 60, 500 multiplied with 1 over 500, and so on. Frames per second and delta time cancel each other out. The only thing left are the pixels per frame. And that is really all we want. That way, it doesn't matter what the frame rate is, you're always getting constant movement. And this you should use whenever you change the position or rotation of any node. The one place where you don't have to use it is with physics bodies, because for those, Godot automatically applies delta time. And finally, let's do all of this in Godot. That way all of this can also be a lot more practical. We want to work inside of the car, where at the moment, we are updating the position by getting the direction and multiplying it with the speed, which on its own works totally fine. If I run the game, the cars are going to move. Let me find one. There we go. We have movement. However, this movement depends on the frame rate. Or in other words, if I go to project settings, and then toggle advanced settings, then under run, we have a maximum frame rate, which right now is set to 0, which means we have no maximum frame rate. Godot will try to run the game as fast as possible. Let's say I want to limit the frame rate to 12. That way we get at least a little bit of movement. If I now run the game, it's going to feel really rough, but the important thing is the cars are moving very, very slowly. If we increase the number to 30, then they should be moving a lot faster. And there we go. Now the taxis are quite a bit faster. And this is a problem. The frame rate shouldn't affect the movement inside of the game. Let's set it to 0 for now. That way, Godot is trying to run the game as fast as possible. Now, to actually fix this, all you have to do is multiply this value with delta time. And then you are done. That's all you had to do. So if I run the game now, the cars are going to move quite a bit slower because delta time is a very low number. So there you can see the cars are not fast at all. Simply change the speed to a larger number, let's say 200. And now the cars are a good bit too fast. Let's go with 100 here. And then we have a car that is moving at a much nicer pace. Really importantly now, if I go back to limit the frame rate to 12, the game is going to be much choppier, but the speed of the car itself is not going to change. And that's the important part. That is the point of delta time. It makes sure that you can change the position independent of the frame rate. A super important concept that you have to use whenever you're changing the position or the rotation or any of these basic properties of a sprite 2D, for example, to make sure that the frame rate doesn't affect the speed of it. However, if you have a physics object that you move via the velocity and move and slide, you don't have to do that. Godot applies delta time here automatically. Next up, we're going to work on the player-car collisions. Or in other words, we have to add a signal to the car that is going to be emitted whenever there's a collision between the two. However, this has to happen inside of the game scene, because there is all of the logic for the actual game. Or in other words, we have to connect the signal once the car is spawned via GD script. Here we are back in the game, and the issue we have at the moment is that we want to check if the player overlaps with this car, and for that we can use a signal. Body entered would be best. The problem is, we can connect this to the car, but then we have a script inside of the car, so in here. I guess that would do something, but it wouldn't really be that helpful. All of the logic for the actual game is inside of game.gd. So in here, I want to run the script for the collisions. Fortunately, what we can do, once a car has spawned, we can connect a signal via GDScript. All you need is the car that we have created. Really important. We want the car instance, not the car scene. On that thing, we can run a method called connect. Then we need the name of the signal, which in our case is called body entered. Simply type the string of it, body underscore entered. The second argument is then the function that you want to call, which in my case is going to be go to title, because that's what we later on want to do once there is a collision. Also, really important, I want to pass this function as an argument in here, but I do not want to call it, meaning there shouldn't be parentheses afterwards. We only want to have the word go to title without anything else. After that, I want to create this function. So func go to title. No need for parameters. And now, once that is the case, I want to print player car collision. And that should be it. Let's try. Inside of the game, I am getting a lot of errors. You can see in the bottom, Godot is really, really unhappy with us. Under errors, we are getting an issue, and let's read it out. Godot has an error calling from signal body entered to callable go to title, the one that we have just created here. And the issue is, the method expected 0 arguments, but was called with 1. Understanding these error messages is incredibly important. So let's go through it. Go to title expected 0 arguments because there's no parameter. However, because of connect and body entered, we are calling this function with 1 argument, this number here at the end. Effectively, when Godot is calling this function, it passes an argument into it, but inside of the function, we don't have a parameter. And as a consequence, we're getting an error message. This happened because when you look at the signal, body entered, we are getting the body as an argument passed into it. And this is what Godot wants to do. To fix that, all you have to do is add 1 parameter, which would be the body. Although in our case, we don't really care about it. But just to demonstrate what is happening, let's print the body that we are getting. And if I now rerun the entire thing, we are getting a whole bunch of collisions actually. Let's have a look at the output. The first collision that we are getting is a static body 2D collision. Then we have another static body collision, another one, and then we have the actual player collision. We are going to work on that in just a second. But for now, the important thing that you have to understand is if you want to connect a signal via GDScript, you get the node or the scene you want to connect, then you call connect with the signal name, and then the function you want to call. And always make sure that you are accounting for all of the arguments that Godot is passing into this function. And once you have that, you can connect signals via GDScript. Now, besides that, we were expecting the player body and player car collision, simply the string. However, besides that, we got a whole bunch of additional collisions. What happened here? When we are looking at body entered for the area 2D, it looks at any body. This would include these borders around the screen. Static bodies are still bodies. So whenever a car is being spawned, it will collide with this border. A car could also collide with the tree that we have created, and it could also collide with any other object that we might create, which at the moment isn't really the desired behavior. So how can we fix that? For that, we have collision layers. Effectively, every physics body has a layer and a mask. A mask is determining what physics object a node can see. And a layer determines what other physics objects can see the node. That way, for every single physics object, you can determine which objects can see each other. So with that back in Godot, if you look at any physics object, like for example the player, in the inspector, under collision, we have layer and mask. All of these are just numbers, and this determines what layer and what mask the player is on. If you have over these numbers at the moment, you only get layer 1. But what you can do, under project settings, and if you scroll down a bit, somewhere we have 2D physics. And let me disable advanced settings. We don't need it anymore. In here, you can name all of the various layers. For example, we could have layer 1 being terrain, layer 2 being the player, layer 3 could be the cars, and layer 4 could be the walls. And by walls, I mean these walls around the screen. And to get started with the player should be on layer 2, which is only for the player. So this determines what other objects can see the player. And on the flip side, for the mask, the player should be able to see the terrain, he should not be able to see itself, the player should be able to see the cars, and the player should see the walls. Then for the tree, for collision, the tree should be on a terrain layer, and for mask, we can disable everything. Simply because the tree doesn't have to see anything else. And just to demonstrate, if I now run the game and go to the tree, we are still getting a collision, and that is working pretty well. However, once I put the tree on a different layer, let's say layer 5 that we are not using, then the player can walk right through it. There's no collision anymore. The only layers that the player can see are determined by the mask 1, 3, and 4. If the tree is not on any of them, the player is going to ignore it entirely. All of this you should really practice. For that, set up the layers and the masks for the cars and the walls. Really important, the cars should not see the walls or each other, but they should see the player. Pause the video now and see how far you get. I want to start working with the car, specifically the Area 2D node. For collision, the layer should not be on terrain, it should be on cars. That way the player can see it. Next up, for the mask, the car should only be able to see the player itself and nothing else. That way a car should already not see the walls around the screen anymore. Let's try this, and now we should only get a collision between the car and the player, and that looks pretty good. Finally then, for these static bodies around the screen, you could leave them on the terrain layer. It would kind of be possible, but I would rather have this organized, so they should be on walls, and they should not see anything else. This I want to do for all of them, so this should be only 4. Same for this one. And same for the final wall, only on layer 4. That way the player should still see them. There we go, this works. But the cars are going to ignore it entirely in 2 different ways actually. With that system, we can control a lot better what is colliding with each other. Finally, all the way at the top, we have to finish Area 2D. This one should not be on any layer. In other words, no other physics node should be able to see it. However, it itself should be able to see the player. That way, if I run the game again, the player should still be getting up here, and that works, but no other physics object can interact with it. At this point, we have covered all of the basic concepts to create a level. If you added lots more stuff to it, you would have a pretty decent basic game. And this is what we are going to do in this part. However, before we get to it, there's one important concept that I still have to cover. At the moment, the player can either be behind an object or in front of it. But this system is static. The player couldn't dynamically change the position. Back inside of Godot, the position of the player relative to the tree, these 2 objects, is determined by the node tree. So at the moment, the player comes first, and then we have the tree. And as a consequence, if I move the player around, the player is always behind the tree. Inside of the game, you can see that the player right now is in the right position, behind the tree. But if we go around, now the player is, well, still behind the tree, but the player should be in front of the tree. That we have to fix. The system for that is called Y sorting. All that it does is it decides which object is going to be on top depending on their Y position. Just imagine that this line up here is Y being 0. The player position in this case is, let's say, 10 pixels, and for this player it's going to be 20 pixels, while the car is always going to be on pixel position 15. Same for this one, 15. All that Y sorting is doing is it compares these two numbers. Whichever has the higher Y number is going to be drawn on top. That way, if the car is further down, it's going to be on top of the player. If the player is further down, it's going to be on top of the car. And that's literally it. It's a really simple concept, and you can apply it to Godot super easily. All you have to do is grab the parent node, objects in this case, and then go to ordering inside of the inspector. There we have Y sort enabled. This should be enabled, and then all of this is going to work. So the player can be behind the tree, like so, and the player can be in front of the tree, like so. And that is feeling a lot more realistic. And by the way, it's really important for this system that the collision shapes for the player and the tree don't cover the entire height of the object. For the tree, we have a bit of space at the top and the bottom, and same for the player. We have a bit of stuff below and above the player. That way, these two can overlap a bit, which makes the game feel much more three-dimensional. And well, with that, we have the basic system in place. Now we can add lots of objects. To place all of these elements, you want to organize your project so the entire thing is reasonably streamlined. Let's do some examples. We already have one object, the tree, where we have a static body 2D, a sprite, and a collision shape. We could, for example, copy this tree and then place it here and here and here, run the game. We would have more trees. Pretty straightforward. If you wanted other objects, all you would need to do is create another static body 2D node. Let's say for this one, I want to create a box, for which I want to go to graphics, and then inside of objects, we have a couple of boxes. I want to choose one of those. To add it to the scene, I want to add a sprite 2D, and then box.png is going to be the texture. After that, zoom in quite a bit, add the collision shape 2D. For this one, we definitely want to have a rectangle that we then want to scale down quite a bit to something like this. Afterwards, save the entire thing inside of scenes, box.tscn, and then we have a box that once again we want to attach to objects, which means in there box.tscn, and then in the origin point we have a box. And by the way, if you try to move it and you move something else, like for example right now the car start positions, you can avoid that by having the box selected inside of the scene tree and then hold Command or Alt. That way you are only moving the node that you have selected inside of the scene tree. Can sometimes be super handy. But anyway, once we have that, we have a box, and then inside of the game, we can collide with it. That being said though, for something as simple as a box, this is kind of overkill, because a box is, well, really simple. We don't need a separate scene for that. What we could also do inside of objects is simply create another static body 2D that we could rename to, let's say, bench. To this bench, we can add a sprite 2D right away. And for that, I want to use bench.png for the texture. Then we have a bench, and after that, we can add a collision shape 2D with a rectangular shape that we then want to scale, like so and so. And then we have another object that we can work with, and we didn't have to create another scene. Although you do want to be careful. Moving this bench around right now can be kind of annoying. There's a good chance that you accidentally only drag the collision shape or only the sprite 2D, which would, well, cause a ton of problems. So this I don't want to do. To avoid that, you want to click on this symbol. If you activate it, you're getting this symbol next to the node. That means you can only move the parent node. So now we are always moving the entire bench as one object. Super handy. That way we can move it, let's say, here. And once again, inside of the game, we are getting another object that we can collide with. There are loads of useful icons at the top. The other one that's super useful is locking it. That way, this node cannot be worked with anymore, which, for example, we really want to do for the background, because this one really isn't supposed to move. Same with the borders, actually, and with the car start positions. None of those should ever really move. Although the bench shouldn't be locked, but it should be grouped. This would be another way to create an object inside of a scene. Once you have that, you can simply duplicate this bench, and then you can create as many benches as you like. Which is also a way to approach it, although if you want to create a lot of objects, this might still not be ideal. For that, we can approach these kind of objects in a different way. Let me add another node 2D, where I want to have a whole bunch of, let's just call it stuff. Doesn't really matter what you call it. To this node, I want to add lots of random sprites. I can simply drag them in there, like so. There we have a bin. We can put a box here, a box there, a third box here. Let's say we can put a car in this position and a light here-ish. The specific shape does not matter. I just want to have a whole bunch of sprites inside of the stuff node. And make sure that for this stuff node, you have ordering Y-sort enabled. Now we have a whole bunch of objects. The problem is, inside of the game, we have no collisions whatsoever. For that, we will need a static body 2D. Now what you can do to a static body 2D is add multiple collision shapes, which means I can add a collision shape 2D with a rectangle for now, and let's say this one is just for the car. So I can resize it to something like this. And then to the same static body 2D, I can add another collision shape or collision polygon. Let's say a collision polygon, and then I can draw a rough shape for these objects. So something vaguely here, 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 and nearly done. Like so. And to refine this a bit, you can have this symbol selected and then move these points. There we go. Now we have a collision shape, and inside of the game, if I go to this position, we have a collision with the car. That works, and with these boxes as well. And that is working pretty well. The same thing we can then do for these objects and for this object, and you simply go through it step by step. That way, you can very easily add lots of objects with one collision shape, which I think is the best way to approach it when you have a lot of stuff to add to a scene. With that part covered, we can do an exercise. I want you to place a lot of elements, so that by the end of it, you have a proper looking level. Place a whole bunch of static bodies and sprite 2Ds. How you're doing this is entirely up to you. You can create separate scenes or a few nodes inside of the game scene. It really doesn't matter for our game, just choose what you think is best. Pause the video now and see how far you get. I went ahead and created a whole bunch of objects. Most of those I placed inside of the stuff node, where we now have a ton of sprites, and on top of that, somewhere in there, is a static body 2D, which holds a whole bunch of collision shapes. Inside of the game, all we see though is that we have a ton of collisions with different objects. Let's go here, here. We always have collisions, and that is working pretty well. Now, obviously, to create a level, you have to have some patience and place a ton of elements, which sometimes can simply take a bit of time. Especially doing all of the collision shapes manually can be quite annoying, and later on, we are going to learn ways to make this more efficient. But for now, this is the easiest way to create a level. On top of that, for this bit up here, we don't actually need collision shapes, because once the player gets to this bit, the game should be over. I guess one thing that we can do to finish up this part is, at the moment, we don't really get that many cars, which does look a bit weird. To make that work much better, let me minimize borders and objects, and then look at the car timer. At the moment, we are creating one car every 1 second. If I change this to 0.1, then we're getting a lot more cars already. So now this feels a lot more like a game. This number you can tweak. I think I went with 0.15 for the actual project. But obviously just test this and see what feels good for your purposes. Also, while looking at this, I think we should vary the cars just a bit more. At the moment, our car is always going to be a taxi. That being said, inside of cars, we have 3 different kinds of cars, and those we want to select randomly. For that, we have to work inside of car.gd. First of all, we have to load these 3 cars into memory. That we do, first of all, by creating a variable, let's call it colors. Inside of this variable, I want to store an array that stores the green, red, and yellow car. To load them, we want to preload, and then the name of the file that we want to preload, which in my case is graphics cars and green.png first of all. Besides that, and let me write this over multiple lines so it's more readable, I want to duplicate this line by pressing Ctrl, Shift, and D. Besides the green car, I want to have the red car, and I want to have the yellow car. That way we can use these graphics inside of the game right away. And effectively what we want to do, once the scene is ready, I want to get this sprite 2D, this sprite 2D here, and then update the texture, which I can simply grab via the texture, and then assign one of the images that we are storing inside of this colors array. Now to pick a random value from it, all we need is pick random. That way we are picking one item at random. If I now run the game, we are getting very unlucky, but now this looks much better. We have 3 different cars, and that makes the game feel significantly more interesting. Alright, at this point we have a basic game where a player can move around, we have static obstacles, we have moving cars, and we can accept player input. However, what we don't have is a way to communicate with the player directly via text. That we're going to work on now, where we are creating a timer on top of the window while the game is running, and we're going to create a title screen. So let's talk about creating layouts. Up to this point, we have placed nodes using absolute positioning, which is a fancy way of saying that every node gets an XY position that is independent from the window. That means, back inside of Godot, let me create a new scene, which is just going to be a 2D scene. Inside of this 2D scene, we have the origin point up here. This is position 0 and 0. If I now place any kind of object via a sprite 2D, then this object is going to get a position that we can see inside of transform. We can have some cleaner numbers, let's say 100 pixels and 120 pixels. This number tells us the XY distance from the origin point. This number does not care about the window size, the blue frame we have right here. Or in other words, if I save this scene, let's say inside of the main folder right now, and run it, we have the car here, and if I resize the window, the car doesn't really care. It's always in the same position relative to this top left point. Which is fine for 2D nodes. They are supposed to work like that. But layouts work differently. They are placed using relative positions, which in effect means that instead of giving them an XY position, we are placing them 10% from the left side of the window or 20% from the top of the window. Things like that. That is really important. For example, if this is the game window, a UI should always be in the same top left position. For example, for health bar up here or for some indicator in the bottom left. Even if the window becomes smaller, let's say the new window is something like this because it's resized, then the UI should still be down here and maybe scale down a bit, but it shouldn't fundamentally change the position. Let me close the scene that I have just created and delete it entirely. So node2d.tscn we can delete. Instead, I want to create another new scene, which this time is going to be a user interface. Once we have that, we are getting something that looks a little bit different. We are getting a red frame and we're getting green needles around it. I'll talk about those in just a second. If I add a new node to the scene, so far we basically only work with node 2Ds, the blue ones. Now we're going to work with the green ones. Those are control nodes, which you're using entirely for UIs. In there, for example, you have a label that gives you text. You have a panel that is a basic panel that you can style. There's also a texture rectangle. That way you can display an image. We are going to work with these nodes in just a second, although for now, the node that I actually want to work with is called a color rectangle. This one is, well, a rectangle that displays a color. If you look at the inspector, we can select any kind of color in here. Let's go with a reddish value for now so we can see what's going on. And then we can resize this thing like any node 2D. That part is fairly straightforward, I think. That being said though, that's not the system you are supposed to be using. Instead, if you look on the right in the inspector, we have layout, and in there we get a whole bunch of options. The most important one is the layout mode. There we have position and anchors. If you have position selected, then you can treat this thing basically like a node 2D, where we can work with transform and give it an XY size, a position, a rotation, and a scale, all of the basic things. This can be useful if you want to display text inside of a game. So for example, later on inside of the game, we want to display some text. And for that, we do want to use the position. So we can integrate a layout node in a 2D scene. However, purely for the layouts, we want to work with anchors. And for those, we don't really need transform. Instead, we are getting anchor presets, loads of options here, but I want to work with custom. We're getting 3 options: anchor points, anchor offsets, and grow direction. The really important part for now is anchor points. In there, we have left, top, right, and bottom. Via those points, we define the distance from the node to the side of the screen that we are talking about here. Just for an example, let's leave left and top at 0 and 0. But right, we can set to 0.4 and bottom to 0.2. If I then zoom out just a bit, there we can see things better. And now let's talk about it. At the moment, we have this blue rectangle. That is our screen. At the moment, in my case, the screen dimension is 1280 by 720. You might have different numbers, it really doesn't matter, because Godot, for layout nodes, changes these numbers to a scale from 0 to 1. So only for the x-axis, from here to here, we are going from 0 to 1. Same for the y-axis. We are starting up here with 0, and then we are going all the way down to 1. That's the bottom border. Because of that, for example, for the right side, when we are defining 0.4, we are talking about 40% of the screen width. At the moment, for the left side, we have defined a value of 0.0. That means the left side of the node is on the left side of the screen. However, for the right side, we have set a value of 0.4. That means the right side of the node gets 40% of the width of the screen. In other words, we have another 60% that the node is not using. Afterwards, we get to the end of the screen. The same system we are using for top, where we start on the top of the window, or in other words, the top of the node has a distance of 0 from the top of the screen. But the bottom side is 20% of the screen height from the top of the window. That is how you have to think about layouts. You don't define an XY position, instead you define a distance to the screen borders. Anchor points for that are the most important part. Besides that, the one that I do want to talk about in this bit is anchor offsets. Those are in pixels and they give you an offset. For example, for left, we can add, let's say 20 pixels. And that way, besides the anchors, we're getting 20 pixels from the left side. Via that, you can also see what the green needles are for. They tell you the anchor points. Besides that, right now for the top, I also want to have 20 pixels. And then I can save the entire scene inside of scenes, and let's call it title.tscn, which should also be the name of the root node, title.tscn. If I now run the scene, in the top left, we are getting the node that we have just created, and this thing grows or shrinks with the screen, which can be really handy. That way, if your game runs on a really small screen, and if you have a really large screen, then it still works. Even more importantly, what you can do is place this thing in the bottom right, down here, where, for example, the left side can have a value of 0.7, the top can be 0.6, the right can be 1, and the bottom can be 1. Then we don't need any offsets. And now, if I run the current scene again, I can resize the window, and the node is always going to be in the bottom right, regardless of the window size. And that can be incredibly useful. So I hope the system makes sense. You basically, at least for now, want to work with layout mode anchors, and then for the anchor preset, you want to have custom. That way, you get the anchor points and the anchor offsets. Besides that, if you look at the top, you have this button. Via that, you can set anchor presets. For example, you can place a node right in the middle, in the top left, in the bottom right, or you can make it cover the entire available space. This is usually just a starting position. Once you have clicked on any of those buttons, you can still go to anchor preset and go from the one you have selected to custom, and then change whatever you like. With that covered, let's create the actual title screen that I want to use for the game. For that, first of all, this color rectangle is going to be the background. I have a custom color, 633C65, which is a purple-ish color. After that, I want to add another node, which is going to be a label. If you now look at the inspector, for label, we basically have text, where we can write, let's call this one the car game. Then in the top left, you can see car game. Although the font is really not ideal. It should also be quite a bit larger. The way we can change that is inside of the inspector, we have theme and theme override. Basically, you can apply a theme to multiple layout nodes, which we are going to do later. But for this project, we only want to apply custom styling to this particular node, which we can do via theme overrides. We can change, for example, the color and give it a different font color, which I don't want to do. We can also give it a custom font and a custom font size. For the font size, I want to have 140. That way, at the very least, this thing is quite a bit larger. For the font, we will need a font file that I have inside of the folder fonts. In there, we have better VCR and crackman.otf. Crackman.otf is what I want to use, so simply drag and drop it in there. Then we have a much nicer looking font. This I want to center, which I can do by going to this symbol up here and then placing it in the center. That way it's right in the center, which is a decent start, but not perfect yet. So to customize that and move this text up just a bit, I want to go to Layout and then change the anchor preset to Custom. That way I can use anchor points and anchor offsets once again. The only thing that I really want to do is inside of anchor offsets, I want to change the bottom and then move the entire thing up by some amount, let's say -250. If I now test this one scene, then we have a bit of text that is slightly on top of the center. This looks good. Besides that, I want to add another layout node, which is a texture rectangle. Via that, we can add a picture. I want to go to Graphics, then to Player, and use playersimple.png. Simply drag it in the texture, And then we have the player. This player should be right in the center of the window, which means anchor presets, center, and then we have the player. That looks good. We can also scale the entire thing. Go to Layout, Transform, and then for the size, we can change this to, let's say, 100 and 100. And then once again, you want to apply the center preset, so it is right in the center. Finally, I want to add another label. This is going to be for the score. For now, let's simply write high score with some kind of number, 1, 2, 3. This once again, I want to have right in the center of the window and then move it down a bit, which we can do by going to Layout, Anchor Presets, Custom, and then Anchor Points. We want to move the top down by a bit. Let's say something like so. After that, I want to go to Theme Override, Fonts and Font Sizes. For the font, I want to use Fonts and Better VCR. Simply drag it in there. Then we have a nicer looking font. And for the font size, let's go with 50. Maybe a bit large. 30 is better, I think. Once again, play around and see what you like. Anyway, with that, we have the basic title screen. That looks good. This is all we need in here for now. Besides that, inside of the game, let me run it. At the top of the window, I want to have a bit of text. And now you do have to be careful. You can add a layout node to a node 2D, like our game, for example. I could simply add a label to it with, for now, let's say some text, and then move it to the center top of the screen, like we have done before for the title. The issue is, if I now try to run the game, I can't see it in the top, but if I move up, there we have some text. And this text is entirely static, so not great yet. Effectively, we have to tell Godot that this label should be relative to the camera that we have selected, which in our case is the camera of the player. The way you are doing that is by adding another node that is called Canvas Layer. If we add the label to this node as a child and run the game again, then we have in the top left some text. A bit hard to see, we have to basically redo the anchor preset. Then you can see if I zoom out, we have it up here, which still looks a bit confusing, but if I now run the game again, at the top of the screen, we have some text. And that looks pretty good. With that, we can do an exercise. I want you to customize the label on top of the window, the one for the score. Number 1, it should count the time since the start of the game. For that, you can use a timer. Besides that, give it a custom font and an offset from the top of the window, so it looks a bit nicer. If you want to experiment, you can also give it a custom size and a custom color and just see what you can change. Pause the video now and see how far you get. The most important thing is that this text displays some actually useful information. Or in other words, it should display the elapsed time since the start of the game. The way I approach that is, first of all, I created another timer. That should be the score timer, like so. This one should auto start and have a wait time of 1 second. After that, I want to connect the timeout signal to the game scene, connect. Then inside of the game scene, I want to create another variable for the score, which has to be an integer with a default value of 0, which is what we're getting by default. So score int is totally fine here. Every time the score timer times out, I want to increase the score by 1. When that happens, I want to get the label and change the text of that label. Once again, if you look at the inspector for the label and you hover over the text or the property you want to change, then you can see how you approach it inside of GDScript. For a label, if you want to change the actual text, you simply want to get label.text. and assign a new value, which has to be a string. Let's say for now, I want to change it to something. If I run the game, after 1 second, some text should become something, and it does. That is working well. That unfortunately means we couldn't assign the score right away, because the score is an integer, while the label wants to have a string. If I run the game now, Godot is going to crash, so this is no good. Luckily, this we can change very easily. You want to wrap the score, so the integer, into the str function. That way Godot is turning the number into a string, after which the entire thing should work just fine. We get 1, 2, 3, 4, and so on. This is working pretty well. If you want to be fancy here, you could also do something like the string time elapsed, and then plus the string that we are getting from the score, like so. Make sure you have a space in there, and then if you run the whole thing, you're getting time elapsed with the current time. You could do that, although I don't really care about that. I simply want to display the number. I think that's enough. Now, besides that, to style this text, I want to go to, first of all, theme override, and then fonts and font sizes. The font should be better VCR, and the font size, let's go with 40. Inside of the game, this should also look okay. And yeah, this works reasonably well. Besides that, for the offset at the top, I want to go to Layout, Anchor Presets, change it to Custom, and then Anchor Offsets for top should be, let's go with 20. After that, inside of the game, we are getting, I think that looks all right. Finally, the default text should be 0. And to make sure that this 0 is actually centered, we want to set the horizontal alignment to center. That way, we are actually in the center. If I now run this thing again, we get 0, 1, 2, 3, and this is working pretty well. Perfect. The last major part of the game that we have to work on is the transition between the game and the title screen. Once we have that, we have an actually functioning game. So let's talk about it. We want to transition. Or in other words, we want to change the scene from the game scene to the title screen. This should happen when the player reaches the finish area or when the player gets hit by a car. We also want to be able to go back. If we're on a title screen and the player presses a button, then we're going back to the game. On top of that, we want to keep the score information, which means that the score inside of the game should also be displayed inside of the title screen. For that, we have to talk about global data. But let's go through it step by step. Back inside of Godot, when the player reaches this finish area 2D, we want to load the title screen. And you can see for this area, we already have a function via a signal, which is this one here. To load another scene inside of GDScript, you only need a single line of code. First of all, you want to get tree. This is a really common operation inside of Godot. The tree is basically the scene tree. This one gives you a ton of options. And to change the scene, you have two methods. Either change scene to file or change scene to packed. Scene to file is easier. Let's work with that for now. Then as an argument, you need the file path to the scene that you want to load, which in our case is going to be scenes and title.tscn. If you have that, I can run the game and go to the top part, and then we have the title screen. Although, on top of that, the debugger is not happy. First of all, the parameter body is never used inside of this method. That we can fix easily, simply by adding an underscore to body. Then we have an actual red message that Godot does not like. We are removing a collision object node during a physics callback, and this is not allowed and might cause undesired behavior. Effectively, what that means is, inside of the game, we have lots of physics objects, and if you change a scene while the physics are updating, you might get an error. Now, all that really means is that when we are changing the scene, Godot might get stuck on a physics operation, and this we want to avoid. The way you are doing that is, and Godot actually tells you that, you are supposed to use call deferred, which is just another function. Call deferred. This one calls a function, so we have to add a name here of a function. Let's create a new function called change_scene. This one doesn't exist yet, so func change_scene. No need for parameters. All that we want to do in here is get tree and change scene to file title.tscn. Simply by having that, I can run the game, go to the top, we have the title screen, and Godot doesn't throw an error anymore. This setup can be a bit annoying, but it's really important to get physics right. Most of the time, when you are changing a scene, you want to call deferred, then create another function, and inside of that function, you are changing the scene. That way you make sure the physics objects don't cause problems. Besides that, when the player gets hit by a car, then we also want to go to the title screen. At the moment, we are, for the cars, connecting the body entered signal to the function goToTitle, meaning inside of this function, we want to do something. And well, fundamentally, we simply want to call deferred once again, and then change the scene to the title scene. So now, if I run the game and I get hit by a car, we are once again getting back to the title screen. And once again, Godot is complaining that the parameter body is never used. There should be an underscore before body. Let's try this one again. And now we can get hit by a car. We get the title screen, and Godot is not complaining anymore. Perfect. This system we should practice right away. I want you to go from the title screen back to the game. This should happen when the player presses the space button while the title screen is active. Pause the video now and try to implement this one. On the title screen, we want to do something, for which we're going to need GDScript. Create a new GDScript. All the defaults here are fine. I want to constantly check for some keyboard input. That we can do inside of physics, process, or simply inside of process. It doesn't really matter. Let's go with process. And for this, we also don't need delta, so there we can add an underscore. I simply want to check if input is action just pressed, and then inside of project settings for the input map, earlier we created an action called confirm, which is for the space button. Which means for this one, we can look for confirm. If that is the case, I want to get the tree and then change scene to file game.tscn. And that is actually all we need. Since there are no physics objects inside of the title screen, we don't need call deferred. Or in other words, if I run this current scene and press space, we are getting to the game scene. And the game runs just as before, and we can go back. This is looking pretty good. Finally then, we have to get the score from the game to the title screen. There are a couple of ways of doing that. The way I want to cover is by creating a global node. Effectively what that means, I want to create a new scene. And this scene is going to be a plain node. It's not going to hold any complex logic. I simply want to change the name first of all to global, then save it inside of scenes, that's totally fine, and add a script to it. Global.gd, the defaults here, once again, are totally fine. The only line of code that I actually want to have in here is var score an integer with a default value of 0. This scene really doesn't do very much. It simply stores a score. But the important thing is that this global scene should be available in every single scene. So game, player, tree, and most importantly, title. The way we are doing that is you want to go to project, project settings, and in there you have globals. In my case, I want to click on this symbol, go to scenes, and then get global.tscn. And make sure you don't get GD by accident. You want global.tscn, the scene. Open this one, then you can give it a name, global is totally fine, and then add. That way, we have a global scene called global. Make sure it's enabled, it should be by default, and then you can close this dialog. And really important now, if I run the game and I go inside of Godot to remote while the game is running, there we get global, even though we didn't add this global scene to the scene tree inside of the game. And on top of that, if I finish the game, we're going to the title screen, but we still have global available. So effectively, if you add anything to this globals, the node will be available in every single scene, bar none. This can be quite nice. For example, inside of the game. When the player has reached this final area, I want to get the global score, so global.score, and then update the score to the current score from inside of the scene. Global.score refers to this variable, and this score refers to the score inside of the current game scene. Meanwhile, inside of title.gd, when this scene is ready, which means func_ready, I want to update, let me show the scene tree. I want to update this score, which we get via label 2. This thing should get text, and for now, I simply want to create a string of global.score. And that should be it. If I now run the game and I can run up, let's hope I don't get hit by a car, we're getting 2 inside of the title screen. If I try this again, and let's wait a few seconds, make sure I don't get hit by a car. And then we're getting 8 because it took me 8 seconds to finish the game. With that, we are moving data around the different scenes. Or to be a bit more specific, we have one global file that stores the score. And this thing we are referencing all the time. Although I only want to do this operation if the score is greater than global.score, only then do we want to update the global score. This we don't want to do when the player gets hit by a car, because then it's basically game over. Let's try that, and let me go really fast to the top of the screen. So we have 3 seconds. If I try this again, and I need longer than 3 seconds, and let's hope I don't die along the way. Now we have 5 seconds, and I just realized the time should be smaller than global.score, because the lower the number, the better the score. I think you get the idea. Besides that, what I also want to do inside of the title screen, this label 2 should have the horizontal alignment, not left, but center. That's going to look a lot better. On top of that, what you can do if you really want to, inside of title, you can add another string for high score, and then simply add the string to it. That way I can run all of this again, try to get to the top of the screen, and now we're getting 0. Okay, not great, because the score right now by default is going to be 0. And the score that we can achieve in the game is never going to be below that. I guess a really easy way to fix that is to set a default value of 10 for the score. Then I can run this again, try to finish the game. Now we get a high score of 2. That feels a bit better. And well, with that, we can move data between different scenes, which is giving us the basic game. All we have to do now is add sounds, and then we are done. To finish up the first game, we have to add sounds. For that, Godot has 3 nodes: an audio stream player, an audio stream player 2D, and an audio stream player 3D. The only difference between them is that the 2D and 3D version care about the position, meaning the further away you are, the quieter it will become. And then obviously the 2D node only cares about the 2D space, the 3D one cares about the 3D space. Other than that, adding audio is pretty straightforward. Let's jump right in. Back inside of Godot, if you look at the file system, we have a folder for audio, in which we have the file for the car and for the background music. For now, I just want to play the background music. for which I don't care about the position, which means I can simply add an audio stream player, this one here. And then besides that, we have the 2D version and the 3D version. You can also listen to audio, although I never found a good purpose for that. Anyway, I want to create an audio stream player. Click on Create, and then on the right side, you get a ton of options. The one that really matters is the stream. This wants to have the actual audio file, which means in my case, I want to drag happy.mp3 in there, and then we have the sound. If you click on playing, you should be hearing a preview of it. If you're setting it to autoplay and start the game, then it's going to work right away. I guess besides that, you can also set the volume and a few more specialized things, but they are not that important. I guess the one thing that you do want to care about is looping. This one should be enabled. Especially for background music, this one is actually quite important. That being said, if I try the game, and I go to the title screen, then we don't get music anymore. That is because the audio stream player only exists inside of the game scene. In the title scene, it does not. And if you edit it in here, like we have done inside of game, then it would start again, which I don't think would be a good experience. I want this music to play continuously. That we can achieve by attaching it to the global scene, where at the moment, we are only storing the score. All we have to do is add the audio stream player. And by the way, for any kind of node, you can have a right click and then cut and copy, or simply press Ctrl X or Ctrl C. Works like in any other program. Now, inside of the global script, we are still doing the very same thing with the same stream. If I run it, we are getting music continuously, which I think is much better, although I do want to lower the volume just a bit. For volume, the default is 0, and if you want to make it quieter, you need negative values. Let's say -10, which you can fine-tune, just play around and see what you like. Besides that, we have audio and car.mp3. To test this one, I don't want to autoplay happy.mp3, so we can actually hear what's going on. To the car scene, I want to attach an audio stream player 2D. Make sure you're getting this one. To that, I want to attach car.mp3, which sounds like this. This we do want to loop, so looping should be enabled. And then we want to make sure that the player only hears this part if we are close to the car, which happens with the 2D version of this node right away. Although we do have to make sure that this is set to play on. The difference between them, by the way, is if you have playing enabled, it is going to play inside of the editor. If you set it to autoplay, then it's going to start inside of the game, but not in the editor. You usually want to go with autoplay. Anyway, now inside of the game, we are getting a whole bunch of sound, which at the moment is way too loud. Let's lower the volume to -20. That way, it's not going to be so overwhelming. That works. Once again, play around if you want to customize this. The one value that really matters is max distance. If we are exceeding that distance, we cannot hear the audio file anymore. At the moment, it is setting to 2000 pixels, which is a lot. If you look at the map, the distance from the top to the bottom is 600 pixels. A lot less than those 2000. I guess we can set it to 100 pixels and just see how this works. If I now try this again, inside of the game, right now, I can't hear anything. But if I get close to the cars, then you can tell the audio is getting louder and quieter depending on my position. You can customize this even more with attenuation, which is a curve that determines the volume given the distance. For example, you could make this thing fall off a lot faster. That way, after this amount, we can't hear anything anymore. Although this I don't want to do. But after that, we are basically done. Still works pretty well, and I do want to make sure that the background music is enabled. So autoplay should be true. And now? Cool, this works. Now I guess before we finish, there are a couple of minor things that we can work on. For example, inside of the player, the move speed is quite fast. I think 100 here is fine, that way the player feels more controllable. We also don't need this part. That was just for practice earlier, so we can just remove it. It's not going to make a difference. Finally, what we should also do, the default direction should be vector2.0. Now this isn't going to make much of a difference. Since we are changing direction right away using the input function, this isn't going to matter. But sometimes it might. It's just a bit cleaner. In fact, we don't need this vector2.0 at all. This is totally fine. The default value is vector2.0. You don't have to specify it. So now we have created our very first game. Well done. Let's get started with the second game, a Metroid-style platform. While making this game, we will learn about a few more advanced concepts in Godot. Most importantly, number one, animations. Godot has a ton of systems to animate things, and we are going to learn about two. The AnimationPlayer, that's a node, and Tweens. Via that, with GDScript, you can animate any property. Next up, we have the TileMapLayer. This is an amazing tool to build levels. Finally, we will look at lights and shaders, which are essential for a good-looking game. Now to get all of this started, here we are in Godot, and I already have a couple of things. No scenes or code, but in the file system, we have a whole bunch of graphics that we are going to use. For example, there is the player. Looks a bit weird right now, but we'll work on it. We have a couple of audio files, those are very simple. And then inside of project settings, we have an input map with left, right, jump, and shoot. The one thing that's new here is that we are capturing mouse input, the left mouse button, which you can get by clicking on plus and then mouse buttons. That's all I've done here. I got left mouse button. Besides that, inside of general, for the window, I'm going with 1280 by 720. That one is very simple. And finally, under textures, I have set the default texture filter to nearest. Because once again, we are working with pixel art and we want to get the right filtering behavior. This would be the starting project. And to set up the basics, I want to create a 2D scene, rename it to, let's call this one level, save this one inside of a new folder called scenes. I suppose inside of this folder, we can create another folder for levels and then save it in there. That way, inside of the file system, we have scenes, levels with the main level. The only thing that I want to have in here is a static body 2D with a collision shape. For this collision shape, I want to have a rectangle shape that we can expand quite a bit to something like so. This is going to be our floor for testing purposes. It's not going to be visible by default inside of the game. If I run the scene and select the current level scene to run. At the moment, we do have a scene, but we can't see the collision shape. For that, under debug, you can enable visible collision shapes. If I now run this again, we can see the floor. Can be very nice to get things started. Next up, I want to create a new scene where the root node is going to be a character body 2D, which will be our player. Once again, this I want to save inside of scenes. In there, I want to have a folder for, let's call it entities. We're going to put the player and the enemy drones in there. For now, player.tscn, that's fine. And to this body, I want to add a collision shape, which is going to be some kind of capsule shapey thing. We can refine this later on. For now, I want to save, go back to level, add a node 2D called entities. As a child of that node, I want to have the player.tscn file. And then we are getting the player collision shape. If I run the scene again, you can see we have the floor and the player. Looks very plain at the moment, but it's a good way to get things started. Nearly done with the first setup part. The last thing that I want to do is to move this player to the right. That's going to be your exercise. This should be reasonably straightforward if you paid attention to things in game 1. Pause the video now and see if you can remember. First of all, we have to give the player a script. Click on this button. The defaults here are totally fine. And then we need func_physics process. In there, to move a character body 2D, you want to always call move and slide. This, by default though, is not going to do anything. So right now we have no movement whatsoever because we have to set a velocity for the player. This can be something like vector2.right multiplied with, let's say, 50. If I now run this again, we have the player moving to the right. Looks pretty good. Although all of this should be a bit cleaner. I want to have a variable for the direction of the player. This is going to be a vector2, and I want to have var speed, which is going to be an integer with a default value of 50. That way, for velocity, we can multiply direction with the speed. The end result is going to be the same. Actually, right now it's not, because direction doesn't have a default value. This we can set vector2.right. And now we can try this again. We are moving to the right. This system we're going to refine quite a bit for proper movement. For now, I simply want to add an underscore to delta, so Godot stops complaining inside of the debugger. Then we are done with the setup. For the first proper part of the platformer game, I want to have proper movement, so we can go left, right, and jump. Here we are back in Godot, and I want to move the player. For that, at the moment, we have a vector2 that defines the velocity. That does work, but that's not the system that we want. Because I don't really care to move in all 4 directions at the same time. I only want to move left and right from the keyboard and then be able to jump. The down movement is covered entirely by gravity. That means, to get started, I want to only move left or right, for which we will only need a direction underscore x, which is going to be a floating point value, for which we don't need a default value. Meaning this value at the moment is going to be 0.0, which we are then going to use to update velocity.x. It's going to be direction.x multiplied by the speed. That part is still fine. Once again, we don't have any movement, and that is expected. Cool. To change that, I want to get func and something like get input. Instead of this function, we're going to override direction.x via input, and the function I want to use is called getAxis. This works very much like getVector, except now we are only looking at one axis. Or in other words, we have a negative and a positive action. The negative action in my case is going to be left. The positive one is right. After that, let's print direction.x and don't forget to call getInput, which I want to do inside of physics process before we're doing anything else. GetInput. If I now run the game, I can press right, we get 1.0. If I press left, we get negative 1.0. And that works really well. Also, you can see inside of the game, we are actually moving the player. Really good start. That means we don't have to print the direction anymore. Next up, I want to work on the jumping mechanic, which will consist of 2 parts. We have jumping and we have falling. Let's start with jumping. I want to check if input.isAction just pressed, and we have a jump action. That is space on the keyboard. If that is the case, I want to update velocity.y. And this needs to have some kind of negative value, because we want to go up. Let's say for now, negative 10. If I run the game, I can press space and the player moves up. That looks good. We will refine this in just a second. First of all though, I want to have the second part of the equation, which is gravity, that I have covered in a separate function. Let's call this one apply underscore gravity. And all that this really does is velocity dot y plus equal and then some kind of value. Let's say for now plus equal 10. That way we are going down and we are accelerating. This we have to call. I want to apply gravity. Let's try now. And the player falls down. Although if I press space, we're not jumping because the gravity is too strong. But if I set this value to negative 200, then this should be enough. I can now do basic jumps. Obviously not amazing yet, but a really, really good start. And I think what we should also do is add a camera to the player so we're not so zoomed out. I want to have a camera 2D with a zoom level of 3. That way, that feels quite a bit nicer. So we do have a basic jumping mechanic, but we do have to make it a bit stronger so the player can jump higher. I want to have 2 more variables. One is going to be jump underscore strength, which is going to get a default value of, let's say for now, 10. And this always needs to be an integer. Besides that, I want to have gravity, which is also going to get a default value of 10. When we are getting input, I want to have the negative value of jump strength. Now this might look a tiny bit weird. We are defining a variable, and then we are getting the negative value. The reason why I'm doing it is that when we are defining the variable, I only want to care about the distance that we want to jump. The actual logic in which way we are going can be covered right here. A negative jump strength would just look weird, but that is subjective. You could add a negative value in here just fine. For the gravity, I want to use velocity.y and add gravity to it. This right now would give us very low numbers, so not much is going to happen. To test this a bit better, we can add export in front of both of them. That way, with the player selected, we are exposing these variables to the inspector and then can set a custom value. This even works when the game is running. So let me run the game. We are getting basically no jumping because jump strength is too low. But if I simply click on the inspector, and you can see at the top, the game is still running. We can pause the game or we can restart the game. If I now set jump strength to, let's say, 200, I can return to the game. And now we are getting a very basic jump. Once again, if I increase this number to, let's say, 600, return to the game, then we are jumping quite a bit more. Maybe something like 400 would be better. And that is looking not too terrible. The next change that I want to work on is gravity. But before we can get to that, there's one more change that we have to make. This should be plus equal gravity times delta, which we are getting from the parameter. So in there, I want to have delta. After that, when we are calling gravity, I want to add delta as an argument, which we are in turn getting from the parameter of physics process. That way, inside of apply gravity, we're getting delta, which at the moment is going to be a really, really low value. If I run the game again and I jump, we are, well, not really falling because we are multiplying 10 with something like 0.001. You can even see it if I restart the game. Gravity is incredibly low. But inside of the inspector, while the game is still running, I can set this to, let's say, 100. And then we are getting something more reasonable, Let's try 1,000 instead. Then we're getting slightly better jumps, and this is now frame rate independent. We can get back to this later on to refine numbers, but I think for now, this is alright. That means to finish up this part, I want to add an exercise where you are getting the input for shooting. For now, simply print shooting if the player presses the shooting action. On top of that, add a half a second reload time to it, so that we have an interval to control the player shooting speed. Pause the video now and see how far you get. To get started, inside of get input, I want to, if input is action just pressed as always, and then I want to get shoot. If that is the case, for now, I simply want to print shoot. If I run the game and I press the left mouse button, we are getting shoot. That looks pretty alright. The issue is I can press really fast and then we're getting shoot very, very quickly. There should be some kind of reload mechanic so we can't shoot too fast. I want to add a timer. Rename this to reload timer and then set a waiting time of 0.5. This timer also should one shot. After that, you could go to node and work with timeout, but you don't have to. Instead, what you can do, when the player has triggered this shooting action, we want to start the timer. So reload timer dot start. Then this timer is going to run for half a second. And while this timer is running, we don't want to allow this if statement. Or in other words, I want to check for two conditions. If the player is pressing the button and the remaining time on this timer has to be 0. That way we know it doesn't run anymore. All we need for that is the reload timer, time left, and this value should be 0. I can now shoot really fast, and we only get shoot every half a second. If I change the value of the reload timer to 2 seconds, try this again, and click as fast as I can, we are only getting shoot every 2 seconds. Cool, this works. Next up, I want to work on the bullets. That way we can do at least some very basic shooting. We are also going to learn about custom signals, meaning you can create your own signals and emit them. But let's go through it step by step. Number 1, inside of the player. When the player presses the shoot action, we want to shoot a bullet. But for that, we have a problem. The bullets need to be inside of the level. That way, they can interact with other entities. But we get the player input inside of the player, which means we have to connect this line here to the actual level. For that, first of all, the level is going to need a script. Attach a script, the defaults here are fine. Then we can do something in there. The thing that we want to do is from the player, we want to capture a signal. Now the player does have, if you have the player selected inside of level, we have all of the signals for the character body 2D, which can be useful, but for our purposes, they're basically useless. So instead, I want to create a custom signal, which you can do by simply typing signal and then add the name of the signal. In my case, shoot. Simply by adding that in the inspector for the player, we are getting shoot. On top of that, you can define parameters. In my case, I want to have a position, which needs to be a vector 2. This will be the starting position of the bullet. And I want to have a direction, which is also going to be a vector 2. Once you have that, inside of the inspector, you get the two parameters you have just defined, along with the data type. Back inside of the level, with the player selected, you can click on the signal and connect it to the level script. I guess for now, we can simply print the position and the direction. Inside of the player script, when this if statement is being triggered, I want to get the shoot signal and emit it. For that, we will need two arguments, the position and the direction. For position, we can simply go with the position of the node. That's all we need. For the direction, at least for now, I want to have a vector2.right. And that should be it. If I now, inside of the game, use the left mouse button, we are getting different outputs. We are emitting the signal here, and inside of the level, we are capturing these 2 bits of information and printing them. Via that, you can create custom signals. It's a really easy system and incredibly useful to connect 2 scenes to each other. And in our case, the position is already the right bit of information. The one thing we have to change though is the direction. The bullet should go in the mouse direction relative to the player center. Or in other words, if the mouse is vaguely here, then the bullet should go this way. If the mouse is on top of the player, then the bullet should go up. For which Godot actually has a function. It is called getLocalMousePosition, and that way we are getting the local mouse position. This is the mouse position relative to this origin point. Or to be a bit more specific, the origin point of the scene that has this script attached to it. Let me actually demonstrate. Inside of the game, if I press the left mouse button and the mouse is vaguely here, we are getting 197 and -7. If I'm up here, we're getting 2.3 and -100. If I'm on the left side, we're getting -170 and -5. If I am right in the center, so basically here, we're getting pretty much 0 and 0. I am always looking at the bottom numbers. The first one is for the position, and this one doesn't change because the player isn't moving. Now this works, but this is not a good direction. In just a bit, we want to use this direction to move the bullet. But for that to work properly, the direction should always have the same length, which at the moment it does not. Imagine if this is the player scene with the center point here. If I click here and here, we're getting this direction and this direction. This vector could have a length of 1 and this could have a length of 3. This difference is really, really bad because for bullet movement, we want to multiply both of those with some kind of speed for the actual bullet speed. But if the length of the vector is 3, then this bullet is going to move 3 times as fast. Obviously not ideal. And the way around that is to normalize the vector, for which you simply need normalized. That way, any kind of vector is going to get a standard length of 1. Or in other words, if I restart the game now and I press somewhere here, the vector we're getting has a value of vaguely 1 and then basically 0. Or to draw all of this, I have clicked vaguely here. So the original vector that we're getting is this. And by normalizing it, we are setting a length of this vector to 1. And it is always going to be 1. I could have clicked here, I could have clicked here, I could have clicked, let's say, here, and we would have gotten very different lengths. But from normalizing the vector, we are always getting a length of 1. So it'd be here, here, or it'd be here. That way, we're getting a constant direction, and this we can multiply with a speed to always have the same speed. This, by the way, we didn't have to do in the first game for the player movement, because when you do input.getVector, the vector that's being returned is already normalized. If you look at the documentation for it, Godot tells you the vector has its length limited to 1. That means it's normalized. Although this we don't want to do at the moment. With that, we get the bullet start position and the proper bullet direction. That means inside of the level, we have to spawn a bullet that starts on this position and moves in this direction. For which, inside of graphics and fire, we have a default bullet. Looks fairly basic, but it's good enough. This part is going to be your exercise. I want you to create a bullet scene, spawn it when the player shoots, and then move the bullet in the right direction. Pause the video now and see how far you get. I want to create a new scene, and the node I want to create has to be an area 2D. I can rename this to bullet and then add 2 nodes to it. I want to have a sprite 2D and I want to have a collision shape 2D. Also, all of this I want to save inside of scenes and a new folder called bullets. Bullet.tscn is totally fine in here. And then for the sprite 2D, I want to have default.png. That way we can see the bullet. And next up, for the collision shape, I want to have a rectangle shape 2D that I want to scale down quite a bit to something like this. Next up, inside of the level, I first of all want to add another node 2D with the bullets. After that, in the level script, I want to preload the bullet scene. So var bullet underscore scene, which we are getting from preload and bullet.tscn. When the player shoots, so when we're getting on player shoot, I want to create one instance of this bullet. That we do via bullet scene.instantiate. And this we then want to add as a child to the bullets node that we have just created. $bullets, add child, and bullet. That way, if I run the game, I can press the left mouse button, and in the top left, you can barely see it up there, we are getting a bullet. To refine this, I want to get the bullet itself and update the position. And by the way, to be a bit cleaner here, when we are instantiating the bullet, this should be as an area 2D. That way, we always get the right kind of node, and we get the predictions. So now position does show up. Position is going to be the position we're getting from the parameters. So position in here. If I now run this again, I can press the left mouse button, and we are creating a bullet in the center of the player. That does work, although I feel like this could be organized a bit better. Instead of setting the position in here, I instead want to call a setup function on the bullet itself, where we are going to add the position and the direction. That way, we can keep all of the logic inside of the bullet, which is just a tiny bit cleaner. To the bullet, add a script. The defaults here, as always, are fine. And we will need func setup with a position, vector 2, and the direction, also a vector 2. First of all, I want to get the position and set it to the position that we're getting from the parameter. Just to test if this is working, if I press the left mouse button, we are getting a bullet. That looks good. Although, if you look closely, the bullet shouldn't start in the center of the player, it should be to the right. We want to get the position and then add the direction multiplied with some kind of offset. Let's try 12 for now. Inside of the game, if I create a bullet, it is just a bit outside of the player. I guess 16 here might be a bit better. But once again, once we have graphics, we can refine all of this a good bit. Let's leave it like this for now. Besides that, I want to update a direction for the bullet, which doesn't exist yet. For that, I need var direction. This has to be a vector 2. And then the direction is going to be the direction we're getting from the parameter. And this we can use now. With func physics process, I want to update the position and add direction times, let's say, 30. Don't forget, we also need delta. If I run this, I can shoot a bullet in a direction. And that is working pretty well. With the basic setup covered, we can work on the animations, for which we have to learn an incredibly important node, which is the animation player. Via that, at least for now, we're going to animate the legs. The top part of the player is going to come later. Also for now, inside of the game, I think these collision shapes are going to become a bit distracting. So instead, to the static body 2D, I want to add a sprite, which is going to get icon.svg, the Godot logo. And then I'm going to move the Godot logo in the same position, vaguely here. Then we can expand this thing, so we are covering roughly the collision area. Then we can go to debug, visible collision shapes disabled, run the game. And now we do have the player, but the player itself isn't visible. We can't see the floor because of the Godot logo. That's good enough. With that, I want to work on the player legs, which we are still going to store inside of a sprite 2D. To those, I want to add inside of characters, we have player.png. If I drag this in there, then you can see we have the player, but cut up in various parts. The top part we're going to cover later. For now, I want to look only at the legs. First of all, we have to cut this tile sheet into individual parts. For that, inside of animation, we can set the H frames and the V frames. We have 1, 2, 3, 4, 5, 6, 7, 8 H frames, and we have 3 V frames. That way, we can select one of the frames and we get one part of the animation. Looks pretty alright. We want to animate this frame property. If I just do it with the mouse, let's say from this point forward, if you play these frames fast enough in sequence, you get a running animation. This can be done in a couple of different ways. You could write some code to loop over these frames and then play them continuously. Would be possible, but also quite a bit of work. Alternatively, you could use the AnimationPlayer. In there, you can, if you click on animation, create a new animation. You can give it a name. Let's call it the run animation. After that, you get a timeline to which you can add tracks, and you can animate different properties. The easiest and most common one is the property track. If you click on that, Godot is asking you what kind of node you want to animate. We want to go with the sprite 2D. If you click on OK, then Godot is asking you what property of the sprite 2D you want to animate. In our case, that is going to be the frame. And now, if I click on Open, we can work inside of this timeline. If you hold Control or Command and use the mouse wheel, you can zoom in. This bright gray area is the timeline. At the moment, and by default, we're going from 0 to 1 second. Although you could change this here to whatever number you want. In fact, the walking animation should be 1.4 seconds. The button right next to it determines if this animation is looping or ping-pongs. Ping-pongs means we start from 0, go to the end, and then go from the end back to 0, and do this over and over. In our case, we want to loop the animation. This button should be blue. That's the basic setup. Now we have to add values to this timeline. This you can do in two ways. You can either right-click and insert a key. If you're doing that, you can see a small preview. And most importantly, on the right, you can give the property that we have defined here, the frame, a value. So effectively, if you're looking at this sprite 2D, under frame, we are changing this value with whatever we have set in here. Also, once we have the animation player, you can see next to the property this key. If you click on it, you can add the property straight to the animation timeline, which I don't want to do right now. Let me get rid of all of this. Just to get started, I want to add a key, and the first value is 9. You can already see a preview there, although it might be quite small. Then after 0.2 seconds, I want to add another key, which is going to get a value of 10. Next up, another key. This is going to be 11. 0.2 seconds later, I want to go to 12. Then at 0.8, and I think you can see where this is going, I want to go to value 13. After that, another key. This is going to be value 14. And we have one more, insert key, value 15. That way, we are getting the walking animation. And if you drag the indicator left and right, you can play the animation, or you just click on this button. Then you can see that we have a running animation. Although fundamentally, we are still working with a sprite 2D for the visuals, and that's really important to understand. All that the animation player is doing is it's changing this property, which means at the moment we have to move the legs up to align with the collision shape. I guess here is broadly fine. With that, inside of the game, we have the legs, although right now they don't animate. That is because inside of the animation player, we have to give it a default animation, which means you want to click on this button, then you're autoplaying it, and inside of the animation, you get this autoplay icon. With that, we have the running animation. Besides that animation, I also want to add a new animation called idle. For this idle animation, I want to add a track, property track with the sprite 2D, and once again, I want to target the frame. The animation length is going to be 1 second, and this is what I actually want to autoplay. You can only play one animation automatically. For this animation, I want to insert a key, starting right at the beginning. The value should be 16. And also, this should be looping. From that, we are getting the legs being entirely static, which is fine. Now we have to figure out how to move between idle and run. This we can do in GDScript. And for that, I want to create another function called funcAnimation. If the player is moving, we want to play the walk animation. If the player is not moving, we want to play the idle animation. To get that, first of all, we need the animation player node. The property we want to target is called current animation. In fact, if you have the animation player selected and you look at the inspector, there we have the current animation. At the moment, we have run and idle and reset. This one you can ignore. This you have to give a value, which has to be a string. Let's say for now, I want to go to walk. But this I only want to do if the player is moving, which we know is happening if we have direction X. If that is not the case, else we want to idle. Make sure you are calling this function where you want to call the animation, and now inside of the game. By default, nothing is happening, but if I start walking around, then we are making the debugger really unhappy. Let's see what happened. We have animation not found walk. That's a good way to indicate what went wrong. So check inside of the animation player. We have idle and run. So in other words, this shouldn't be walk, this should be run. Once we have that, this is looking much, much better. So I can idle and I can run. Wrong direction, but generally this works. And while we are here, what we can also do with this sprite to be selected, and in fact, I should rename this to, let's call it legs. These legs by default always point to the right, but if the player is moving to the left, they should be facing left. Which we can get fairly easily. I want to get the legs and then flip H. If the player is moving to the left, I want to flip the legs on the horizontal axis. This value has to be true or false. And we can set it by direction X being smaller than 0. This operation is going to return a Boolean. It's going to be true if we are moving left, and it's going to be false if we are moving right. So with that, I can go to the right, I can go to the left, and that is working pretty well. We don't have jumping yet, but that we can work on next. That part is actually going to be your exercise. I want you to add the jumping animation. This should also be played inside of the game when the player jumps. A tip for this one, via isOnFloor, that is just a function inside of a character body 2D. You can check if the player is on the floor or not. That's going to be really important. Pause the video now and see how far you get. Number 1. Inside of the animation player, we have to add one more animation called jump. For that, we want to add a track, property track. We want to target the legs, the sprite 2D. In there, we have the frame. On the timeline, we want to insert a key, and then find the jumping animation. If you toggle these values, you can see a preview of what we need. There's only one frame for the jumping animation, and it's frame 17. This we do want to loop, and we don't want to autoplay it. That covers the animation player. Good start. Next up, inside of the code, we have to figure out when the player is jumping. So technically, what you could be doing, when we are getting input and the player is jumping, you could change the animation to jump. Although, what would be easier, inside of animation, we can first of all check if the player is on the floor. Only if that is the case, do we want to play the run or the idle animation. If that is not the case, else, then we basically only have one option, the jump animation. Which basically means I want to get the animation player, set the current animation to jump. And then we are done. Inside of the game, I can now jump, and we have some legs that are well animated. That is looking pretty good. That means, next up, we can work on the upper body. For that, we have another sprite 2D, which I can rename to torso. Once again, we want to get player.png, drag it into the texture, and then for the animation frames, I think we had 8 H frames and 3 V frames. Then we want to move this sprite 2D up by a couple of pixels. If you use the keyboard with the arrow keys, this is going to work much better. Let's try it inside of the game, and that is working pretty well. Obviously, we have to actually animate the upper body. And for that, let's think about the problem. If you look at the player frames for the upper body, we essentially have 8 directions that the player can face. This is to the right, bottom right, down, down left, and so on. We have to pick one of those depending on where the mouse is pointing. If the mouse is here, so to the right of the player, then we want to get this first frame. If the mouse is on the left here, then we want to get this one. This unfortunately cannot be done in the animation player. At least not efficiently. This could actually be a pretty good exercise. Try to get the right upper body frame. And just be creative, see how far you get. If you can't do this one, don't worry about it. It is a tiny bit more advanced. Let's go through it step by step. First of all, we need to get the mouse position relative to the center of the player. This we have already done. Inside of get input, we have used get local mouse position and normalized it. That we can reuse. Let me copy it. And inside of animation, I want to get a new variable. Let's call it the raw direction. As a reminder, if I print this value, I can see where the mouse is relative to the player. So there, I have very close to 1 and 0. We are to the right of the player. If I go up, then we are at 0 and -1. These values we need to clean up, so they are more easily accessible. Let's create another variable, adjusted direction. This should be a vector2 with x and y, where x is going to be the rounded value of the raw direction.x. The same thing I want to do for y, except now we have the rounded value of raw direction.y. Let's print this one. That should be a bit easier to see. Now, if the mouse cursor is to the right of the player, we get 1 and 0. If I'm to the left, we get -1 and 0. If I am above the player with the mouse cursor, it's 0 and -1. And so on. This works for all 8 possible directions. What you can also do is set this vector2 to vector2 integer. That way, instead of floating point values, you are getting integers, which I think for this purpose is a little bit cleaner. Both would work though. In this case, it doesn't really matter. So at this point, we have 8 possible values. These we have to convert to the frames that we're getting for the player. This would be frame 0, frame 1, frame 2, and I can actually show it inside of the torso. At the moment, we are on frame 0. The player is facing to the right. If I set this to a 1, we're going down right, frame 2 is down, frame 3 is bottom left. I think the easiest way to connect this vector 2 to the frame is by creating a dictionary. This can be a constant value where we have gun directions, which is a dictionary where, for example, we have a vector 2 integer with 1 and 0. The associated value or the frame is going to be 0. For the next value, we're going to the right and down. The frame is 1. Then we are only going down, so x is 0, y is 1. The frame would be 2. And this is going to continue for a bit. Let me actually copy it all in so you don't have to watch me type for too long. These would be all of the 8 values that we can work with. And if I add a bit more space, then this looks a lot cleaner. I hope the system here makes sense. We have a dictionary where we have a vector 2 with a frame. The vector 2 we are getting from the mouse direction. And then the frame is going to be what we need inside of the player for the right animation frame. Once we have all of that, all we need to do is get the torso sprite 2D and adjust the frame. The value is going to be the gun directions with the adjusted direction. And that should be it. Also, I realized this should all be vector 2 integers. That way, we are keeping constant values. Now let's try the entire thing. And the player is following the mouse cursor. The other animation is also working pretty well. So that is looking really nice. We can also still shoot, although the shooting speed is a bit low, but that's a problem for later. Next up, I want to add a marker, so the player knows the shooting direction. This is also going to be animated, but for this animation, using an animation player would be overkill. It's just too simple of an animation, so we're going to learn a simpler system to create animations, called Tweens. Via those, you can animate any property with just a couple of lines of code. First of all, inside of the player, I want to add a crosshair so we know the direction that we are pointing at. I want to add another sprite 2D that I want to rename right away to marker. For this marker, you can find a texture under UI. There we have crosshair. Drag it in, and we are getting a crosshair. This crosshair we want to place in the right position using GD script, which I guess could be another animation. You could also place it inside of animation, I guess, but let's keep things organized. I want to have a function update marker. All I want to do in here is get the marker and change the position to the position that the player is pointing at, which once again, we have done this a couple of times by now. We want to get the mouse position relative to the center, like so, and then multiply this with some kind of value. Let's say 40. That's basically all we have to do for the position of the marker. Although we do have to call the function update marker. Then we can run the game, and inside of the game, I now have a marker, which is quite a bit too large. To fix that really quick, with the marker selected inside of the inspector, you can go to transform and change the scale to 0.5. For both x and y, they should be linked. Next attempt, and that feels much more reasonable. Now we come to the interesting bit. When the player is shooting, I want this marker to scale down and then scale up again. We could use an animation player. Let's actually do that. I want to use an animation player in which I want to add a new animation. I guess we can call this one this scale. I want to add a track, property track, get the marker, okay, and then the property I want to animate is going to be scale, a vector 2. You could also target x and y separately, but I want to get vector 2 scale. In there, I can insert a key at the beginning. I want to start with 0.5. let's say around 0.2 seconds, scale to 0.1 for both x and y. And then, let's say by 0.6 seconds, I want to go back to a scale of 0.5. If I play this, we are getting a short animation. This we want to play when the player is shooting the gun. All we have to do inside of get input, when the player is shooting, I want to get AnimationPlayer 2 and then play the animation. We need a name for that, scale. That is basically it. If I now shoot, we are getting a short animation on the crosshair. This would work, but it's kind of overkill. The animation player does a ton of stuff, and we only want to have a super basic animation, for which we can use a simpler system. Let me first get rid of the animation player 2 and then of this line, so we don't get an error. That way, we are back to the crosshair not doing anything, besides the position. I want to create what is called a tween, short for in between. All that it is doing is it takes a property and moves it from one state to another state over a set duration of time. To create it, you want to get tree and create tween. Then, on this tween, you have lots of different ways to change a value. The easiest one is tween a property, for which, first of all, we need an object that we want to target. This effectively is a node in most cases. In our case, we want to get the marker. On this marker, we need a string with the property that we want to change. That is scale, or the name, if you look at the inspector, when you hover over it, this property is called scale. This is what you want to target. If you wanted to change the position, it would be all in lowercase position. After that, you need the value that you want to go to, which in our case is a vector 2 with 0.1 and 0.1 for x and y. Finally, we need a duration. Let's say 0.2 seconds. And that is it. With 2 lines of code, we can animate the crosshair. If I now run the script and shoot, the crosshair becomes really small. To make it large again, all we have to do is do another tween property line where we want to have the marker node, target the scale, and now our target scale is going to be 0.5 and 0.5 with a duration of, let's say, 0.4 seconds. The tween is going to play these animations one after another. It first plays this one and then this one, which means inside of the game, we're getting a nice animation. And this is working really well. This you can also customize a lot. For example, you can make it play forever. You can make it play in parallel if you want to. There's a ton of stuff you can do. To learn more about it, you want to go to Help and then look for Tweens. There's a really good documentation for all of it, and this thing is incredibly powerful. Most importantly, you want to work with the different methods. All of this here is pretty much what you need. For example, via tween interval, you can create a pause. Via stop, you can stop an animation. Via set loops, you can set the loops. Via set parallel, you can make the animations play in parallel. And that's kind of it for basic tweens. For a very basic animation, this is what you want to use most of the time. It's a very simple system, it's super reliable, and very easy to implement. Let's practice this one. I want you to scale the bullets when they are being launched. They should start from 0 and go to 1. And this is for both x and y. Pause the video now and see how far you get. To work inside of the bullet, we can simply target func underscore ready. So once the bullet is being spawned, we want to create var tween once again via get, free, and create tween. Then we want to have tween and tween property. On that, we want to target the sprite 2D. Drag this one in there, and then we want to get, once again, the scale. The final value is going to be a vector 2.1 with a duration of, at least for now, 0.5 seconds, so we can see what's happening. This right now is not going to do anything because the default scale of the sprite 2D is already 1 and 1. So what we would have to do is, when we're getting started, get the sprite 2D, update the scale to vector 2.0. That should already be enough. If I now launch the game, shoot a bullet, the bullet is growing when we are shooting it. And that is working. Alternatively, what you can also do, instead of running this line to scale the bullet down, you can add after tween property .from. That way you can set a start value, which in this case is going to be vector 2.0. And now we're getting the same result with one line less. And I think this is also a good bit more readable. Although I guess that can be slightly subjective, but it's still a really, really useful system. At the moment, we only have the player and pretty much nothing else. Let's change that by creating the level. For that purpose, we're going to learn about a new node called a TileMapLayer. Via that, you can create really complex levels inside of a single node. You can also add animations, collisions, and even auto-tiling. Although for now, we're going to keep it simple. Back inside of Godot. First of all, this static body 2D for the floor really doesn't work anymore. Let's get rid of it entirely. Instead, I want to add a TileMapLayer node. Notice here, we have a tilemap and a TileMapLayer, with the tilemap being depreciated. It still works, but you are not supposed to use it. It's just there for backwards compatibility. So use TileMapLayer, create, and then. First of all, nothing happens, although we did get a tilemap button at the bottom of the editor, in which at the moment we can't really do anything. For that, first of all, you want to look at the inspector. There we have tile set, and we have to create a new one. Click on that, and then we get two buttons at the bottom, tile set and tile map. To understand what's happening here, first of all, inside of the inspector, when you click on tile set, you get a whole bunch of options, a tile shape and a tile size. Those are the really important ones. I want to keep all of the defaults here, and then go to tile set and look at graphics and tile sets as well. There we have subway and waltz.png. For now, I want to drag subway.png into this area. If you drop it, then Godot is asking you if you want to create an atlas texture, which we do want to do. Once we have that, I can actually explain what's going on. So, we start with all of this. This is one PNG file. And via this TileMapLayer node, we are separating it into little chunks of 16 by 16 pixels, or whatever you have specified in. You can also get a different shape and a different size, but in my case, the defaults work perfectly. And the fundamental idea is that you can use the tile map via this tile map button, pick one of these parts, and then place it inside of the level, like so. For that, make sure you have this pencil button selected. Then you can draw, and if you have this rectangle tool selected, you can create entire areas quite easily. Although that's not what I want to do. If you left click and you have the rectangle tool selected, you can delete entire areas. And if you have the pencil selected, you can place stuff with the left mouse button and remove it with the right mouse button. The basic way you are supposed to use it is to place tiles deliberately. So this could be one floor. Then I want to place this tile, place it here. Then I want to have this tile, place it there. And maybe this middle bit for a bit of variety. Something like this. Then we would have one part of the level. That being said, if I run the game, this is not going to do very much. Well, it is inside of the game, but the player doesn't collide with it. Also, there should be this one here. We're going to fix that in just a second. But for now, the main thing that you have to understand is that fundamentally, when you're working with a tile set, there are basically 3 steps. Inside of the inspector, you can create a tile set, where you set a tile shape and a tile size. After that, inside of tile set, you can look at what you have created and modify it. That we're going to work on in just a second. Under the Paint tab, you can do a couple of things. Finally, with tile map selected, you can grab different parts, this can even be multiple bits, and place them inside of the level to make them visible. If you spend enough time on it, then you can create really nice levels. Although it is going to take a while. Creating levels is just going to take some work. What you can also do, if you have the tile set open, you get a whole bunch of extra stuff. The most important one for our purposes at the moment is the physics layer. Via that, you can add collisions. First of all, we have to add a physics layer. Then you get the usual stuff, where we have a collision layer and a collision mask. For which, first of all, I want to go to Project Settings, then find 2D Physics, and I want to name a couple of layers. The first one is going to be Terrain, then I want to have Layer. Besides that, I want to have the drones and the bullets. That's all we need. Once we have that, inside of the tile set should be on the first layer, Terrain, and it doesn't have a mask. It doesn't need to see anything. Just to keep things consistent, the player should be, for the character body 2D, collision, we are going to be on layer 2. We can see layer 1, layer 3, and we cannot see the bullets. Only the player can shoot bullets, and the player shouldn't be able to shoot himself. Then finally, for the bullets, the area 2D, for the collisions, it should be on layer 4. It can see the terrain, and it can see the drones. That way, we have collisions covered. Although, if I run the game, this still isn't doing anything. The reason for that is to actually get collisions. These tiles need to have an actual shape for the collision. That you can find inside of Tile Set under Paint. Once you have to find a physics layer, inside of Select Property, you will find Physics Layer 0. In there, once you have it selected, you get this shape, and this you can place on different tiles. If I place it for now on all of these tiles, the one that I have used inside of the game, then I can run the game, and now we have collisions. You can also change them. The basic idea is that you are modifying this shape, for which you can also add snapping, which I would generally recommend. Grid snap is pretty good. I usually go with a separation of 8. And then you can drag these points to a specific part, for example, something like this, and then use them like so. If you click on one, you get a preview, and let's say for this one, I want to be roughly here. This doesn't have to be too precise, but you do want to spend some time on it. Also, via these 3 dots, you get a couple of shortcuts to rotate or flip it. For example, if I press H, then this is being flipped, and I can use it here. Although I probably want to expand it just a bit. Something like that. This I also want to do for this tile, but we do want to cover the entire bottom bit. Like so, and like so. That looks pretty alright. I guess we can do the same thing here and here. And then, inside of debug, I do want to have visible collision shapes. Run the game. And now you can see that we have collision shapes that work pretty well. On top of that, if you put this tile map layer before the player inside of the scene tree, I can run the whole thing again. And now the player is on top of them, which looks a lot better. If I now disable the visible collision shapes, try all of this again, this is looking pretty alright. At least for the basics. Now, in my case, I want to have multiple layers, which effectively means I want to have multiple tile map layers. The one we have created so far is the, let's call it the collision layer. Besides that, And let me organize all of this inside of a node 2D called layers. This should come right at the beginning of the scene tree and contain all of the layers. I want to add another tile map layer. This one is going to be the background layer. And then I want to have a background detail layer. Finally, I want to have a foreground layer called FG layer. Just to demonstrate how this system is going to work. And the BG layer and BG detail layer should come first. So we have background, background detail, collision, and foreground. For the background, I want to create a new tile set. Once again, the defaults here are totally fine. Then inside of tile set, I want to use subway, create an atlas texture. This one doesn't have any collisions. I basically want to grab this black tile. Then inside of tile map, grab the rectangle tool and draw some kind of black area for the background. You can also drag another PNG file into the tile set, like so. Click on yes, and then you get a lot more options. For example, for this one, I can select all of this. And then with the pen selected, I can place something like this. For BG detail layer, I want to have a new tile set. Once again, details here are fine. Then inside of tile set, subway.png is the main thing I want to use. And there, for example, we could use a bin. For that, you want to go to tile map, select the bin, and then place it, I don't know, let's say here. Once we have that, I can run the game. And now we are getting something that is looking a lot more like a real game. Still not perfect, but this is definitely progress. The last thing that I want to do, inside of FG layer, the usual stuff, new tile set, inside of the tile set, I want to add subway.png. I do want to have an atlas texture, and then I want to place, let's say, this light source here via tile map, select it, and then place it, let's say here. Now this should be in front of the player, but inside of the game, this doesn't work. Let me demonstrate. So I can get there, and the player is in front of the light. That is because we have the layers first in the scene tree, and then we go to entities in which we have the player. So the player is drawn after the lights. To change that, with FG layer selected, you can go to ordering, and there you have the Z index. This determines when stuff is being drawn, and by default, you always get 0. If you set this to a 1, then it's going to be drawn after everything else. The basic logic is that Godot goes through all of the Z indexes in order and then draws them. By default, everything is 0. So if this value gets a 1, then this layer is always going to be on top, no matter what you do. Via that system, you can keep all of the layers inside of one node and don't worry so much about the order. Keeps the scene tree a bit more organized, which I think is a good idea. Let's do an exercise. I want you to create a proper level. Make sure that you are adding lots of stuff to it and that the player cannot see the gray background. There should be a proper surrounding area so the player can never leave the level. Pause the video now and see how far you get. Righty, back inside of the level, I'm going to create a level and speed up the video so it doesn't get too boring. Okay, I think that was definitely enough for a reasonable level. I think just by watching the video, you can tell that creating levels does take a while. Simply drawing the border around the level took me 5 minutes just on its own. Now later on, we are going to learn ways about automating this process, where you are placing one tile and then Godot selects the right one for you. Makes the whole thing so much easier. But for now, I think it's a good idea to appreciate how difficult level creation really is. That being said, there's one thing I forgot to tell you. Let's say with the collision layer selected, via this selection button, you can select elements and then copy paste them. Super handy. We are nearly done. There's one last thing that I want to do. Let me run the game again. And we definitely have to speed up the player, but also we can look outside of the level. For that, first of all, with BG layer selected, I want to draw a vague rectangle around the level. So we have a clear border on one side. Something like this looks all right. Don't need this part, I think. But you need those bits, up to here. We need this part, and this part. Then I guess we can cover this area. Nearly done. Here and here. Then we need this area. And we have to cover the entire bottom. Like so. Once we have that, you can look at the top. There Godot is telling you the pixel coordinates. For example, this line here is at around -100. I'm pretty sure it's going to be -96. So what we can do, inside of the player camera 2D, we can go to limit and then go to left -96. Now I can go to the left and we cannot see the background. This gray bit here is because of the window. If I rescale it, then you can see this is just part of the background. If you click on this button, that disappears. And then Godot scales properly. And we can see nothing of the background in the actual game. The same thing I want to do for basically all of the sides. So at the top, we are at, let's say, -32. On the right side, we should have a much larger number, let's say 2780. And at the bottom, we are at around 900. So on the player, this is going to be top -32. Right was, let me go to the bottom right, then I can see both numbers. And if you zoom in a lot, you can tell much better where you are. So 2780 should be right here. Right, 2780. For the bottom, I want to have 960 exactly. 960, and then we shouldn't be able to see the background. Let's try. So I'm going to zoom out a lot. Place the player. I guess we can start in the default position so we can check the top. And that definitely works. Then we can place the player somewhere, let's say here. We cannot see the bottom and we can't see the right. Also, if you move the player around, the purple rectangle around it is the camera. And you can see that at some point the camera stops, which is a really good indicator. And with that, we have a level. It is time to create an enemy, which is going to be a drone. This thing is just going to move towards the player and explodes once there's contact. But the player can also shoot at it, and after 3 hits, the drone explodes. All of this is going to be an exercise right away. I want you to create a drone yourself. For that, it should activate when the player gets in range. That's going to be an area 2D. When activated, it should move towards the player. Once again, the drone is going to be a character body 2D that you move via move and slide with the velocity. Once it gets close to the player, it should stop and explode. So you stop the movement and use the animation player to play the explosion animation. Finally, when the player hits the drone 3 times, the drone should also stop and explode. That is going to be quite a bit, but I think at this point you can manage this. So pause the video now and see how far you get. To get started, I want to create a new scene with a character body 2D root node that we can rename right away to drone. I want to save the whole thing inside of scenes and entities drone.tscn. Then let me move to the center. There we go. To find the drone image, you want to go to characters, and there we have drone, a very basic animation. You can barely tell that it's even animated. We could play all of this via a sprite and, for example, an animation player. Alternatively, we can also get an animated sprite 2D, for which we can set a sprite frame with a default animation, and in there, if you click on this button, you can select from graphics, characters, and drone. We want to have 4 horizontal images and only 1 vertical one, like so. Then we can select the different images. Add 4 frames, and now we can autoplay the animation. That way you get some basic effect. Alternatively, you could have also used a sprite 2D with some GD script, or you could have used an animation player. There are loads of different ways to get a basic task done in Godot. And I really want you to think about the different approaches you could be taking. I think this is the easiest one, but there are alternatives. Besides that, I want to have a collision shape 2D, which I think for this thing can be a circle shape. Let's resize it to something like this. That looks okay. And then, just to test things, inside of the level, in entities, I want to add the drone. Oh, and by the way, at this point, once your levels become a little bit larger, it's really easy to drag the wrong node from the origin point. So instead of the drone, I drag the bullets, which shouldn't be the case. The easiest way to get around that is with the drone selected inside of the scene tree. You want to hold Command or Alt, and then you are only moving the node that is selected inside of the scene tree. Can be incredibly helpful. Besides that, with the bullets selected, you can also lock them via this button. That way, you can't move them anymore. The same thing I want to do to layers and to entities. They shouldn't be draggable inside of the game. There are a couple of useful buttons at the top. I would recommend to go through them when you have time. There's, for example, a ruler in there, or there's grid snap, can be quite helpful, but I want to focus on the basics, which is the drone. Let's run the game and see how it looks. That looks pretty respectable. Now that we have that, I want to create an area 2D node, which I want to rename to detection area. To that, I want to add a collision shape 2D, which is going to be a circle shape that needs to be reasonably large, something like this. Let's see how it looks in the game. And I think that's a good detection area. If the player gets into this range, the drone is going to activate, for which we want to add a script. The defaults here, as always, are totally fine. And for the detection area, I want to go to node and then body entered. Although, first of all, I forgot one thing. With the character body drone selected, I want to go to collision, and this should be on layer 3. It can see the terrain, it can see the player, and it can see the bullets. Besides that, for the detection area, collisions, it shouldn't be on any layer, and it can only see the player. And for now, let's simply print the body that we are getting. It should only be the player. We can actually rename it to player. And this has to be a character body 2D. And the player is being spawned right next to the drone. But if I go outside and come back, this should be enough. We are going to see player again. So that is definitely working. Once we have that, I can create a var direction. As always, this is going to be a vector2 without the default value. I want to have a var speed. This can be an integer with a value of, for now, let's say 50. And I want to store the layer, a character body 2D. Now, inside of this function, when we are getting the player, I want to assign the player to player. So I want to get the variable and assign the parameter. Although you can see this logic is going to be quite confusing and Godot really doesn't like it. This causes a ton of errors. I guess inside of the parameters, we can call it the player body. Now, once we have a player body, I want to run func_physics process and check if this value exists, so there's anything inside of this variable, then this if statement is going to trigger. If there isn't, it is not. All I want to do, if we have a player, is first of all get the direction to the player. Let's call it var dir. This we can get from vector math. We need the player.position, and from that subtract the current position of the node. This we also want to normalize, like we have done for the bullets. Super important, so that when we are multiplying the direction with the speed, we are getting a constant speed. Speaking of which, all we have to do is get velocity and assign it direction multiplied with speed. And also, we want to call move and slide. To test all of that, I want to move the drone and the player a bit further apart so I can actually walk into this area. Let me try. And now, if I get close enough, the drone starts moving towards the player. And we really should increase the player walking speed. It is really, really slow. I guess 120 should be quite a bit better. That feels definitely better. Now I can also run away from the drone. If the player goes outside of the detection area, the drone should stop, which we can check via body exited. Once again, we have the player_body, which has to be a character body 2D. You don't have to rename these, but I think it's good practice. It just makes the entire thing much more understandable. If that is the case, I want to remove the player body from the player variable. To do that, I want to get the player variable and assign it a value of null, which is empty. Once we have that, back inside of the game, I can walk towards the drone, it follows me, and if I run away, it stops. This works multiple times. Perfect. Also, Godot is really unhappy with us because inside of physics process, we don't use delta, and inside of player body, we don't actually use the player body. So we should add an underscore before it. If I now try this again, the debugger should be happy, and that looks much better. Now we have a drone following the player. After we have that, I want to play an explosion once the drone gets really close to the player. For that, first of all, I want to add a sprite 2D, which we can rename to explosion sprite. Inside of the inspector, for the texture, I want to get fire and explosion, which is an explosion with 1, 2, 3, 4, 5, 6, 7, 8 frames, or 8 H frames to be specific. These we want to animate via the frame property. For that, you could use another animated sprite, although to practice things, I want to add an animation layer, which is going to get a new animation, explode. I want to add a track, property, explosion sprite, and get frame. With the timeline open, I want to go to the explosion sprite and then set the animations. I can select all of them. We should be going from 0 to 7. So the first one is 0, and we go all the way to 7. And I think this might be a bit too fast. So we want to space things out. I can just select all of them and then give each 0.1 seconds. Like so. And so. Then the entire duration of the animation should be 0.7 seconds. Let's try it now. And for some reason, the first frame is always a bit longer in the preview, but inside of the game, this isn't going to be an issue. Which means, next up, I want to add another area 2D node to the drone. This one is called collision area. Once again, I want to have a collision shape 2D, which is going to be a circle shape, And this one should be just a bit larger than the drone, something like this. Also, for collision, you don't want to be on any layer and you can only see the player. If a body enters now, then we want to explode the drone, for which we don't need a body, so this one can get an underscore. All I want to do is get the animation player and play explode. Let's see if that works. And that is maybe not ideal. First of all, the explosion sprite should not be visible. By default, it should be hidden, so click on the eye, and then once the node collides with the player, I want to get the explosion sprite and show it. Next attempt. Much better start, and now we get one explosion. This happens multiple times, so we can test things. We are nearly done. The one issue that we have is that when the drone is exploding, so somewhere here, we don't actually get rid of the drone, it sticks around. To fix that, first of all, when we have an explosion, the drone should stop moving, which we can do very easily. We just have to set the speed to 0. That way, if the drone gets close, it stops moving. Good start. Besides that, I want to hide the animated sprite 2D, so we can't see the drone anymore. That part is also super easy. Animated sprite 2D and hide. Also, the explosion sprite by default shouldn't be visible. Once we're doing that, the drone can move towards the player, and this almost works. Basically, what we now have to do, once the explosion has finished playing, we want to delete the entire scene, which we can do in two ways. Either with the animation player selected, inside of node and signals, you have animation finished. You could delete the node when this function is running. Alternatively, which I think is the better approach, inside of this function, we can await the animation layer dot animation finished. We are waiting for the animation to be finished, and then we want to delete the node via Q3. Let's try this one. And now, if the drone comes to us, it explodes and disappears. And I realized the bin here really doesn't work. But first of all, let me explain why this line is really important. If we didn't include it, we would play the animation, but then delete the node right away, which means we wouldn't see the animation. Now the drone simply disappears. Now we are still playing the animation, but we are deleting the entire thing right away, so you can't really see it. For which we have this await line, and then everything works just as expected. Next up, when a bullet hits the drone should lose some health. Inside of the bullet, I want to check for a body entered and connected to the script of the bullet. For now, let me simply print the body that we want to target. Also, the bullet speed is incredibly slow. 30 is just not very good, and this should be speed anyway. Integer with, let's say, 100. And then this speed we want to use for the bullet. Let's try all of that. If I now shoot at the drone, I do have to make sure I hit it. There we get drone. Also, we get collision layer. That is expected. The bullets can see the drone and the terrain. If a drone hits the terrain, I simply want to delete the bullet, which we can do via Q3. However, inside of the drone, I want to have a func hit, which for now simply prints drone was hit. Once we have that, inside of the bullet, I want to check on the body that we're getting from the parameter. If there is a hit function, I want to run the hit function, but only then, so that when we are getting the terrain, we are not doing anything. And just to demonstrate, before Q3, I want to run body.hit, which is going to work for the drone, but not for the terrain. Let me get to the drone, make sure I hit it on the first try. There we go, drone was hit. This one works. But if I hit anything else, then Godot is going to crash because there's no hit function inside of TileMapLayer. We first have to check if the hit function exists inside of body. That luckily we can do very easily. If the string hit is in body, that's all we needed. Via that, Godot is checking if there's a hit function or property inside of this node, and then it is going to execute it. So next attempt. I can now shoot at the drone a couple of times, make sure I hit it. That looks good, drone was hit. And if I hit anything else, the drone just disappears. That means, finally, inside of drone, I want to set var health, an integer with a default value of 3. This we then want to reduce, so health minus equal 1, and we want to check if health is smaller or equal to 0. And then I want to play basically what we have done in here. In the most basic sense, you could simply copy all of this and you should be good to go. Let's try. For that, I have to make sure I hit the drone. 1, 2, and 3. We get the explosion and the drone disappears. That being said, you shouldn't copy lines of code like this. It's a really bad practice. A better way of approaching that would be to create another function. Let's call it explode. We want to have all of these lines, paste them in there, make sure the indentation is correct for all of them. And then, if health is below 0, we want to explode. And if the drone gets close to the player, we also want to explode. That way, you are referencing the same code twice. And if you want to make changes, it's really easy to do. So let's try. I can get to the drone. I can shoot at it. It explodes. That looks good. And if I just get close to it, then it also explodes. Perfect. With that, we have the basic drone. There's one more mechanic that I want to add. When a drone explodes, it should damage everything around it, including other drones. To achieve that kind of effect, we have to group all of the drones, via which we can introduce a new mechanic. Back inside of Godot, if you look at node, besides signals, we have groups. Those can be incredibly useful. For example, inside of the drone, with the root node selected, I can create a new group and call it drones. Then we have a scene group. What can we do with that? Well, inside of the level, let's say when the scene is ready, func_ready, I want to print everything inside of this drones group. If you look at the scene tree for the drone, we now have this symbol, indicating that the node is inside of a group. If you hover over it, Godot is telling you what the group is called. To access all of these nodes, all you need is get_tree, don't forget to call it, and then you can get nodes in group, or you can get first node in group. Quite often, if you want to have access to one node globally everywhere inside of the script, like for example the player, you might have a group dedicated to the player only. Then get first node in group usually makes sense. But for our purposes, we want to get nodes in group. Then we need the group name, which in this case is drones. If I now run the game, I am going to get an array with one node inside, the drone. If I add multiple drones, let me duplicate it, and I don't want entities to be locked. That way we can move stuff inside of it. I just want to have a couple of drones, like so, so, and so. If I now run the script, we get an array with 4 drones. And that is pretty much all you have to know about the basics of groups. When you have a scene, you can assign the node to a group, and then every time you create an instance of the scene, you have access to that via the group. And this, by the way, is going to work everywhere. We can check inside of the game scenes for all of the drones, and we can check inside of the drone itself. For example, in there, I want to have func_ready as well, and then simply copy from level this one line. Then I can run the script, and now we should get the same output a couple of times, and that looks pretty good. Every single drone is going to output this print statement. Via this system, you can target scenes basically anywhere inside of Godot, and you're not really constrained by any kind of scene setup. Now, to test all of this, I want you guys to implement the drone explosion. Basically, make nearby drones explode when the drone explodes. You can set the range yourself, just choose something that you think looks good. Pause the video now and see how far you get. I want to work inside of the script for the drone, and we don't need the ready statement anymore, and we also don't need it inside of the level. All of this can go. Instead, when the drone is exploding, this function here, before we are running Q3, but after the animation, I want to, for drone, in get_tree and get nodes in group. The group I want is drones. This works because the return value of this function is an array, meaning we can use a for loop to get every single item inside of it. All we have to do then is drone.explode. Although this we only want to do if the drone is within a certain range. Now, to test all of this first, inside of level, I want to move all of the drones really close to the player so we can see them at the same time. If I now run this, we get the drones, and if one of them explodes, they all explode. That being said, inside of the drone, we only want to explode nearby drones. That we can do via the current position, and then we have distance to. We want to check drone.position. If this value is, let's say, smaller than 10 pixels, then I want to run drone.explode. Also, this should be an if statement. Let's try this one now, and we have to make sure that the drones are close to each other. And well, that was quite hard to see. Let's move one drone over here so we can test things a bit better. The drones explode, but this one is totally unaffected. And if I move the player just a bit further to the side, like so, meaning we don't trigger the drones automatically, then I can play with this a bit better. So I want these two drones right next to each other. Then inside of the game, make sure you don't move forward. And now I just have to shoot at them, actually hit, and I guess we need to have a bit more of a distance between them. Let's try 20. And that works much better. So this would be the most basic setup. However, back inside of the game, if I simply explode the top drone, you can see that we have the explosion and then this waiting time, which is kind of annoying. Ideally, we want to explode the other drone while this animation is playing. Or to be a bit more specific, if I open the animation player, inside of explode, we want to probably damage things somewhere here. How could we do that? And well, first of all, we will need another function. Let's call it func_chain_reaction. This function doesn't need a parameter. All we want to do in there is effectively this for loop. Let me copy it, then paste it in there. After that, it's really important that this script is saved. There shouldn't be an asterisk right next to it. But for now, let me not save it. Because what I want to do inside of AnimationPlayer, in the animation, I want to add a call method track. If I do that, then Godot wants to have a node. I want to get drone. On that node, I can insert a key, and this key is going to be a method that we want to call. We do have all of the inbuilt ones of character body 2D. For example, move and slide, or is on floor, whatever you need. But besides that, we also have the functions that we created, like hit and explode. But notice here, we do not have chain reaction. That is because this script was not saved. If I save it, so the asterisk has disappeared, then I can add another key, and now we get chain reaction. This can be a really annoying beginner mistake. But now, when we get to this point in the animation, Godot is calling for you the chain reaction function. Which means, inside of the game, I can shoot at the drone 3 times, and we get a much better effect. And with that, we have the drones completed. Next up, I want to add lights. That way the game is going to look significantly better. For all of that, back inside of Godot. First of all, I only want to have a single drone. So let me delete all of the other ones and move this drone to the side. We are going to add lights to this one later on, so we get a bit of a blinking effect. But that's going to come later. First of all, to add lights. With the level node selected, I want to add a node and simply type light. For the 3D nodes, we have a ton of different lights, but those we don't care about yet. For 2D, we have 2 kinds of light, a directional light 2D and a point light 2D. The point light 2D is basically a lamp, whereas directional light is more or less the sun. Let me add this one first. If I do that, then you can see the entire level is much, much brighter. If I hide it, then you can see the effect much better. Also, on the right, we can change the color to whatever you need in here. And you can even change the blend mode, so you are subtracting the color instead of adding it. If I change the color to something red, then the level will become green, because we are removing all of the red values. Can create interesting effects, but not what I want to do right now. Besides that, we can change the energy, and this one changes, well, the energy. Something you want to use very, very carefully. I guess for now, what I want to do is to make the color much darker, something like this. Then for the blend mode, I want to mix the color. So we are mixing basically all of the layers with this color. And this is definitely too dark. I guess something like this works a lot better. And to see the difference, if you toggle this node, this is very much noticeable. For all practical purposes, we now have a sun that makes things darker. Besides that, if you look at the inspector, we also have shadow. This we can enable, but at the moment it's not going to do anything. I guess to make it visible, let me change all of this back to normal and then add another node. The node I want to add is light occluder. This is basically a collision shape for lights. If you add it, by default, nothing is happening, and Godot is giving you a warning that you have to add a polygon. Inside of the inspector, in the includer, you can add a new occluder polygon 2D. Do that, and then still nothing happens. But now at the top, you get 3 buttons that let you draw a shape. Let me draw something random, like so. And now, this shape is blocking the light, and anything below is casting a shadow. For that, you do want to make sure that shadow is enabled. If it isn't, then this is just blocking out the light. You might also be wondering, why do we still get a warning for this occluder node? If you simply go outside of the scene and come back to it, it is disappearing. It's just a small bug, doesn't really matter. Now, for this scene, I don't want to do that. So let me get rid of it. And for the directional light 2D, I want to set the blend mode to mix and the color to something darker. So we get more atmosphere inside of the game. Let's see how that looks. And that is definitely a change. Just play around and see what you like. Now the second kind of light that we can work with is a point light 2D, effectively a lamp. If you add that one, once again, by default, nothing is happening. Because for this light, you will need a texture. Inside of graphics, we have lights, and there we have a couple of textures. The one you want to use for now is called main.png. If you add that one in the origin of the game, we have a light source that is defined by this texture. If we have white points, we get a lot of light. If we get more grayish points, we get much less light. And this works together with the directional light. If I make everything super dark, then you can still see this outline. You can also scale it inside of the point light. You have a texture scale, and you can make it smaller or larger. You can also offset the entire thing, although this is not what I want to do, but besides that, you can also mess with the color and do something weird in here. You can update the energy and the blend mode. Shadow also works in exactly the same way. Now in my case, I don't want to do any of this, and for directional light, I want to have a bit more visibility. Something like this. And then I want to add the point light 2D to the player character. Inside of the player character, point light 2D, along with main.png. Then the player is going to be much brighter, which does look a bit weird, but back inside of the level, we get a pretty nice effect. And by the way, what you can also do, if I add another point light 2D to the level scene, if you click on the drop-down arrow for the texture, you can create new textures from scratch. For example, there is a gradient texture 2D. If you click on it, you are getting a texture that you can modify right inside of the engine. So if you look closely, let me zoom in a bit, and I guess if we move this thing over here, it's much more visible. This gradient can be changed inside of the editor, and then you are getting a real-time preview of how it's going to look. This you could, for example, use all the way on the right. We have a couple of doors that could do with a bit of illumination. Let's move it here. And then we can move the light roughly here. And you can already see, if I toggle this light, this is making a difference. We can maybe move it a bit more like this. Besides that, if you change the color, you can reduce the amount of red and then make this thing a lot greener. Although you do want to play around with what looks good in here. I guess adding a bit of red to it could be a nice effect. I hope you get the idea. Via this system, you can make things look much more appealing. If you compare this door to this door, this one just looks better. And finally, what we can also do by adding another point light. We can illuminate this sign, for which we have l3.png. You can already see if I drag it around, we have the right light source, and this one's being spawned in the origin point. But I want to have it here. That way, this sign is looking much more interesting. Inside of the game, it is now illuminated, and it works along with the player. If you compare this sign to the other sign, you can definitely tell the difference. Also, what we can do. If I have the point light selected, we can, for example, change the energy and make it flicker just a tiny bit inside of the level script. When the scene is ready, func_ready, I want to create, let's call it light tween, for which I want to once again create a tween. And by the way, you can either get the tree and then call create tween, or you can simply go to create tween right away. Both would work. Choose whatever you like. Then for the light tween, I want to tween a property. The node I want to target is point light 2D2, this one, and on there, I want to get energy. As a string, energy, the final value has to be a float for now, so we can see something, let's say 10.0. The duration could be 2 seconds. If I run the game, you can see the sign is definitely getting brighter. This should be much less strong. 1.1 maybe. After we have that, I want to duplicate the line and go to, let's say, 0.9. That way, you are going to get a very, very minor effect. And this I want to play forever, which we can do via light tween and then set loops. If you don't add any value in here, let me open the documentation. If you add any kind of value in there, like a 2, you're going to play it twice. But if you call it without any arguments, it's going to run forever, which is exactly what we want. That way, inside of the game, it's going to be quite hard to see. But if I make the value stronger, let's go with 1.5 and 0.5, then you should definitely see it. There, you can absolutely see that this is making a difference. I think the main issue is that this 2 seconds is a bit too long. 0.3 maybe. Now we have more of a flashing effect, but you get the idea. Let's stick to 2 seconds, and then we get at least some kind of effect. Should be something to indicate that here is an important part of the level. Anyway, this is kind of all you have to know about lights to get started. You have either a directional light 2D for the sun or a point light for a specific kind of light source. For those, you have to add a texture, which you can either create yourself in something like Photoshop, or you can create them via the drop-down menu. To practice all of this, I want you to add a drone light, which is basically going to be a red light that flickers on the drone. Animate this via the AnimationPlayer. You could also use a tween, but I want you to practice using the AnimationPlayer. That one is super important. Pause the video now and see how far you get. I want to work inside of the drone. And for now, let me hide all of the areas so we can actually see what's going on. Much better. First of all, I want to add a light to this red part of the drone, for which I can add a point light 2D. I still have it selected, and then add a main.png file. Now we're making the entire drone much too bright. That is because this light source is quite large. To scale it down, you can set the texture scale to 0.1, and then you can see a bit better what's going on. We have a light source that we want to be, let's say, here. Besides that, I want to change the color to something more red. For that, reduce the amount of green and blue, and then we are already getting close to the effect that we want if I simply toggle the color. Alternatively, what you can also do is change the energy to something like this, where we toggle between a value of 1 point something and 0. Let's say 0.3. This we want to do via the AnimationPlayer. We already have one. In there, I want to create a new animation for the red light. I want to add a track for property. I want to target point light 2D and then target energy. Open this one. The duration for the animation can actually be 1 second. I want to start with a key. The value for the light should be 0.3. You can see a preview. If I now go to, let's say, 0.4 seconds, I can add another key with a value of 1.2. This animation I want to loop. Let me run it. And just in case you're confused, we're starting at 0. Then we go to this value. And then Godot automatically tries to go back to this original value, which is why we are reducing the light already. And we can just loop the entire thing, and then we have the effect already. If you ping pong this value, you are playing the animation back and forth, which could also work. If you reduce the animation length to half a second, it's going to do pretty much the same thing. Just choose whatever you prefer. With that, inside of the game, we can look at the drone, and it still explodes. That looks good. At this point, we have basically a game. However, I want to make this thing look a bit more interesting. Specifically, once a drone gets hit, it should flash. For that effect, we have to learn a new topic that does get quite a bit more complex, called shaders. Using shaders, you can do a crazy amount of special effects, and I am only going to cover the absolute basics. But fundamentally, all that we are going to do is that we are going to determine how elements are being displayed. That means, if you have the Godot logo, for example, and this would also work with any other graphic, when we are displaying this in the game engine, What internally happens is that the GPU separates this thing into smaller chunks and draws each of them individually in parallel. And this process you can manipulate. For example, you could tell the GPU to draw this part purely in yellow, or make this part white. You can also change the position. For example, you could move this top part here further to the right. Via this system, you can turn a 2D graphic into basically anything else. There's actually a whole website for it to give you ideas in terms of what you can do. It's called GodotShaders.com. If you click on shaders, there you can get an idea of what you can do with them. Canvas items are for 2D shaders and spatial shaders are for 3D objects. If you look at canvas items, there you can see that you can do a crazy amount of stuff using this system. But keep in mind, all of this does get a lot more complex. But I want to keep it simple, so we are only going to do the absolute basics. For which, back inside of Godot, I want to work inside of the drone, and specifically inside of the animated sprite 2D. We only have to apply a shader to the visible sprite, which is the animated sprite 2D. To give this thing a shader, you want to go to Material, and there you can give it a canvas item material or a shader material. Shader material is what we want to go with, so click on that, and then nothing happens, but you do get a sphere. That's a preview of what the shader is doing. If you click on that, then you can create a new shader. There are two types of shader, a script-based shader and a visual shader. I actually want to work with a visual shader. Then we have the mode. You have canvas item, spatial, particles, sky, and fog. Particles, sky, and fog I think are self-explanatory. Canvas item is for 2D items, sprite 2D, animated sprite 2D, things like that. Spatial shaders are for 3D objects. Don't worry about those yet. We do want to create a canvas item shader, and then we have to save it somewhere. In my case, I tend to prefer to save all of the shaders inside of a folder called shaders. That keeps things a bit more organized, but you could save it wherever you want. It doesn't really matter. After you have that, click on Create. And then nothing happened. To actually do something, you have to click on this item again, and then you can see. Let me expand it. We have a field where we can create a shader using visual nodes. The most important thing is the output, and to that thing, we can add different information. The only two values that we care about are color and alpha, although there are quite a few more. And next to them, the dot determines what kind of data type we are working with. Gray means Godot is looking for a floating point value, and shades of purple mean some kind of vector. Color wants to have a vector 3 for red, green, and blue. Down here, we have shadow vertex. This one is a lighter shade. This is going to be a vector 2, which doesn't matter for now. And fundamentally, the way this system is working, let me show the drone and the output node. If you right-click on this field, you can add other nodes. For example, in there, if you look at color, we have under variables a color constant. If you double-click on that, you get a color constant with a golden node. If you click on this arrow, Godot is telling you what the individual parts of this node are. We have red, green, blue, and alpha, meaning this is a vector 4, which is fine for our purposes. Effectively, what you want to do, you want to drag this node into color, and then we have turned this node white. Also, you can see that Godot has converted a vector 4 into a vector 3, which it is doing by discarding any extra information. Meaning from this vector 4, we have red, green, blue, and alpha values, but to this color vector 3, we only get 3 values, red, green, and blue, meaning alpha was discarded. And well, now, inside of color constant, we can change the color, and this will show up inside of the game right away. If I launch the game, then you can see that the drones are now colored in this specific way. On top of that, what we can also do, let me give myself just a bit more space, like this. Right now, we work with the color values, but besides that, if I right-click again, we can add other nodes. and most of the time you are simply searching for the node you are looking for. For example, I want to add a float constant and then connect this to the alpha value, which right now makes the drone invisible. That is because we have set alpha to a value of 0.0. If I set this to a 1, then you can see that we have made every single pixel visible. The reason for that is, if I disconnect this node, a computer graphic is always a rectangle. This red outline you see is the actual graphic. The reason why we can see a drone shape is because all of these pixels are invisible. But via the shader and the alpha property, we can make all of these pixels visible. As a consequence, we would get a rectangle, which obviously is not what we want to do. That being said, if you have disconnected and set it to a value of 0.5, then you have 50% transparency. But once again, not something that I want to do. We have to learn about just a few more nodes. One of the most important ones is called color, and you want to look for vector for color. This is different from color constant, the one that we have just used, because this is giving us the current color of every single pixel inside of this graphic. If I create it, then once again, we're getting a node with a golden output, meaning this is a vector 4. But this isn't a static color like we have done here. Instead, this is the color that is inside of the original graphic, meaning if I connect it to color, then we get the original drone. If I expand it and only use the red pixels, then we get a grayscale image where the red pixels are brighter. This would work with all of them, which can give you some fairly interesting effects. You can also get only the alpha values, like so, and that way we would get a white drone. So fundamentally, what is happening now? Let me draw this actually. The way you want to think about shaders, and this can be a bit confusing, is Godot internally via the GPU separates the graphic into individual chunks, something like this. For each of those chunks, let's say this one to get started, Godot is getting a whole bunch of information. Most importantly, at the moment, we are looking at the color, meaning for this chunk, we're getting the red color, the green color, the blue color, and the alpha value. And currently, we are taking the alpha value, which for this pixel is a 1, and set this to the value of the color. Since for this color, it wants to have a vector 3, which needs to have a red value, a green value, and a blue value. But from alpha, we only get one value, which at the moment, once again, is a 1. To make this conversion happen, Godot is setting the value of all three of these to 1. So 1, 1, and 1 for R, G, and B, and as a consequence, we're getting 1 as the actual color value. If you want to learn more about it, I have made a couple of shader videos on YouTube. Check those out for a lot more detail. But once we have this kind of setup, what we can also do is get our float constant back. And then, if we want to modify the alpha value of this graphic, all we have to do is multiply this alpha value with the float constant, which we can do via a multiply node. And notice here, we got multiply and then a data type to the left of it. This is for float. We also have integers, and if you scroll down, we have vector 2, 3, and 4 as well. At the moment, we only want to work with the floating point values. And fundamentally, I want to multiply the float constant with the alpha of the original pixel and set this as the alpha value. Also, I don't want to use the color value for now, and right now we can't see anything because this float constant is 0. If I set it to 1, we're getting the original. If I set it to 0.5, then we are making the drone semi-transparent. And also at this point, we can get the color constant back, and now this is working like you would expect it to work. I can set this thing back to 1 or to 0.1, and this works pretty well. And once again, just to understand the system, via this input node, we're getting the original color, so red, green, and blue, along with the alpha value. And this alpha value for every single pixel, we are multiplying with some constant via this node, which we are then setting as the new alpha. Pixels that are invisible, like all of these pixels around it, stay invisible because they, from the original input node, have a value of 0. And anything multiplied with 0 is going to be 0. So I hope that system makes sense. Once again, getting used to shaders does take a while. Don't rush yourself with this one. In my case, to make the drone flash, I actually don't want to do any of this. Instead, I want to add a color parameter. And this color parameter basically gives us a color. We can set a default value and then, like we have done before, set some kind of value. The default is white, and this is what I want to use, but you could change it to whatever you like. Once again, this color we could use for the color, and then we get an output. So far, this is identical to the color constant. The difference is that this color parameter can be changed inside of the inspector. So let me connect it to the output, and then, if it is connected to the output in the inspector under shader parameters, you can see a color parameter, and you can also change it. That way, we can work with the shader from inside of GDScript. And effectively what I want to do, let me expand this again. I want to mix this color with the original graphic and then control which one we see. For that, Godot has a mix node. And keep in mind here, we want to mix a vector 3 for the color. Create this one, and then Godot wants to have 3 values. 2 for the colors, and then for the weight. The first color is the one we get from the color parameter. The second color is the original color from the graphic. So vector for color. This we want to connect to the second one. The output is going to be the color. And right now, this thing is set to 0.5 for every single one of the colors, meaning we are mixing the original color with the color parameter, which currently is white. To change this value, all we care about is a float parameter. This, like the color parameter, gives you a parameter that you can change inside of the inspector. And this I want to connect to the weight. Once again, we are converting a float to a vector 3. The way Godot is doing that is it assigns the value of the float to all 3 values of the vector 3, meaning R, G, and B are all getting the same value, which is exactly what we want. Inside of the inspector, we have a color parameter and a float parameter. And if I change the float parameter to 1, you can also just type a value in here, then we only get this original color. If I set it to 0, then we only get this color parameter. If I set it to 0.5, then we are mixing these two together. And that is pretty much all we need. Although one thing I do want to do, to have easier names, this should just be the color. And for the float parameter, let's call this one progress. Once we have that, we have to figure out how to target all of this from inside of GDScript. For that, inside of the drone, specifically the hit function, besides reducing the health, we want to do animated sprite 2D. I want to get the material, and on this material, we have a shader parameter. Although in this particular case, I want to set the shader parameter. You want to have the name of the node first of all, which in our case is either going to be progress or color. For now, I only want to work with progress. So progress, and then the second argument is going to be the value we want to set to it. Let's have a quick look. Once again, inside of the drone, if we set this to 0, we get the white color. If we set it to 1, we get the drone. As a consequence, the default should be 1.0, so we can see the drone. But once the drone gets hit, this should be set to 0. And once the drone gets hit, we want to get a value of 0.0. Let's try this one. By default, the drone should have the normal color. That looks good. And once I hit it, the drone becomes white. And that is working really well. That's a good start, but this should be a bit more animated, for which I want to use a tween, meaning var tween create tween. Like we have done before, I want to tween a property where we want to get the animated sprite 2D dot material. The property we want to target is called shader underscore parameter slash progress. Or this progress is whatever value you set inside of this field. After that, we will need a target value 0.0 and finally a duration. Let's say 0.3 seconds. Once that's done, I want to duplicate the line and then set the value back to 1.0 over a duration of, let's say, half a second. And then we don't need this last line. Let me get rid of it. I can run the script again. And now, if I hit the drone, it flashes, and after 3 hits, it disappears. And perfect. With that, we have shaders along with tweens. We are nearly done with the game. I just want to add some very minor parts. First of all, I want to play sounds. There are only 2 sounds for the explosion and the laser. This part is actually going to be your exercise right away. Add the sounds for the laser and the explosion. Pause the video now and see how far you get. For the laser, we want to work inside of the bullet and basically play the sound whenever this thing was spawned. Which means I want to add an audio stream player to D. We don't have to change the name, but I do want to add laser.wav. It's going to sound like this. This we want to play whenever this bullet is spawned. When the scene is ready, I want to get the audio stream player to D and play it. Let's try. That is working pretty well. Besides that, for the drone, when the drone explodes, inside of the explode function, I want to play another sound. I want to add another audio stream player to D, which gets the explosion.wav sound, which we then want to play once the drone explodes. Right at the beginning, I want to get audio stream player to D dot play. Let's try this one. Now this kind of worked with a couple of issues. Let me play it again actually. And pay close attention to it. If I shoot the drone 3 times, we get the explosion sound twice. If I just play the sound on its own. You can hear it, we only have it once. And if I, inside of explode, print explode, and try the whole thing again, you can see the issue. Once again, I want to shoot it 3 times. We can see explode twice. That is because once the drone's health goes below 0, we are calling this function. And then we are playing the explosion animation, this one here, for which we are playing the animation, and then we are calling chain reaction, where we are checking if a drone is nearby, and then we are calling explode again. As a consequence, this function can be played twice. This we obviously want to avoid, which we can do in a couple of different ways. I think the easiest one would be var is underscore exploding, which is going to get a Boolean value that by default will be false. When we are getting to health below 0, I want to set is exploding to true and call explode. That way, we are still doing all of this. After that though, inside of chain reaction, I only want to call drone explode if not is exploding. That way, we're doing all of this only once. And just to test things, Let me print explode once again. Although now we should only hear the sound once. And that feels much better. Besides that, I guess let me run the game again. The bullets at the moment are really, really slow. The player can even catch up to them. That's an easy thing to fix. Inside of bullet, the speed should be something like 200. Let's try that. And now this feels much more realistic. Besides that, inside of the level, this bin is really, really annoying. For that, we want to work on the FG layer and simply get rid of it. Then inside of BG detail layer, I want to find the bin again. It was here, and draw it in the same position. Like so. That way the thing is actually in the background. The last thing that you want to do for your game is to add a lot more drones throughout the level. So this would just be distributing the drones all throughout the level while making sure that you have a fun game. I guess that's a thing that you can do on your own. We have the second proper game, and at this point you have a pretty good idea about the basics of Godot. So just practice and see what games you can make. It is time to get started with 3D game development. For that, we're going to create a basic spaceship shooter. Not the most complex game, but enough to cover 3D game development. Fortunately, in Godot, 3D mostly works like 2D, in the sense that you are still placing nodes and scenes, you use GDScript and signals, you're using layers, you're getting input, things like that. These concepts do not change. On top of that, a lot of 2D nodes have a 3D equivalent. A sprite 2D becomes a sprite 3D, a static body 2D becomes a static body 3D, a camera 2D becomes a camera 3D, and so on. This happens to a lot of nodes and makes it quite accessible. On top of that, there are loads of nodes that remain exactly the same. Timers, for example, don't care if you work in 2D or 3D. Same for the animation player, it just plays an animation. It doesn't care about the dimensions. That being said, there are going to be some changes. Most importantly, we are now working with a third dimension. We have X, Y, and Z coordinates for basically everything. Besides that, lights and cameras are becoming much more important. In fact, without using them, you pretty much don't get anything useful. Finally, we're getting visuals from objects, not drawings. Meaning we're going to start using 3D files with graphics and animations. Or we use Godot to create basic shapes. Both would be possible. And just to explain in a bit more detail what that means. Here is the character from our first game. For all of this, we are using pixels. This would be 1 pixel, this is another one, there we have another one, and so on. Somebody spent a ton of effort to put all of these pixels in their position with the right color. After that, we are taking an image, and if we want to animate it, we are cycling through different images. And that's all we really do. Fundamentally, we are just showing different images. This is all we need for 2D, but for 3D, this obviously doesn't work anymore. For that to work, we need a different system. That system is going to look something like this, where we have a 3D object that we can look at from different angles. The way all of that works is that this object is defined by a lot of different points. For example, this would be a point, this would be a point, this would be a point, and this would be a point. If you connect these 4 points, you are getting a surface that you can add a color to, which would also be visible from every single angle. You can even change these points. So here is the edit mode, and I can drag any of these points and move them around and thereby change this object. Although not something I want to do, but something I could very easily do. Let me change this point, then you can see it a bit better. We are basically creating a whole bunch of points and then connect them in a 3D space. Every single one of these points has an X, Y, and Z coordinate. Along with that, each point is also connected to other points, and if these points are connected, You can add a color to them, and that way you're getting a surface. That's the basic principle for pretty much any 3D object. This is still a very simple object. These can get much more complex, and they can also have animations. But that's not too important for now. The only thing that you really have to keep in mind at this point is that we are not working with images anymore. Instead, we have 3D objects. But enough with the theory, let's work in Godot. And in this project, I already have a couple of files. We have a few audio files, those don't really matter. And inside of graphics, we have a lot of stuff. In there, we have a ton of files that are usually called .glb. This is the file format that you want to use the most for 3D game development. Via that, you can store 3D shapes and animations. Super handy. Although keep in mind, there are alternatives, but GLB is the most common one. You can find all of these files inside of the description. Make sure you have them ready, but for now, I just want to work in the 3D space to get started. You want to have 3D selected at the top. That way, you're getting the 3D space. If you hold the middle mouse button, you can pan around. If you hold Shift, you can go in the different directions. And if you hold Control, you can zoom in and out. You can also use the mouse wheel to zoom. It's pretty straightforward. And to create our first 3D scene, I want to create a, 3D scene. Click on it, and then we are getting a node 3D. Inside of the viewport, we're getting this gizmo that you can move in different directions to change the position. We have the x-axis, we have the z-axis, and we have the y-axis. These little panels here let you move on two axes at the same time. If you click on the green one, you are pretty much excluding the y-axis, meaning you only move in the x and the z-axis. Might be a bit hard to see, but if I hold it like this and then use the green panel, you can see it quite well. We're only going in this axis. Besides that, you have these circles around it, and those let you rotate. Although for basic node, this doesn't really do anything. If you look at that transform, there you get all of the information, and now if I rotate it, you can at least see that we have a z-axis rotation. Since a node 3D is a single point in space, rotating it doesn't really do anything. In fact, all of this should be 0. You can also change the scale, but once again, I think this is straightforward. This is giving us a really basic 3D space. This I want to save right away. For that, I want to create a new folder. Let's call it Scenes. And this should be a test 3D scene. We are not going to use this one for the game. Although the naming scheme should be consistent, this is going to be test 3D. To this scene, I want to add another node. So press Ctrl A or on the plus icon, and then we can add a new node. And we want to add a 3D node. If you click on the drop-down menu, all of these red nodes are for the 3D space. If you look at the top, there you have Collision Object 3D. And there you have an Area 3D, and Physics Body 3Ds with Static Body 3D, Character Body 3D, and Rigid Body 3D. Those should look reasonably familiar. If you use the search function, you can also find a Sprite 3D and an Animated Sprite 3D. And finally, we have a Camera 3D as well, although that's going to come later. For now, I want to work with a Sprite 3D. Possibly the simplest 3D node to get started with, because this is basically a 2D node in 3D space. We only have a texture like in a Sprite 2D, which means we can get the Godot logo, drag it in there, and then you want to zoom in quite a bit. At some point, you can see the Godot logo. With the middle mouse button, you can rotate around, and well, you have the Godot logo. If you now look at transform, all of these properties are going to make a lot more sense. If I rotate it around the x-axis, or the y-axis, or the z-axis, you can see pretty well what's going on. Same with position, x goes left and right, y goes up and down, and z goes backwards and forwards. Scale, I don't think I have to explain. This one works just as before. This would be our very first actual 3D object, where we have a sprite in a 3D space. Although this in practice is kind of useless. You want to have actual 3D objects, which means Sprite 3D can go. We basically never use it. Instead, the 3D object that most people start with is a simple mesh instance 3D. Via that, we can auto-generate a mesh. By default, this node is not visible because on the right in the inspector, you have to create a mesh. And there are loads of options. Just choose whichever you like. I'm going to start with a box mesh. If you click on that, we're getting a box. On this box, you can change quite a few things. For that, you want to click on the mesh, and then you get a ton of options. You can change the size in all 3 dimensions, and then you get the different subdivisions along with a material. What does that mean? Well, for that, you want to click on Perspective, this menu button, and then you get a ton of options. Under Display, by default, we're getting normal, but you can also display a wireframe. And that way, like we have seen just a second ago with the spaceship, we can see the different edges of this model. This is how this model is defined, where effectively we have a point here, a point here, a point here, and these 3 points are connected, with the enclosing space being visible. And this is working in 3D space, so we can look at it from any angle. And the subdivisions tell you how many points you get. If I increase this number, we're getting more and more points on these different axes. Let me add quite a few more. And now, this model is defined by a lot more points, which currently doesn't really help us very much. Since this is a very simple shape, it doesn't need that many points. So this is not necessary for our purposes. But later on, for example, you might want to change these points using a shader, something that we are actually going to do. And by the way, these points are called vertices. Sometimes you really want to have a lot of them, but not at the moment. So once again, click on Perspective and then Display Normal. That way, you can see the cube again. Finally, we have Material. Via that, we can change the color of this cube. Right now, it's empty, but I want to add a standard material 3D to it. If you do that, the color already changes a bit. And if you click on Material again, then we're getting a lot of options. The easiest one is Albedo. This defines effectively the color. If I change this to really anything else, we are changing the color of this object. You can also give it a texture, although this by default is going to look a bit weird. If I drag the Godot logo in there, then you can see we are getting the Godot logo, and let me change the default color to white. But the model doesn't really know where to put the different parts of the image. And that should make sense. We have to give it a bit more information to place this image, a 2D image, in a 3D space. By default, it doesn't know that. Although at the moment, that really doesn't matter that much. So let's get rid of the Godot logo and just give this thing a color. I'm going to give it a bluish color. Let's add just a bit of green. There we go. Bluish color, good enough for our purposes. The other options you are usually going to use, besides albedo, are metallic and roughness. Via that, you determine how light is reflected. If I change this number, you can see that this thing has changed a bit. Although quite hard to see, same as specular, we are changing the color just a bit, but not very much. That is because this property only really makes sense once you have a light, which we can add very easily. What I want is a light 3D, and then we have 3 options: directional light, omnilight, and spotlight. I want to add a spotlight. Then we can see a light cone that I want to move this way, and via the red dots, you can change this thing. If you hold Shift, you can change it more gradually. Let's do something like this, and then move it a bit closer. Under Spot, you can change all of these attributes as well, and under Light, you can change the energy. See how this looks. And now, if you zoom in a bit, there you can see the light along with a bit of shading. I think if we go from an angle, this is going to be a bit more visible. Something like this. There we go. This is much better. Now we have a cube with some light shining at it. And if I go back to the cube under metallic, if I change this value, you can basically see how metallic this object is, or in other words, how much light it reflects. Same as specular, although I guess still a bit hard to see. For the proper effect, you want to have a proper scene with more reflections. But I think you get the idea. Metallic only really makes sense once you have light. Same with roughness. If I change this value, you can kind of see how much light is reflected, especially if you look at the preview. They can see it a bit better, I think. So if I have a low roughness, we're getting very sharp lights. If I have a high roughness, the light becomes much more faded out. At least to get started, you mostly want to work with albedo, metallic, and roughness for a decent look. But once you get further into it, all of these other options give you a ton more stuff to work with, which can be quite nice, but also a bit daunting. So go through it step by step. I guess in my case, I am not going to worry about it and simply delete the spotlight and only work with this mesh instance. Because next up, I want to change it using GD script. I'm going to add a script to the test 3D node. All the defaults here are fine, and click on create. Just as before, we can use the basic inbuilt functions. Like for example, ready. Let me add just a bit more space, and then get the mesh instance 3D and call one of the methods or work with one of the properties. For example, what we can do is rotate it along the, let's do the x-axis. Then we need an angle. Let's go with 20, something random. Once we have that, I want to run the current scene. And we should see a rotated cube, but we don't. We don't actually see anything. Why is that? Well, for 3D game development, you will need two important things to see anything, or at least anything useful. You will need a camera and lights. The first thing, a camera, is quite easy. All we need is to add a camera 3D. Once you're doing that, you have a camera, and you can see a preview on the right in the inspector. Let's say I want to move the camera a bit down the Z-axis, and then in the preview, we're getting something. So now, if I run the scene, I should be seeing this cube rotated because of GD script. But in practice, we are getting something, but not the right result. We do have the cube, and the cube is rotated around the x-axis. And I think rotating around the y-axis makes this a bit more straightforward. I guess you get the idea. The issue now, though, is that this doesn't look like anything in the preview. Let me run it again. This is what we are supposed to see in the preview. But this is what we actually get. Why is there such a difference? In the viewport at the moment, we are getting a preview for the sky and the lights from the editor. But in the game, this doesn't apply. This we have to add manually. And for that, you have those two symbols, where you can toggle the preview sunlight and you can toggle the environment. If you click on these three dots next to them, you get a bit more information. Via that, you can change how the world looks. For example, for the sun color, we can make it, I don't know, something random. If you're doing that, the cube is going to look different. Just pay attention to it when I change it again. If I change the sun color to really anything else, the cube is changing its color as well. This can be a bit stronger or a bit weaker, depending on what you need. Just imagine holding a red light next to any kind of object. That object, even if it isn't red, is going to look more red because of the red light. And this we're doing in 3D space as well. By default, all of these lights are very, very white because this is the most neutral option, which is totally fine to get started with. Besides that, we have sun energy, which is also usually 1 or at least very, very low. Then you can set the shadows, and that is really all you need for the sun. Besides that, we have the environment, and in there you can set the sky color and the ground color, which I think are fairly self-explanatory. We can change the color of the world. Most of the time this is blue because, well, the sky is blue. I am going to stick with the defaults. Once you have what you like, the important thing is that you want to add the sun to the scene and the environment to the scene. So click on both of them, and then you get two more nodes, a world environment and a directional light 3D. Once those two are actually added to the scene tree, you can run the current scene again, and you see a proper result, the thing that we can see in the preview for the camera. Via that, we could also tell that GDScript still works just fine, because we do get a rotation. On top of that, you can use things like func_process to rotate it at a constant rate. Although this should be a very low number, let's say 0.1 times delta. Although I guess we can rotate around another axis, let's say Z. If I now run the scene again, we are getting a very slow rotation around the Z axis. Just as before, if you want to change any of the properties of the node, you want to look at the inspector and then go through it step by step. Most of the time, you want to work inside of transform and change something in there, but you could also work inside of the mesh and the material to change, for example, the albedo color. If you hover over it, Godot is pretty much telling you what you need to know. All of this we should practice. For that, I want you to create a pink donut that moves to the right. On top of that, change the color via GDScript. Pause the video now and see how far you get. I want to hide the current mesh instance and then add another one. From recent, I can get mesh instant, double click on it, and I want to rename this to exercise donut. The name doesn't really matter, choose whatever you like. What actually matters inside of the inspector, for the mesh, you want to have a torus mesh. That's effectively a donut. This I want to rotate by 90 degrees, which you want to rotate it and hold Control. That way, you're rotating it in increments. Makes things much more easy to work with. Let's run the current scene to see how this looks. And that definitely is a donut. Perfect. This donut should get a material, so we can get the pink color. Material, standard material 3D. Click on it again. And then in albedo, we can give it a color. Something pinkish, like so. That looks all right. And with that, we have a pink donut. To move it, you want to use GDScript, get the donut, and then update the position. Position, and this is a vector 3. We have .x, .y, and .z. At the moment, we want to go down the x-axis, so this way. Meaning we want to get position.x and then increase it by some amount. Let's go 5 times delta and run the scene to see how this looks. That works reasonably well, possibly a bit fast. Let's go with 2 times delta. Then you can see things just a bit better. I suppose what we can also do is change the rotation. I want to rotate around the y-axis, and that way we can see some spinning behavior. Once again, just get the property or the method that you want to get the desired result. Although, one thing that can be a bit confusing is we have a mesh instance, then we have a mesh, and then we have a material. How can we change that? Well, for that, I want to get the exercise donut once again. In there, we can find a mesh. Inside of this mesh, we have a material, which, by the way, you can also print to see what you have available. Let me print it, run the current scene again, and then we're getting a standard material 3D, the thing that we have assigned earlier. If you hover over it, you can see we have a standard material 3D. Also, all of this should be inside of the ready function. We only want to do this once. Inside of this material, we have a standard material. As a consequence, inside of this standard material, we have the albedo property, albedo_color. If you hover over the value, you can see what Godot wants. The data type here is called color. So just type color, and in there, you can create a color from a whole list of options. You could add simple integers in here. For example, 1, 0, 0, and 1 gives you the full amount of red, no amount of green or blue, and the full amount of alpha. As a consequence, the donut should be red. And it is. Perfect. You can also simply get color, dot, and then you get some preview colors. Let's go with something a bit more interesting. I guess we can use deep sky blue. If I now run the entire thing again, we're getting a bluish color. And well, with that, we can change the material color of the donut. And by the way, inside of the mesh, you could also change the inner and the outer radius. That way, you would change the size of the donut. As always, just hover over the property that you want to change. Godot lets you change pretty much everything. And alright, with that, we have the basics of 3D in Godot. Now we can start working on the actual game. With the basics covered, we can work on the actual game. For now, I want to create a super basic floor and the actual player. The player can also move around from user input, so we are already getting something. For the player, we're going to use a character body 3D, which works just like the 2D one. To move it, you want to change the velocity and then call move and slide. The only real difference is that velocity now is a vector 3, meaning we need x, y, and z. But other than that, you don't really change that much. But before we get to that, we have to cover a few smaller things. So let's work on Godot right away. Here we have the scene from the last part, which we don't need anymore. You can just close it. You could also delete it. I guess I am going to leave it in, just so you guys have it as well. Now, before we get to the player, I want to create a general game scene, which is going to be a 3D scene that I want to rename to game and then save it inside of the scenes folder. Besides that, I want to create another scene where the root node has to be a character body 3D. This is going to be our player. Save this one as well, same folder, that's totally fine. And then Godot is giving us a warning that this node has no shape. To change that, we have to give it, like in 2D, a collision shape 3D, and assign this one a shape. The only difference now is that these are 3D shapes. If I had a capsule shape, we're getting, well, a capsule. Good start, but we don't really see anything. And for that, you want to look at graphics. If you open this one, you can see we have a ton of files to work with. To actually use them, you can simply grab one, let me get the first one, barrel.glb, and drag them into the scene. Then, if you find the right spot, you can see we have a barrel. That's really all you have to do. Although, if you look at the inspector, something interesting happened. We have a node 2D, and this node 2D is a scene, meaning you can open a scene, and then Godot is asking you if you want to create a new inherited scene or open anyway. I just want to open anyway for now. That way we can see what's actually happening. When Godot is importing this object, it creates a node 2D, another node 2D, and then we get an actual mesh with the object. This is what is actually visible. On the right side in the inspector, you could make a ton of changes to it, but these changes are going to be lost because this object is going to be imported. So when you make changes, it doesn't really overwrite that. It's simply going to be discarded, which we don't want to do. Let's close the scene. Instead, what you usually want to do if you want to keep things simple, you can either leave this thing as it is, or you could right click on it and then click on Make Local. That way, you can edit all of this, and in our case, we only care about this barrel mesh. If you now make changes to it, these are going to be permanent. That being said, I don't want a barrel for the main character. That would be slightly weird. Instead, I want to find craft speeder A, B, C, or D, or racer, really whichever one you prefer for the look of the main character. If you drag in craft speeder A, you get the default spaceship. Besides that, we also have B, C, and D, along with the racer, which you could all use. It doesn't really matter which one you choose. It's just for the look. All the other code is going to work the same. So choose which you like the most. I'm going to stick with craft speeder A2. This I want to make local and then attach the mesh to the parent node. After that, we can get rid of these two nodes. They're not necessary. And then, instead of craft speeder A, you want to go to transform and reset any kind of position. That way, we are perfectly in the center of the scene. And we have our player character. Although at the moment, the collision shape doesn't line up. For that, you want to rotate this thing by 90 degrees. If you hold Control and look at the bottom left, you want to rotate it 90 or negative 90 degrees. Both would be fine. Also, the craft speeder A should be moved down just a bit, so we are in the center of it. And also, the collision shape should be a bit smaller. You can either click on the small red dots or work inside of the inspector and reduce the radius to 0.2, maybe a bit larger. I'm going to stick with 0.2 and 2.2, or rather 0.25. It's going to feel a bit better. And that looks pretty decent, at least for a very basic shape. Although keep in mind, for these collisions, the wings are going to be excluded, which is what I want, but might not be what you have in mind. We're going to find better ways of dealing with this later on. For now, this is not too much of an issue. Once we have that, inside of the game, like as before, I want to instantiate a child scene. If you just look for player, we're getting the scene right away. Player, and there, inside of the game scene, we have the player. On top of that, for a very basic floor, I want to add a mesh instance, and this mesh instance is going to get a new plane mesh that I want to move down just a bit. That way, we're getting a floor. If you click on the mesh once again, you can set a size. I want to go with 100 by 100, and that way, we are getting a much larger area. Besides that, for the material, I want to have a standard material where we can set an albedo color. The actual color isn't so important at the moment. Let's go with a brownish color. It looks a bit spacey. I guess this one's alright. This game scene is what I actually want to run. So click on the Run project and then select the current scene. After you're doing that, you can see that you can't see anything. That is because we don't have a camera and we don't have lights. Adding all of that is going to be your exercise. Most importantly, add lights and the camera, so that the game is actually visible. Besides that, make the player move. The direction of the movement should come from data from the input map. Try to figure this one out and see how far you get. First of all, we will need a camera 3D, which you could either add to the main game scene or to the player. For this game, I actually want the camera 3D to be static, so I am going to add it to the game scene itself. Under Recent, we have a camera 3D that I want to move vaguely here for now and look down on the player just a bit. Something like this, just for testing purposes. Then let's run the game. And we can, at the very least, see something. To get the actual result from the preview, you want to add the sun to the scene, and you want to add the environment to the scene. That way, I can run all of this again, and we can see something that looks much better. Perfect. That covers the first part. Next up, this player should be moving from input. That means, inside of project settings, I want to create an input map, or rather a couple of actions inside of the input map. We have left, right. You could also add up and down, although those aren't actually used in the game, but we can use them for now. For left, I want to use A. For right, I want to use D. Up is going to be W, and down is going to be S. Choose whatever you want in here. Whatever works for you is fine. Just make sure that you have these 4 actions available. After that, give the player a script. The defaults are fine. Create. And then to move a physical object, you want to use physics process, like we have seen before. The most important thing in here to move anything is to update the velocity, which now is going to be a vector 3. So once again, we have X, Y, and Z. For now, I'm going to set velocity x to 1 and then call move and slide. If I now run the game, the ship is going to move to the right. So we are getting very basic movement. That looks really good. So now we have basic movement, but obviously we want to use the input map to make this much more interactive. For that, I want to get var direction, which needs to be a vector2 with a default of 0 and 0, which is what we are getting. And keep in mind now, our direction is a vector2, but the entire movement is a vector3. In other words, we have to convert a 2D input into a 3D movement. We are primarily going to do that by ignoring the y-axis, meaning the ship can only go left, right, forward, and backward. It cannot go up or down. I also want to have var speed, which is going to be an integer of 4. I don't want to set velocity.x to 1. Instead, I want to get the direction and then input.get vector. With left for the negative x action, right for the positive one, negative y is going to be up, and positive y is going to be down, like we have seen in the 2D space. Next up, we can actually update the velocity, and this is going to be direction times speed. Delta is going to be applied automatically, so we can just ignore it. Although now Godot is going to give us an error that the value of type vector2 cannot be assigned to a variable of type vector3. And that should make sense. This direction is a vector2, meaning we have x and y values. But the velocity of this object is 3-dimensional. It needs to have x, y, and z values. The easiest way to fix that is to target the values individually. So velocity.x is going to be direction.x times speed, then duplicate this, and velocity.z is going to be direction.y. Velocity.x is going to be direction.x times speed, should make sense. Direction.y is going to be us pressing up or down on the keyboard. And this we want to translate into forward and backwards movement in the game, which is on the z-axis. Remember, in the game, if you want to go up or down, you move along the y-axis, which we don't want to do yet. Converting 2D input into 3D movement sometimes can be a bit confusing, so I hope this makes sense. But anyway, let's run the game. I can move left and right, and if I press forward and backward, we are getting all the right inputs. So that is working pretty well. What we can also do is work just a tiny bit with physics. Inside of the game, I want to add a static body 3D, where we can add some kind of more interesting object. Let's go with rover, attach it as a child, and then we are getting a rover that's admittedly a bit small. That we can fix by making it local, getting the mesh, and attaching this straight to the static body 3D. And also transform should be 0. Most importantly after that, the scale should be, let's go with 4. That way, this thing is quite a bit larger. Although I do want to move it forward just a bit, so it's not on the player right away. Let's move it to the surface, like so. And after that, we can add the actual collision shape to it. And by the way, like in 2D, we have a collision polygon and a collision shape. Although collision polygon 3D is very rarely used. You'll see in a second why. For now, I want to add a collision shape 3D, which is going to be a very basic box shape. That at the moment is a bit too small, but this we can scale up to something like so and so. And like in 2D, if you hold Shift, you get more granular values, and if you hold Alt, then you are mirroring it along the axis. And that looks pretty alright. If I now run the game again, I can move forward, and once we get a collision, I cannot go any further. And that is working pretty well. And I hope this makes sense. All of this is pretty much identical compared to 2D. That being said, what if this rover was much, much larger? I want to set the scale to 20. That way this rover is significantly bigger, and now I want to have a bit more control over the collision shapes. So for example, these wheels can't really be described by a simple box anymore. Although let's not do the rotation, that way all of this gets a bit simpler. What we could be doing right now is to create a box shape for all of this, like so. And that would kind of work, but in 3D, very quickly, these shapes become too complex for that. So this isn't something you actually want to do. As a consequence, I'm going to get rid of the collision shape 3D. Instead, you could add a collision polygon 3D, like so. And then you can add the polygon using the points at the top. Although this is very, very difficult to use, and I wouldn't recommend it. Let's actually not do it. A much better system would be, with the mesh selected, click on the mesh button at the top, and then you can create a collision shape. Then Godot is giving you a couple of options. Do you want to have a collision shape placement as a sibling or as a static body child? I want to have sibling, and then you can select the actual shape. These give you different kinds of collision shapes, with trimesh being the simplest one. If you now click on create, Godot is going to create a shape. That's going to be a bit hard to see, but if you look closely, Godot has created a shape that exactly meshes the shape of the mesh that it was built on. Down there you can see the wheels, up here you can see the actual body, a bit up there you have the antenna, and that way you have a perfect shape for this object. If I run the scene, you can, well, this is slightly hard to see, but you can definitely see the collisions are working. And that's pretty much all you have to worry about in terms of physics. Like in 2D, you have a character body or a static body, then you have something visual, and you have the collision shape. And in 3D, most of the time, from the mesh, you want to create a collision shape. That's the easiest and most reliable way. Now, before we finish, I don't want to have this static body. That was just for demonstration purposes. Let's get rid of it. And the player shouldn't actually be able to move forward and backward. You'll see later how the system is going to work, but the player in the actual game can only move left and right, which in our game is very easily implemented. We simply want to get rid of velocity.z. If I now run the game again, we can still go left and right, but we can't go forwards or backwards anymore, which works pretty well. To keep things a bit more organized for all of that, direction doesn't need to be a vector 2, it can be a float. And then we don't need get vector, instead I want to have get axis with only left and right. That way we can use direction.speed right away for velocity.x, the end result should be the same. And it is. Perfect. Besides that, to make things just a bit more interesting, I want to rotate the model a bit when we are going left and right. Or in other words, I want to change rotation.z. If I change this value, for example, to a 2, then you can see the ship is going to be rotated quite a bit. We are working in radians, so a 2 is actually quite a bit. Now in my case, I want to use move toward. That way, we're moving towards a value. We are starting from a value and then going to a value over a certain duration, which is called delta. Our starting point is going to be the current z rotation of the model. So rotation.z. The target is going to be the direction, which is simply going to be a value from 0 to 1. Finally, we need a speed, which can just be delta. And for that, there shouldn't be an underscore before delta. If I now run this thing again, you can see that the ship is rotating along the z-axis, although in the wrong way. To fix that, all we need is negative direction. Then we can try the entire thing again. And now the ship is rotating in the right way, although a bit too strong. All we have to do for that is divide this by 2.0. Make sure you are using a float here, so you don't accidentally get an integer. Next attempt. And now the ship is rotating when we're going left and right in the right way. That is working really nicely. Finally, I want to make the ship hover along the y-axis. Or in other words, it should go very slowly up and down, something like this. Makes the entire thing look much more realistic. All we need for that, before move and slide, is update velocity.y. If I set this to 0.1, we will go up very, very slowly. And this works. Although we have to come down again as well. The best way to approach all of that is to use the sine function. The sine curve looks like this. We're going up and down with the highest value being a 1 and the lowest value being a -1. From this curve, we can sample. We could, for example, get this point, or this point, or this point, or this point, or this point, and so on. We just have to figure out where we are on the x-axis, which in our case can simply be the time since the start of the project. That way, if time goes forward, we start somewhere here. We are going all the way to 1. And then as time passes forward, we are going to -1. Then we go back up to 1 and so on. Via that, simply by using the time, we can alternate between 1 and -1. To get the time, all you need is time.get ticks in milliseconds. If I try all of that, we should be seeing something, although it does look a bit jittery. Good start though. To change the strength of this effect, you can either multiply the time that you pass in as an argument, or you can change the entire thing by multiplying it with some kind of value. For example, if you divide the entire thing by 500.0, make sure you always use a float in here, then you are going to move a lot slower. And if you divide the entire thing by, let's say, 4.0, then we are not going to move as much anymore. And that looks pretty alright. Although at the moment, if you look at it, it looks very, very repetitive. If you want to make this look a bit more organic, you can simply add different sine curves together. For example, I can copy all of this, add it to the first one, and then simply make these values a little bit different. Let's say divided by 600 and divided by 10. That way, we are combining different sine curves, which makes the whole thing look much less predictable. As a result, we are getting something that looks a bit more organic. Quite hard to see, but in practice, this is going to make a difference. But anyway, I think this part has gotten quite long, so let's finish it here. To get an actual game, we are going to need lasers and meteors. That's going to be the next major step. And well, at this point, we can basically do all of this already. So let's work right away in Godot. Here we are once again. I want to create a new scene where the root node is going to be an area 3D that I can rename to laser. Save all of that inside of the scenes folder, save. Then we will need the actual laser graphic. This you can find inside of the files under red.glb. If you drag this in there, you can see the laser. And just as before, click on Make Local. That way, you're getting the mesh itself, which feels a bit more organized. Make sure that under Transform, all of this is set to 0. Although, that being said, if the rotation is set to 0, this thing is pointing upwards, which is really not ideal. In our case, the ship is facing down the -z axis, and the laser should look in the same direction, meaning we want to rotate it 90 degrees in that way, so it's facing down this way, away from the blue arrow. If you are looking in a different direction, go with that. Finally, for the laser, we are going to need a collision shape. This can be done in a couple of ways. You can either click on Mesh, create a new collision mesh, sibling tri-mesh, and that way we are getting a very nice mesh that I think would be totally serviceable. Alternatively, you could get rid of it and then create a very basic collision shape 3D with, I guess, a sphere shape that you can make just a bit larger and then move it to the front of the projectile, roughly here, and then you would get a similar result. There are different ways of doing collision shapes. I think I am going to go with the first version, mesh, create new collision shape, and then sibling tri-mesh. That one is definitely the most precise one. But in many cases, you don't need that much precision, especially for a simple game like this. Next up, inside of the game, to keep things a bit organized, I want to add a node 3D for lasers. All of the lasers that we are going to create will be children of this node. And lasers are going to be created when the player presses a button, which means inside of project settings, the input map, we will need a laser button. Could also be called shoot, it doesn't really matter. In my case, I want to look for the space button. There we go, space physical, that's all we need. After that, we have to work inside of the player character. Inside of physics process, we can simply check if input is action just pressed or laser. Then we want to do something. Really important at this point, we want to have the lasers inside of the game scene. But currently, we're checking for input inside of the player scene, meaning we have to connect these two scenes. I think the easiest way to do all of that is via a signal. Shoot underscore laser with one argument, the position, which always needs to be a vector 3. If the player presses the laser button, I want to shoot laser and emit with the global position of the spaceship. That way we make sure that inside of the game, we always get the right position for this spaceship. Next up, we can work inside of the game scene. First of all, we will have to attach a script to it. As always, the defaults here are totally fine. And most importantly, I will need a var laser underscore scene that always needs to be a packed scene by preloading laser.tscn. Besides that, we want to get the player, go to node and shoot laser and connect it to the game scene. On player shoot laser, sounds fine, connect. Now we can check when the player shoots a laser inside of the game scene. Just for testing purposes, let's print the position that we are getting and run the entire thing. I can press space and we're getting some kind of position. Now we don't just want to print a position. Instead, I want to create one instance of the laser scene. I'm just going to call it laser, and this we create via laser scene.instantiate. As an added bonus, I want to instantiate it as an area 3D. That way, we're getting the autocorrect stuff, which can be handy. Just make sure that your laser is an area 3D as well. If you don't have that, you're going to get some weird results. Once we have a laser scene, we have to give it a position and add it to the scene tree. To add it to the scene tree, I want to get the lasers node 3D and add a child, which is going to be the laser that we just created. This should already do something. Let me run the entire thing, and now if I press space, we are getting the laser. Although if I press it multiple times, nothing is going to happen on the surface, but if you look under remote, game, and lasers, we're getting a whole bunch of lasers. They just happen to be in the same position, so you can only really see one. Things are working though. The final thing that we have to do is update the position of the laser by changing the position to the pos that we're getting from the parameter. Once we have that, I can press space, we're getting a laser, we're getting another laser, and that looks pretty good. With that, we can create lasers. That's working pretty well. Next up, the laser has to move. For that, we want to give the laser a script. As always, the defaults here are totally fine. And then for the laser, I want to have func_physics process. All we need for this one is to move it down one of the axes. We are still pointing the negative z direction, which means we want to update position.z and then subtract values. For now, let's go with 15 times delta, run the scene, and now the laser should be moving in the right direction, and it is. That looks pretty good. To keep things more organized, we do want to have var speed, which is going to be 15, and this should always be an integer. That way, we're getting this speed here, and things are a bit more understandable. All of this is giving us a reasonable laser, but by default, this just doesn't look very good because the lasers are on top of the player and they're just way too big. To fix that, I want to scale them up when they are being created, which means I want to have func_ready and then set a default scale of vector 3.0. That way the lasers are not going to be visible by default, but we can scale them up using a tween in just a second. Although, first of all, if I run the game and create a laser, Godot is going to be really, really unhappy. That is because we're getting invert condition that is equal to 0 is true. That happens when you try to scale a physics object to a complete 0. If you set this instead to 0.1, 0.1, and 0.1, this error is not going to happen. Let's run it again, and now we're getting a very, very, very small laser. Good enough for our purposes. I want to create a tween via create tween, and then tween.tween property with self. I want to target this scale. The target value is going to be vector 3.1, and the duration can be 0.4 seconds. The default scaling of the laser is going to be 0.1, but afterwards, via tween, we are scaling it up to a size of 1 over a duration of 0.4 seconds. That is going to make the entire thing feel much, much nicer. What you could also do inside of the game, when you're setting the position, you can add just a bit of an offset by simply adding a vector 3, where we have to set x, y, and z. Once again, you want to make sure you are on the right axis. We want to offset this laser by some negative amount on the z-axis. X is going to be 0, y is going to be 0, and z is going to be, for something strong, -10. That's going to be way too much. But you can see we are at least going in the right direction. If I change this to a -1, we have a much more reasonable offset. I guess this could be a -2, possibly a bit too much now. Yeah, definitely too much. But play around, this could be -1.2. That way, looks a bit better. We are actually nearly done with the lasers. The one final thing I want to do for them is that they should disappear at some point. Because at the moment, we can create lasers indefinitely, and they would never disappear again. If the game is running too long, this means we have more and more objects. Not great. A very simple way of fixing that would be to check if position.z is greater or equal to, let's say for now, so we can see something, 15. If that is the case, we want to get rid of the laser. If I now, inside of the game, shoot a laser, the laser should disappear at some point. And it does not, because the z values are getting smaller and smaller. So instead of being greater than, we want to check if they're smaller than -15. Next attempt. And now the laser disappears roughly around this point. The negative numbers here do get a bit confusing. If you want to have this more organized in your game, you might want to rotate all of this around the Z or the X axis. I think for our purposes, this is still good enough. Although this number needs to be much larger than negative 15, or well, much smaller. So let's go with negative 200. So it's going to take a while for the laser to disappear, and the player is not going to see it. Perfect. That covers the lasers. Next up, we have to create the meteors. This part is going to be your exercise. I want you to create the meteors and spawn them via a timer. Every time the timer times out, create a new meteor and then move that meteor towards the player. You can add some randomness to it, like a bit of a random direction or rotation, to see what looks good. You can find the meteor graphic inside of the resource folder, and the root node should be an area 3D, like the laser. Pause the video now and see how far you get. First of all, I want to create a new scene where the root node is an area 3D. Let's rename this right away to Meteor. As a child to it, you could look for Meteor inside of the resource folder. It is there. We have Meteor and Meteor detailed along with Meteor half, although I only want to use the Meteor itself. You could add this right away, or you could attach a child scene. If you look for Meteor, you can find meteor.glb, the imported graphic. Both would work. There we have a meteor, and just as before, I want to make this thing local, attach it to the root node, get rid of the node 3Ds, and then reset the transforms. That way, we are getting a meteor, although I want this to be in the perfect center, which I have done by changing the transform y to negative 0.3. After that, we will need a collision shape. And I guess we can do the usual thing, go to mesh, create collision shape, sibling, try mesh. And that looks really, really solid. Although keep in mind here, the collision is basically a sphere. You could get away with much fewer points, which would be good for performance. Not an issue for our game, because it's so simple, performance will not matter. But for a more complex game, you would want to keep as few vertices as possible. The fewer you have, the easier your game will be to run. Once we have all of that, save the scene as meteor.tscn, and then we can work with it. To actually use it, for now, I want to attach one instance of the meteor and make sure you have meteor.tscn, not meteor.glb. That is the wrong one. I want to add meteor.tscn, and then we want to move this thing just a bit forward so we can see it inside of the game. Now we can run the whole thing, and we are getting a meteor. That looks perfect. Next up, to animate this meteor, we want to give it a script. The defaults here are fine, just as usual. And for the most basic effect, I want to create func physics process where we are updating position.z. We want to move towards the player. So I think this should be plus equal some kind of speed. Let's go with 2 for now. This we have to multiply with delta. After that, in the game, we're getting the meteor moving towards the player. That is working pretty well. For better organization, I want to create var speed with a default value of 2, and I want to have var direction underscore x. That way, we are going slightly left or right when the meteor is moving. And this should be some kind of float that we will set in just a second. Whenever this meteor scene is ready, I want to update direction.x and set a random value, which we get via rand_f range, where I want to go from negative 0.1 to positive 0.1. A very small amount here is totally fine. After that, this value should actually be used. In my case, position.x plus equal direction.x multiplied with delta. That way, we are very, very slowly going left or right on the x-axis. Let's try. And we can't really see very much. These values might be a bit too small. Let's go with -1 to 1. And that is looking much more random. One more attempt. That works. While you're here, you can also do things like rotate X with some kind of speed. Let's go with 1.5 times delta. That way, this thing is going to rotate. Makes it feel much more organic. You can do the same thing for rotate.z. And that way, we're getting a lot more rotation. These are fairly small things. If you want to customize them, just play around a bit more. But for now, they're not too important. What actually matters is that inside of a game, we are spawning meteors when a timer times out. For that, I want to add a basic node, rename it to timers, and then attach a timer node. That should be called meteor timer. The duration for this one is going to be 0.25. It should auto start and it should not be one shot. We want this thing to run over and over again. I want to connect the timeout signal to the game scene. Connect, that is totally fine. And then do pretty much the same thing that we have seen for the laser. Var meteor underscore scene. We want to create a packed scene and then preload the meteor.tscn scene. Once again, make sure that you're getting scenes meteor.tscn. You do not want to get the GLB file. After that, once the timer times out, I want to create var meteor via meteor scene.instantiate. After that, we have to find some kind of parent container for all of the meteors. And I suppose what we can do is add another node 3D with the meteors. You could actually have the same parent container for the lasers and for the meteors. Would be fine. I guess we can actually do that. Let's get rid of the meteors and rename lasers to projectiles. Make sure then you are adding the lasers to the projectiles, like so. This shouldn't be lasers anymore. And then we can use projectiles once again and add a child that is going to be a meteor this time. Keeps things just a bit more organized. Then we can get rid of the meteor that we have just added, run the scene again, and now we're getting a whole bunch of meteors whenever the timer times out. Good start, although we might have to update the position of the meteors when they are being spawned. Just a bit. When a meteor is ready, I want to set position.z to some large negative value. Let's try -30 for now. That way, it should already look a lot better inside of the game. Now the meteors start from much further away. We're going to fine-tune all of this later on, so don't worry too much about it for now. I guess so we can see something. Let's set this to -10. That way we can actually tell what's going on right away, and that looks okay. Besides the position, I also want to change the scale to some slightly more random value. Before we're getting to the scale, I want to create var random scale, which we can get via rand f range with a value that goes from 1 to 3. Then the actual scale is going to be a vector of 3 with the random scale for x, y, and z. So random scale, and random scale. That is going to make the meteors look much more different. And now we are getting different scales. That is going to look quite a bit nicer. I suppose the final thing that we can change is the speed. This one should also be a bit more random. Speed is going to be rand f range, let's say between 3 and 5. And for that to work, this speed doesn't need a default value of 2 for the integer. Instead, I just want to have a float with a default value of 0. We are overwriting all of this anyway in the ready function, so the default value doesn't really matter. Final attempt. And now the meteors should move at different speeds, and they do. That looks fairly alright. Now you could randomize the rotation a bit, but I'm not too concerned. I think we have all of the important parts, so now we have the meteors and we have the lasers. Lots of progress. Next up, we are going to work on collisions between the player and the meteors and the lasers and the meteors. While doing that, we are also going to work on a very basic flash shader effect. Let's get started right away. Here we are in Godot, and for now, I want to check the collision between the lasers and the meteors. Both of these are area 3Ds, so one of them can be used via the signals check for area entered. That way we can connect the two fairly easily. Although, first of all, we should go to Project Settings, 3D Physics, and then set some physics layers. I want to have terrain, layer, lasers, and meteors. That way, all of this is much more organized. The player is going to be on collision layer 2, I think. Yep. And can see the terrain and the meteors. Nothing else needs to be visible. The lasers are going to be on the laser layer, obviously, and they can only see the meteors. The other way around, for the meteors, they are on the meteor layer, and they can only see the lasers. Like so. That way we don't get any accidental collisions, which is quite nice. Next up, I am going to keep the logic for collisions organized inside of the meteors. Meaning in there, I want to have a signal for area entered. Click on connect, and then we can write some code. For now, when an area entered, I want to simply print the area to check if this is working in the first place. Let's run the game, and if I shoot a laser at a meteor, we don't get anything. So something went wrong. Although we are getting a debugger warning, solve static, collisions between two concave shapes are not supported. In other words, the current shape of the meteor and the laser don't work together. Godot simply cannot check a collision here. Which arguably is a bit annoying, but the way to fix that is for the collision shape. We have a concave polygon shape. Same for the meteor, where we also have a concave polygon shape. And for some reason, these two cannot be checked for collisions. The way around that is for the meteors, in our case, to get rid of the shape and then create a new shape for a sphere, which we can just move up a bit and then scale it down a tiny bit so it fits just right. Like so. If we do the same thing now, I can shoot a laser and we get the expected result. That looks pretty good. For these kind of issues, you really want to read the debugger, that way you know what's going wrong. Otherwise, this is going to be super confusing. Then I realized I forgot one thing for the meteors. The meteors should see the lasers and the player, obviously. Now, fundamentally, what we want to do, once there's a collision, we want to Q3 the meteor, and we want to Q3 the laser, which is going to be the area 3D. If I try this now, I can shoot at the meteors and stuff disappears. Although it's not really satisfying, I guess it kind of works. To make this a bit more interesting, we can add a timer. For that, I want to first of all stop the movement once this function has run, which we can do by adding another variable, can_move, which is going to be a Boolean with a default value of true. After that, inside of physics process, we want to all of this only if the meteor can move. And once an area has entered, can move should be false. And for now, let's focus on the meteor. This one should disappear, but it should only disappear after a short amount of time. For that, we can either create a timer, or we can use a wait get_tree, and then create a timer in GDScript. One argument in here is going to be the duration, which I want to set to 0.4. Then we have to wait for the signal that is called timeout. That way, we are waiting 0.4 seconds to run this line. After that, I can wait for a meteor, shoot a laser, the meteor stop moving, and after about half a second, they disappear. That looks pretty alright. Although the laser should also stop moving. To keep that one organized, let's create a function inside of the laser. Which means area, which is going to be the laser, let's call it destroy. That means inside of the laser, we will need func destroy, no need for parameters, and fundamentally, we want to do the same thing that we have seen inside of the meteor. Basically, all of this. Let's paste it in there. And we have to create can move. Var can underscore move, a Boolean, default is true. And then the movement should only happen if can move is the case. Like so. If I now run all of this, I can shoot a laser. We get an error that we try to call the function destroy in base previously freed on a null instance. That happened because of a silly mistake. Just think about these 4 lines of code, and I think you might be able to see it already. Let's go through it step by step. Number 1, we set can move to false, so none of this happens anymore. That part is totally fine. Then we wait about half a second, destroy the node, and then call a function on another node. There are 2 issues here that are pretty bad actually. Number 1, the most obvious one, is that we are destroying this node on this line, meaning nothing else afterwards is really going to be run because the node has been destroyed. And that, by the way, is the error message here. This one should definitely come before Q3. That way, we are calling a function on an existing node, which is what we have to do. But on top of that, this line should come before await. We want to stop the laser right away. We don't want to wait half a second. That would be kind of weird. But once we have both of those, I can run the code again, shoot at a meteor, and now we can destroy meteors just fine. And if there's a bit more space between them, this would also look better. We'll work on that in just a bit. For now, I'm reasonably happy. Although, to make all of this look much nicer, I want to add a shader to make the meteor and the laser flash in white once there's a collision. For that, we have to work on shaders, specifically inside of the mesh. That's the only visible part of the scene. And when it comes to 3D stuff, there are multiple ways to add a shader actually. If you click on the mesh, there you have surface, and there you have a material. To this material, you could add a new shader material. That would be one way. Besides that, if you look under surface material override, you can add a surface material override. The name explains itself. Finally, instead of geometry, you have a material override and a material overlay. I think the difference between them makes sense. The override overrides the current surface. The overlay doesn't get rid of it, but it lays something else on top of it, which is actually what we want to do. So in material overlay, I want to create a new shader material. Then we get the usual stuff. We want to create a new shader. We want to create a base shader. Now the mode has to be spatial, and then we need a name. The name should be Flash Shader, because this shader should be applied to the meteor and to the laser. Also, I guess what we can do is create another folder with shaders. Not necessarily needed, but I think it's good practice. After we have that, create, and then the meteor becomes pure white, which is the expected behavior. So all good so far. After that, we are getting the usual stuff. We have a vertex shader and a fragment shader. For now, we don't need the vertex shader whatsoever. We can get rid of it entirely. We also don't need the light shader. We only want to work inside of fragment. Unfortunately, 2D shaders and 3D shaders are quite different. For example, in a 2D shader, you can simply set the color, which doesn't work in 3D. For that, for the color, you want to target albedo, which wants to have a vector 3 with some kind of value. If you set this to 1, 0, and 0, then you are going to get a red color. We have the full amount of red, no amount of green, and no amount of blue. If you want to look more into this kind of shader thing, The best way to get started, I think, is to look at the material, and then you basically get the names that you want to target from all of these parameters, like albedo, metallic, roughness, and so on. Speaking of which, the next part that we want to target is going to be alpha, which is simply called alpha. This value is a very simple float. If you set this to 0.0, don't forget the semicolon, then we get the base color. But this only applies because we are adding a material overlay. If you had material override, the entire thing would be invisible because we are hiding the actual texture. But now we are only hiding the overlay. So I hope that part makes sense. Anyway, for this shader, all I really want to do is to create a uniform float progress with a hint range of 0 to 1 with a default of 0.0. This value is then going to give us the alpha value, so progress in here, and the actual color that I want is going to be 1.0 for R, G, and B, meaning we're getting a pure white. Once we have that, inside of the shader, we have shader parameters, progress, and via that, we can toggle a white flashy kind of thing, which we can then use when there's a collision, so on area entered. Before we are awaiting the timer, I want to get the meteor. On the meteor, I want to get the material overlay. Really important, don't get overwrite. And in there, we can set shader parameter of progress to 1.0. That should be it. If I now shoot a laser, we are getting a white flash. Although now we are making all of the meteors white. Not exactly ideal. To fix that, all we have to do is under resources, local to scene, and then this should be fixed. Next attempt. Now some meteors become white, but the others keep the same color. Perfect. With that, we have the basic logic for the meteors. The same thing I want to do for the lasers. They should also flash up from a shader. That part is going to be your exercise. Apply the flash shader to the laser and trigger it when there's a collision, like you have seen for the meteor. Pause the video now and see how far you get. Inside of the laser, first of all, we have to apply the shader to this mesh, which is called red. I suppose we could rename it to something a bit more descriptive. Let's call it mesh. Fairly minor part, the actually important bit is under geometry, we have material override. In there, we want to create a new shader material. And for the shader, we want to quick load the flash shader. That way, under shader parameters, we can toggle progress and change the color super efficiently. That looks good. That's all we need in here. Next up, inside of the laser, in the destroy method, before await, we want to do the same thing we have done for the meteor, which means we can copy the line and then call it like so, except meteor should be mesh. That's pretty much it. Let's see if this works. And that looks pretty good. The game is slowly coming together. The meteors need to spread out quite a bit, but that we're going to work on in just a bit. Next up, I also want to check if there's a collision between the ship and the meteors. If that is the case, we're going to shut down the game. That way we don't have to worry about UIs or resetting the game. That keeps things a lot more simple. Inside of the meteor, we want to check the signals and then look for body entered. This we can connect to the script at the bottom. And well, basically there's only one body that could be entering, which should be the player. Let's try. Print body. And now, once there's a collision between the player and the meteors, we should get something printed out. And we do. That is working beautifully. We should be renaming this parameter to player, and we are expecting a character body 3D. Makes the code just a bit clearer. That being said, we don't actually need any of this. all we want to do inside of this function is end the game, which we can do via get 3 and wait. Next attempt. Let's wait just a second. And there we go. The game ended. With that, we have the very, very basic setup. There are a few major parts that we have to work on. Number 1, the camera needs to look at a different angle. Number 2, the meteors need to spread out quite a bit. And number 3, we can add a couple of things to the ground, so we have some obstacles. Makes everything look just a bit better. These are also going to be collidable, so basically we have a few more projectiles. Back inside of the game. Most importantly for now, the camera needs to look much further down, so we can't see the horizon. For that, we want to look at transform, and first of all, move the camera up quite a bit. I went with 6.5. That means we can see the horizon quite a bit more, so we need to rotate this thing a lot more. For the X rotation, I went with -45. And that way, this is already looking quite a bit better. To make this look just a bit more interesting, we can rotate the camera around the y-axis to something like this. Let's see how that actually feels inside of the game. And I think that is working reasonably well. You can also change the Z rotation a tiny bit. That's the blue line. So you get just a bit of a very slight rotation there. This should be a very low number, something like 0.5. Otherwise, it's going to feel very, very strange. Let's try. And didn't do very much, which I guess is fine. For the most part, you want to work with the X and the Y rotation. Also, while looking at this, we do have these corners here, but we don't have a background. That is quite easily fixable. We just have to move this thing a bit forward, then look at the camera. And nearly there, move it over a bit here. And, well, I guess we can make it a bit larger. 130 in both dimensions. That should cover it. Not quite. A bit over here. There we go. Now we have covered the entire floor. And that is working pretty well. Obviously now the entire floor looks incredibly boring, but that we can fix as well. First of all though, the meteors need a better start position. Right now, they start in this one point, which looks really, really silly. At the moment, we are spawning the meteors, and they're always spawning in the same position. That shouldn't be the case, and for that, we can work inside of the meteor, specifically in the ready function. We are setting Z position of -10, and that's the start point. This number should be quite a bit lower. Let's go with -40. That way they should spawn outside of the window. That looks about right. And on top of that, we want to give them a random X position. Position.x is going to be rand f range between -10 and 10. Let's see how that looks. And now we have a good bit more spread. This could even be more spread out. Let's say -20 to 15. And that is looking reasonably okay. Obviously, you can fine-tune all of this quite a bit, but I am happy with that. Once the game is running for a bit, the player is not going to know. So this is pretty alright. And now, if you hit individual meteors, you get a much better effect. Before continuing, I forgot one thing. At the moment, we keep on creating new meteors, and the meteors never disappear. That shouldn't be the case. We could fix that like we have fixed the lasers. Or in other words, we can check if we are crossing some kind of position and then call Q3. Alternatively, for the meteors, once they leave the screen, we can also destroy them. For that, we can add a visible on-screen notifier 3D. create. This thing is going to have a shape. Doesn't need to be too precise, but we do want to cover the meteor reasonably well, something like this. And on this node, we can get screen entered and screen exited. Once the meteor leaves the screen, we can, let's for now simply print that this is working. I want to print meteor exits. Getting a result from this one is going to take a second. I am probably going to speed up the video just a bit. Righty. This meteor should trigger the first signal, and there we go. Now we start to get lots of meteor exits. This is working. Which means all we have to do in here is call Q3, and that way the meteor is going to disappear as soon as it leaves the screen. Different ways of doing that, both would be fine. We could have done the same to the lasers, would be a bit cleaner, I guess, but for this kind of game, it just really doesn't matter. And alright, that is already cleaning up the game a lot. Next up, the game at the moment looks incredibly empty. That we have to work on. And for that, I want to create obstacles. For this scene, the root node is going to be an area 3D. Let's rename it to obstacle right away. Save the entire thing. And then we have to give it a collision shape 3D, so Godot stops complaining. For now, I want to work with a box shape. We're going to refine this in just a second. First of all, though, the actually important bit is going to be that we want to pick a whole bunch of graphics and show one of them at random. So, for example, we want to have a couple of rocks, a rover, a satellite dish, and a few more objects inside of this scene. And then, once the scene is ready, only show one of them. For that, I want to add a node 3D with the actual meshes, the shapes that I went with. And the easiest way to get them is by using the filter. I want to have a rock. Let's simply drag it in there and make sure it's reasonably centered. This one looks all right, although it should be part of meshes, like so. Besides that, we have rock crystals, drag this one in there, and then we're getting basically the same skin, except with crystals, which should be in the origin as well, vaguely here. This doesn't have to be too precise, although make sure that you only move it on the X and the Z axis. It shouldn't go up or down. Besides that, we have the rover. This one should be part of the mesh as well, like so. Move it to the origin point, vaguely. Next up, I want to have a satellite dish, and there are quite a few. Let's go with large. That looks pretty nice. Once again, needs to go into the origin point. Finally, to add one more mesh, you can, instead of dragging stuff in, simply instantiate a child scene. The one that I'm looking for is called Turret Double. Drag this one into the center as well. And there we go. Now we have a whole bunch of objects that we can select quite easily from the meshes. We just have to get the children. Although first of all, the collision shape should be at least vaguely fitting here. This part isn't going to be too important, so I'm not going to be too precise here. But what you can do is first of all get the front view and then move the collision shape to roughly fit all of these shapes. Make sure that this shape is fairly small. The bottom part doesn't actually matter, and for the top part, we can put it vaguely here. Besides that, we can look from the right and make sure that this thing isn't too long. Put it to something like so. That way, we have a reasonable shape that mostly covers the area. Obviously, for a real game, you want to have a shape for every single one of these meshes that works a lot better. But that would take too long for this tutorial. Instead, I want to spawn a whole bunch of these obstacles on the map to make the entire thing look much more populated. This should happen on the tick of a timer, which means I want to add another timer. Let's call this one the obstacle timer. It's going to have a wait time of 2 seconds. and it should auto start. I suppose we can connect the timeout signal right away to game. Most importantly, we need to have this scene ready inside of the game scene, which means, like we have seen for the meteor and for the laser, I want to have an obstacle scene, which we get via scenes and obstacle. After that, once the timer times out, I want to create a random amount of these obstacles that we can do via a for loop for I in rand I range. I want to create between 3 and 6 objects. This we can do in the usual way. We have obstacle is going to be obstacle scene dot instantiate. Next up, we have to add that to a node, meaning we have to find a parent. And once again, we can add all of this to projectiles, because effectively those are projectiles. Maybe not the greatest name, but it's good enough. So to that, we want to add a child, which will be the obstacle. If we now run the whole thing, let's see what happens. We are getting obstacles right on top of the player. That is at least something. And also make sure that for the obstacle timers, auto start and wait time are enabled, so you get this kind of thing constantly. Now at the moment, this isn't too visible because we always spawn things in the same place. Not great. For that, we want to go back to obstacle and then add a script to it so we can randomize things a bit. As always, the defaults here are totally fine. Create. And then once the scene is ready, func underscore ready, I want to do a couple of things. Let me add paths for now. Number one, I want to randomize the scale between 1 and 3, meaning we can have the default scale or scale up by a factor of 3 and find some kind of float between those values. Then I want to have a random rotation around the y-axis. That one should be straightforward. And finally, as a separate function, I want to set the xz position with x and z as an argument. And this we are going to call from the game class after we created one of the obstacles. That's going to become important later on. But for now, there are 3 things that we need to do. This is going to be your exercise. Randomize the scale and the rotation of the obstacle once the scene is ready, and create a function for the x and z position. Pause the video now and see how far you get. Let's start with the really easy part, the function to set the xz position. And I should be a bit more organized here. For both data types, we are expecting a float, and nothing else should be accepted. All we have to do in here is position.x is going to be x, and position.z is going to be z. That way, from inside of the game class, we can call obstacle.setxz position with some kind of value. Let's say for now 0 and -5. That way, all of the obstacles should be spawned a bit further in front of the player. And if you write the name of the function properly, this is also going to work. Let's try again. And now we get the obstacle a bit further in front of the player. That worked. Besides that, for the ready function, I want to update the scale, and this has to be a vector 3, where we want to have values for x, y, and z, and all 3 of those should be the same. I think the easiest way to approach that is to create another variable. Let's call it scale random, which we create with rand f range, where we go from 1 to 3. This value we then plug into x, y, and z, like so. That way we keep the scaling proportional. That should actually be all we need. Let's try. So now we should be getting obstacles that are different in scale, and that definitely worked. The first one was really large, so it's a bit hard to see, but this worked. That covers the first part. Next up, a random rotation around the y-axis. All we need for that is rotate y and then a random range. Once again, randf range, and the values here go from 0 to tau. Tau is simply 2 times pi, and randf range is working in radians, meaning the full range goes from 0 to 2 times pi. In other words, this covers the full rotation. And finally, one thing I forgot to mention is that at the moment, we have 5 children, and we only want to make one visible. This could be an extra challenge. If you want to figure that one out, pause the video now and try to only make one of those visible once the scene is ready. I want to get all of the meshes and then get the children. This is going to return an array with all of the children, from which we can pick one at random. And this we want to show. For that to work though, we have to make sure that by default, all of them are invisible, like so. With that, inside of the game, we should only be getting one object. And this kind of worked. The reason why it looks weird is that inside of the game, we are spawning between 3 and 6 objects at the same time. Meaning, even if we only have one of those visible, we still see multiple. We're going to fix that in just a second. But for now, inside of the obstacle class, we have nearly all that we need. The one additional thing that I want to do inside of the game, the floor should be a bit further down. At the moment, in my case, the Y position of the floor is 0.9, or negative 0.9 to be specific. The floor is a bit further down compared to the player. This, I think, should be lower. Let's go with negative 2. That way, there's a bit more space between the player and the floor. This, however, means at the moment for the obstacles that they are floating. This we should really fix. And for that, we will need position.y, and this should be negative 2, or whatever value you set for the floor of the game. And by the way, this mesh instance should just be the floor. Makes a bit more sense. Let's try all of this now. And now the obstacles shouldn't be floating anymore, and they're not. That looks alright. With that, finally, we can randomize the position of the obstacles via the set xz position. In my case for that, I have created another variable called game_size. And this tracks the scale of the game, which is going to be a dictionary. In there we have the left side, we are going to have the right side, then we have front, and finally we have back. The left side in my case is negative 15, the right side is positive 15, the front is negative 2, and finally the back is negative 40. Effectively, inside of the game, this area is all of this bit here. And we want to spawn an obstacle inside of this area. Although we do have to be careful. These obstacles should be, like the meteors, at the top end of the window. In other words, first of all, I want to cover the x part of the function. I want to have randf range, where we go from the game size dot left, and then game size and right. That way we are going left and right. This we can duplicate for the z values. And let's say, just to get started, I want to go from the front to the back. That way we are spawning an obstacle in the entire available range, which isn't actually what we want to do. But let's try. Now we're getting some obstacles here, we're getting some there. That looks pretty alright. The problem is, these shouldn't just pop in and start existing randomly inside of the game. They should start at the top of the game and then move down, just like the meteors. I want to have game size and back for the first value, for the second value, game size.back plus 5. That way, they all spawn in the back, which at the moment isn't ideal because they should also be moving. Because remember, the spaceship itself doesn't actually move. we are simulating movement by having the meteors and the obstacles moving in this direction, which means the obstacles will also need a func_physics process in which we are updating the position, specifically position.z. And let's keep it simple, plus equal 2 times delta. That way they should be moving. And let's try all of that. Now we should be having obstacles coming towards the player, and that looks okay. Once you have a bit more stuff here, this is also going to look a bit more realistic, but I think this is working decently well. To make all of this feel even better, what we can do, once the game scene is ready, and let's do this all the way at the top, func_ready, I want to create loads of obstacles. We can simply copy this for a loop, like so, and then spawn between, let's say, 50 and 60 obstacles. And those should cover the entire available range, meaning we want to go from the front to the back. That way, if I run the whole thing again, we are getting, right at the start, a whole bunch of stuff, and that way the game looks a bit less empty. And that is working pretty well. Cool. Not perfect, but I think for a basic game, this is good enough. The last minor thing that I want to do is, if the player happens to collide with an obstacle, the game should still end. Which means, first of all, for the obstacles, we have terrain, and for the mass, the player. If that is correct, we can check for body entered. And if that is the case, we can simply get the tree and quit the game. Now this is going to be quite rare because all of these meshes are fairly far down, but the player should still be a little bit careful. So we are nearly done. In the next part, we have to add sounds and work on a very small shader, but other than that, we are pretty much good to go. It is time to finish up the game. There are 3 major things that we need to do. Number 1, we have to add sound. Number 2, we have to clean up some very small things. And number 3, I want to add a floor shader. That way we get a proper terrain, at least somewhat. All of this we can start with an exercise right away. I want you guys to add the sounds to the game. There are 3 that you want to add, for lasers, collisions, and the background. This is going to work like in a 2D game. Just keep in mind, an audio stream player 2D will become an audio stream player 3D. Other than that, nothing really changes. So pause the video now and see how far you get. Here we are in the project, and if you look at the audio folder, we have 3 files: Explosion, Laser 8, and Spaceship. These we want to play at specific instances. For example, when we are shooting a laser, I want to play the laser sound, which we can do very easily by adding an audio stream player 3D, and then we get the usual stuff, where we want to play an audio stream. This should be Laser 8, and if you play it, you get a laser sound. You can also change the volume. It's pretty straightforward. To play this thing inside of the script, when we are creating the laser, so inside of ready, we also want to get the audio stream player 3D and play it. It's literally all we have to do. If I now run the entire game and shoot a laser, that works pretty well. When the laser hits a meteor, I want to play explosion.wav. Means to the meteor, I want to add an audio stream player with explosion. Let's see how that sounds. Pretty loud. Let's make it a bit less loud, but once again, experiment and see how this works for you. When a laser area entered, we want to play that sound, which means before we are doing anything else, I want to get the audio stream player and play it. Once we have that, I can shoot the laser. Let's hope I hit something important. And that works. Perfect. Finally, inside of the game, I want to have the background music. For that, I want to have a plain audio stream player. The background music doesn't care about the distance to the player. Which, as a reminder, is why we have an audio stream player 2D, 3D, and a plain one. 2D and 3D care about the position. The further away the sound is from the camera, the quieter it will be. The audio stream player, on the other hand, doesn't care about that. This is what we want to get. And for that, I want to have spaceship.wav. Let's see how that sounds. Background music. That is definitely background music. And on top of that, when you are importing the file inside of the loop mode, this is set to forward. If it is disabled or set to ping pong or backward, you are going to get some weird behavior. This should be forward. If it's set to disabled for you, press forward and then click on re-import. I don't have to do it because I already had that setting. And this we want to autoplay. That way we are getting looping background music, which usually should be a bit quieter, -20. Let's try out of this in the game. And that's coming together reasonably well. With that, we have sound. Next up, I want to fix a couple of smaller things. The first one is the debugger is unhappy with us because in onBody entered for the obstacle, we don't use the body, so there should be an underscore. That was a very easy fix. The more important one is there are actually two things we have to work on. Number one, inside of the game, the player can move to the right and simply leave the screen, which does get a bit weird. To fix that, what we can do inside of the game, we can simply add a static body 3D along with a collision shape 3D, where we just need a box shape, and this is going to be a pretty basic wall that needs to cover just about the player. Something like this is fine. And this you want to move to the right, so you get something reasonably large. To test this inside of the game, you want to go to debug and then visible collision shapes. So we can see the collision shapes. Let's see how that looks. You can see a faint blue outline. That's the collision shape. And at the moment, I guess that's basically all right. Then we can duplicate the collision body, move it to the left. And this is quite hard to see, but we do have a collision shape here. I guess if I disable the floor, this is much easier to see. I guess we can go somewhere here-ish. Let's try the game now. And I guess that works also okay. Cool. That way the player is constrained to the actual game. And that makes the entire thing feel much better. Besides that, for the meteors, once they leave the screen, they still exist, meaning we are creating more and more meteors. For that, I want to have a visibility on-screen notifier 3D. If you add that, you get a collision shape that is a basic rectangle, and this should roughly be the size of the meteor. Doesn't have to be too precise. The basics here are totally fine. Something like this. This node simply checks if the node is, well, on the screen or not. Instead of the signals, we can check if this node entered the screen or exited it. In our case, we want to check if it exited the window. Click on Connect, and if that is the case, I want to Q3 that node. That way, the meteors disappear once they go past the player. A similar system might be good for the laser as well, but you can implement that on your own. Those were the two smaller parts that I want to work on. Finally, the last major bit is, at the moment, if you look at the floor, this, well, doesn't really look like a floor. It's perfectly flat, and that just doesn't look good. To fix that, we can write a basic shader. Specifically, we want to create a vertex shader. For that, if you click on the mesh, at the moment, this thing has a size of 130 and a subdivision for width and depth of 0, which means instead of perspective, we are getting basically just these vertices, which isn't really ideal. Via the shader, we want to move some of these vertices up and some down. That way, we're getting a random terrain. But that we can't do at the moment because we don't have that many vertices. To fix that, we want to change the subdivision to, let's say, 100 for X and Y. That way, you can already see we're getting a lot more points. And these points we can change via a shader. You can actually do something interesting. If you click on the arrow on the material, you can convert the material to a shader material. If you do that, then first of all, nothing happens. But if you now click on this thing again, you have a shader, which already has a ton of stuff, which we don't really care about. All that we want to do is add a bit of stuff to the vertex shader. Although all of this is a pretty good way to learn about shaders in terms of what happens under the hood. But not our problem at the moment. Instead, what I want to do via the vertex property inside of the vertex function, you can target the position of every single vertex inside of this mesh. This is going to be a vector 3 that you can read and overwrite. So for example, what you can do is vertex plus equal vector 3, and then you have x, y, and z. Meaning, if you want to move up all of this by 2 units, you simply need a vector 3 with 0 to 0, and then all of this is going to be moved up a tiny bit. There you can see it, especially around the corner. This is the original mesh, and we're moving all of this up by 2 units because of this number. If I change it to a 1, then we're going down a bit, and if I change it to a 10, then we're going up by quite a lot. There you go. That's the basic idea. But this we have to randomize, and for that we will need a random texture. The way you are creating that is, first of all, you want to have a uniform, so you can change it outside of the shader, and then the data type is a sampler 2D. By that, you can create textures inside of a shader. The texture that we want to create is a noise texture. You'll see in a second where this is going. If you add a semicolon, then nothing really happens. But if you look at shader parameters, first of all, we get a lot of stuff that we don't care about. The only thing that we care about is noise texture at the bottom. And there, we can create a noise texture 2D. If you click on that, you get a few more options that we also don't care about. But then, once again at the bottom, under noise, we can create a new fast noise light. Click on that, and then you are getting a random noise. That is actually what we need. This is effectively a 2D texture where we have lots of random black and white values with lots of gray in between. For example, in here, we have a pure white color, and here we have a pure black color. The range always goes from 0 to 1, with 0 being black and the white bits having a value of 1. Or to be a bit more specific, we're working with RGB values, where white color has an RGB value of 1, 1, and 1, and the black color has an RGB value of 0, 0, and 0. All of this you can fine-tune as well. There are, for example, different kinds of noise. And if you look at the bottom options, you can change a few more things. So you can create some pretty funky behavior. In my case though, I want to have simplex. That way we're getting something. And via the frequency, you can scale in and out. This really doesn't have to be too precise. From this texture, we want to sample the colors, which we do via inside of the vertex function. I want to create a float noise sample. To sample a color, we need first of all the texture function, and this wants to have 2 arguments. Number 1 is the sampler. This is the thing that holds the texture. That is very easy. We want to have a noise texture. Then we need the UV coordinates. Those tell us where we are on the texture. In practice, all you need in here is UV, and then you are getting something. Effectively via this, we're getting all of the points on this texture, but it returns a vector 4, so RGB and A, but we need a float. The way you're converting that is simply by looking at one of these values. R, G, or B are all going to be fine. Let's go with red. Grayscale values, like this texture, R, G, and B are going to be the same, so it doesn't matter which one you choose. But effectively now, for every single pixel on this mesh, we get one associated value on this texture. For example, the top left point would vaguely be somewhere up here. Or if you are vaguely here, then you might be on this point, which for the red value would be basically 0. If you are somewhere down here, which would be vaguely here, then you would get an R value of close to 1. And that we can use simply by adding the noise sample to the vertex position. If you're doing that and you look from the side, you can see that now we are getting a bit more of a terrainy look. It's quite hard to see. To make this more visible, we can multiply the noise sample by a factor of 10, and this is going to be really visible. And there you go. This looks much, much better. And I hope you understand the logic here. Basically, we are laying a texture on top of all of this texture here. And then via the position, we are sampling one of these grayscale values and get a value between 0 and 1. If the value is 0, we are somewhere here, meaning we didn't move up the vertices by a lot. But if we are on this bit, then we get a higher value. This would be roughly here in the texture. And all combined, we're getting a pretty cool effect. If you go back to display normal, this is arguably a bit less visible because we don't have a lot of lighting. And also, this shouldn't be that strong. Let's change it to 0.5. This really shouldn't be that tall. And somewhere in there, we have the player. There we go. And right now, you can't really see that. Let's change this a bit more so we are getting something. Always make sure you're multiplying this with 2.0. Otherwise, Godot is going to complain. And now, this looks a bit more realistic, but this isn't going to be too strong. In the game, it might be just about visible. I guess we're getting a slight effect. This is the kind of thing that you want to play around with a lot. Just to make sure we are not breaking the rest of the game, I'm going to set this to 0.5, which makes it barely visible. But at the very least, it's going to do something. And alright, with that, we have the finished game. Make sure under debug, the visible collision shapes is disabled, so it doesn't look too weird. But other than that, you have learned about the basics of 3D game development. You can either continue with the course, where you're going to learn about a 3D platformer and a first-person shooter. If you don't really care about the course, I have also made a Zelda game that goes into a lot more detail about 3D game development. This one is entirely on YouTube, so just check it out if you are interested. In there, I cover a lot of animation logic, a bit more on shaders, enemy behavior, and honestly, a lot of stuff. The video is quite long.